Hello, everyone. Yeah, so it's my pleasure introducing Anshuman Singh sir to you today. So I have been very much honored to be mentored by him and today hosting him for this webinar. So if you don't know him, he has been twice ICPC World Finalist and was part of the engineering team that built Facebook Messenger and one of the initial people who moved to Facebook London. I think that most of you already know him and want to hear from him more than from me. So I will be handling over to him. Yeah.
Hi guys, thank you so much for the introduction, Naman. Today I want to cover one thing which is on how to be successful as a software developer. There's so many resources around that talk about how do you get really effective at data structures, algorithms, problem solving. But the truth is, like, while that is great, what I learned in my life was that when you move to software engineering, you utilize a lot of that learning, but it's a very different battle that you're fighting. So I wanted to share some of the insights from what I had learned then. Just take it as a feedback on some of the things that you should be doing. The way I usually do things is I prepare a checklist every single day. When I'm ending my work, I just check whether I have done well on all of those checklists. So this is more of creating a checklist for all of you guys, and welcome any kind of feedback, anything that you guys might have seen in your career as well. The way I'm going to structure this is actually, let me see if I can share my screen. So I'm going to just share, I mean, there's just the structure for this. The structure is I'm going to first talk about what changes from hard skills, technical skills. I was writing code on a single machine. So for example, somebody told me, hey, I just write a code to find the first 100 prime numbers. I was able to write a code for that on a single machine. How does the same problem, or like what else to do with the same problem when you're writing the code in a software engineering job? So the first part is going to focus on that. The second part is more of soft skills. Basically, how do you hack your growth in a company, right? Like you'll be working with a bunch of different colleagues. What do you do so that you stand ahead of rest of your colleagues? You grow faster at a company. Again, I was fortunate enough to grow significantly fast within Facebook, multiple promotions fairly quickly. And these were the things that I had followed. So might work for you, might not work for you, but I would love to share these things with you guys. All right. So starting with the first part, which is the problems when you're solving it on a single machine and when you're solving it in a distributed environment, they have different solutions. So the first change that you have to do is on how you change the mindset to solve problems when you have the same data on 100 different machines, right? So for example, I'll just take an example here, which is, let's say I told you, hey, there is a list of integers that is given to you and you have to sort it. Now, when you're doing it on a single machine, let's say if you're doing it using your problem solving, it is super easy, right? Like most of you guys would just write a sort function and things are done. In fact, most languages have inbuilt sort. You do a list.sort or sort vector.begin, comma vector.end, and in one single line, your entire array is sorted, which is great. However, think about the case when you have the same list. Let's assume this is a list of a user ID, and every user ID has some score, right? And I have such a popular platform that I have trillions of users. And I mean user not meaning because we don't have population of a trillion people, but let's say assume it's an entity, right? So some entity, and every entity has some score. And I have trillions of these entities, right? And that's why like a single machine is not able to fit that data on a single machine. So that's why I had to split it across various 100 machines, right? And now I say, hey, sort this entire list of entities with respect to score. So that means entities with the highest score should come first and entities with the lowest score should come last. And since it's across machines, so let's say machine 1 has the highest scoring entities, machine 2 like the entities after that, and machine 3 the entities after that, and so forth. Now if you see this problem, I mean, as long as it was sorting within a machine, you can still use a sort function, which you would obviously do. But the problem then becomes, once every single machine has data sorted within them, there is no guarantee that there is an ordering between two machines, right? So then you do some variant of merge sorting, where you pick pairs of machine and then you merge their data So you pick machine 1 and machine 2. You do a merge between these two because they both have sorted lists between them, and then you do a merging with them. Then you might pick machine 3 and machine 4. They will again do merge sort, and then they will be sorted within them. And then that way you build it up. It's a If you search online, you will find this algo, and this again like is not supposed to be a algo teaching class, so I'm not going to go into depth of it. I would love to, but yes, I mean it uses merge sort mechanism to sort it on a distributed environment. But as you can see, like the problem became a very different problem when it was given in a distributed environment. Very similar thing. Like let's take another example. If I say find the median in a stream of integers. Now, as long as that stream of integer fits on a single machine, it's a very standard interview question. You can have a balanced binary tree of the numbers that are coming in, or you can have two different heaps, and then you can derive your median from there. However, when the data doesn't fit in a single machine and it's now split across 100 different machines, then I would leave you guys to do this exercise. It actually becomes a binary search problem. You start binary searching for your median, and those two are again like very different problems and very different solutions. So the first change in mindset is that the code that you were writing on a single machine had a very inherent assumption that everything is going to be on one machine. All of my data is going to fit in my main memory. That might not remain true when you move to a distributed setting. So that's difference number one. Difference number two, all of you here, I can read the chat. So assume that you are working in a company which has this multi-threaded environment, right? So let's say somebody here is working at Amazon. Now Amazon has these Java servers, and it's multi-threaded. There's a code snippet there, which is very, very simple. If X is 5, then let's make Y as X into 2. What do you think is going to be the output of the following code? Most of you would think that the output of the following code, as in like the value of Y after this piece of code executes, is going to be 10, which is true in most cases. However, in a multi-threaded environment, if you have multiple threads doing execution, it is very possible on line number 1, when you checked X was 5, the value of Y, I was asking for value of Y. On line number 1, when you checked X is equal to 5, and for that thread, the value of X was 5 and you went in. But before you could execute the second statement, which was Y is equal to X into 2, there is some other thread that changed the value of X. So for a single threaded, yes, Y's value will be 10, which is 5 into 2. But when you have multiple threads, then the value is not guaranteed to be 10. It is possible some other thread just between these two lines change the value of X. So that is another thing, like the code that you read, they might not behave as you would have assumed them to behave in a normal competitive programming scenario, or when writing code on your simple machine, which was always single threaded. So again, like the resolution there is, you can either put a lock there. I'm sure like if some of you might have studied operating systems, and there were mutex locks there. So you can either put that so that you ensure that there is only one thread executing this piece of code at a time. So you can put a lock on X so that nobody else can change the value of X. Or somebody just suggested that make X as constant, so nobody can change the value of X. Well, actually, you can make X as constant only if that is allowed as part of the application, right? Like if your application, in your application, X was supposed to, let's say, denote the number of online users, then it cannot be constant by definition. It has to change as the number of online users change. So yeah, Mohit suggested like we make this segment synchronized, which is very similar to just taking a lock, which that will actually also work. But I'm just telling you, like the transition that happens, right? Like when you were writing code on your single machine, you didn't have to care about that, right? Like if I said you've written this code and you were debugging this code, and like you look at this, you're guaranteed that Y's value will always be 10 at the end of execution of this block. That's not guaranteed in a multi-threaded production environment. So you have to be cautious of those facts as well. Let's look at the next thing. The other thing that you will realize, and this is again from my personal experience, when I was in college, I used to pride myself on writing code that was obfuscated. I would write code that is obfuscated, hard for other people to understand. I would maybe use certain operations which would be more optimized. For example, for taking the maximum greater than question mark equal to, this performs better, slightly better in C++ for taking out the maximum rather than the max function. But just writing the same code in a production environment is not good enough, because in your company, this code is not just for you. It is for you and hundreds of your team members who are also going to maintain this code. So every single code that you write, you have to assume that you might not remain at the company a year from now. There should be other people who should be able to come and read the code and clearly figure out what is happening in the code. That means your variables need to have very descriptive numbers. And in fact, this is what Amazon also tests for in their interviews, because they want this to be sort of built into you. So they optimize for code readability, because they know that, like, if you have empathy, if you want the other teams to also succeed, you will make your code very readable. So your variable names need to be proper, which denote what they are supposed to do. Your code needs to be readable, in the sense that if you look here in the second part, with the equal to operator, there is space before, there is space after. With less than operator, there is space before, space after, so that the other person can very easily understand what is the variable being compared and against what. Even the function name instead of f, which could be anything, now seems to be more descriptive. Instead of writing m greater than question mark equal to, now we are using the max operator. So you have to, as you move from a competitive programming environment into a production environment, you also have to write code that is actually readable, that people can understand quickly. That also means you have to document your code. I'll actually come to that right after this. There's another thing here, which is code duplication. Now, this is something which doesn't come very naturally to us, but I'll actually tell you what happens in actual scenarios. Let's say I had written these two functions. The first function is just checking whether a user has passed the course or not. And let's say hypothetically, a user passes the course if their score is more than 1,000, right? So what I did was I wrote some code to calculate their score, and then I checked if the total score is more than 1,000. Let's return true, otherwise return false. At the same time, let's say there was another piece of code somewhere that wanted to calculate user score. So I wrote another function which was find user score, which that did exactly this. So the exact same code has been replicated here, and I'm returning the total score here. Now, hypothetically, let's say I figured out that there was a bug in this code. Now I have to fix that bug at two different places. Imagine if I would have replicated this code 100 times at 100 different places, I would have had to go and change code at those 100 different places. That means if let's say I want to just change this to say that total score now is not absolute, but it's relative. That means I would rank every user. The highest user gets 100, the second highest gets 99 or whatever, and then like so forth. For changing that, I will have to change the logic at each of these places, which is very cumbersome. That means that as you move to production environments, companies try to optimize for reducing duplication of code. So they would rather want that any code that has been duplicated, you create a function for it, and then every single reference point is calling that function. So then when you have to fix that code, you only change that function. So there's only one place where you're changing the code rather than 2 or 3 different places. This again is not very important in a competitive programming, because as long as the code works, as long as it gives the right output, everybody is okay with what you wrote. But as you get into a job, this becomes important, and this is something you should keep in mind. Let's look at the next thing, which is what I was saying in just the slide previous to us, is like the code should be readable. At the same time, you should document your code. Now, this is the mistake that most top programmers make. They believe that documenting the code is a waste of time. Why should I be documenting my code? This is completely non-productive. It's not getting a new feature out. The truth is that you're writing code not just for now, unlike competitive programming or participating in contests or participating in a hacker rank test. You're writing code for the next 5-10 years. If let's say you go and work at Amazon, if you go and work at Microsoft, if you've written really beautiful code and your whatever you worked on is still functional, it will probably be there even 10 years from now, 20 years from now. And that is what you should try. I mean, your whatever code you write is your baby. It's your production, right? You would want that to be with people. Even 10 years from now, people should be able to say and see and say, for example, that this code was written by Archit or Bhupendra or Arshad or Aditi, right? And you should feel proud about that. So for that reason, it's very important that you document your code well. So even 10 years from now, if somebody comes and reads your code, and they will be able to understand the code fairly well, they look at the structure of your code and they say, person who wrote this code was really had cared about me, because they took this additional effort to help me understand what this code is doing. And that's when nobody changes your code. To succeed in a software engineering job, there are two things that happens, which is unlike what you do in college. Code reviews. Whatever code you write, nothing goes into production till somebody has reviewed your code. Somebody will review your code and leave you advices on what mistake you made. Make sure that every single code review that you get is a learning opportunity for you. Ask yourself the question, what did this code review teach me? And you should be willing to give it back as well, right? So become a master at code debugging. In fact, even today, if you're in college, look at code samples from different people, help them debug your code, because this will help you when you go and join a job. Code debugging is important. When you do code reviews, if you're not able to pick out on bugs by reading through the code, it is possible that a buggy code goes into production and it breaks your system. Let's say if you were building Messenger, it would be, and you were the owner for it, you would be really sad if somebody wrote a code and you were not able to figure out the bug there and it went into production and Messenger was down. So you would want to become a master at code debugging. All right, so let's go to the next part, which is now the other thing is, a lot of us judge each other by just the knowledge of data structures and algorithms. I remember, I mean, when we were in fourth year, people would compare each other on who knew how much on data structure and algorithm, or how much research somebody was doing. I mean, those were the two parameters on how we would compare each other. The truth is that while data structures is really good to help you be effective at your job, it is not enough. It is not enough at all. And one of the couple of examples I gave, right? Like one was a multi-threading environment, one was this distributed environment. Then there are other aspects, like for example, there is high-level design, and I'll give you an example for that. So let's say somebody told you that build a system which can shorten my URL, which is what you call as tiny URL, right? Like I have this big link. Can somebody shorten it and give it to me so that I can share it at different places? And when people click on that link, then they get redirected to the right big URL. Like the service is very simple, right? Like anytime somebody requests you to just shorten a URL, you generate some random code. You make that tinyurl.com/that code, and you return that tiny URL. And when somebody tries to access it, you just, since you have stored that, now you also have to store the tiny code to actual URL mapping. Since you have stored that, you can look it up and then you can return the right thing. Now, think about the case when your system has grown so big that all of the mappings that you have, which is your tiny URL to the actual URL, all those mappings cannot be stored on a single machine. Right? So my machine, let's say the laptop that I have, it's a 1 terabyte laptop. I have generated so many entries that now my laptop is full and I cannot store the entries here. So in that case, let's say now I have two machines that are storing this data now. Some of the data is on machine 1 and then some of the data is on machine 2. So when somebody asks me, hey, what is the URL corresponding to the tiny URL, let's say XYZ, then I search whether XYZ exists on machine 1 or machine 2. If it exists at either of those places, I look up the corresponding entry and I return it back. Very simple. However, let's say somebody comes and says, please shorten a URL for me. Now, when I shorten the URL, let's say the code that I generate was ABC. Now, before I store it, I want to be sure that ABC has already not been generated before. So I go and check in DB number 1, which is machine number 1, and I go and check in machine number 2. Let's say I did not find ABC. And now I proceed to write ABC in machine number 1. It is very possible at the same time there was another thread on machine number 2 that was doing the exact same thing with ABC. So it also checked machine 1 and machine 2, and it found that there was no ABC in machine 1 or machine 2. And as a corner case, both machines have now an entry for ABC. That becomes a problem, because when somebody comes and now asks you for what is the corresponding URL for tinyurl.com/ABC, now you have two conflicting entries. There's one entry on machine 1, and now there is another entry on machine 2. That means there is a consistency problem. So these kind of problems arise when you are working across different kinds of systems. Again, I know I would have loved to go into depth of this case study, but again, this is not really a study on high-level design, so I can't go into depth. But all of this comes as part of system design or high-level design, right? Like you're trying to design systems, design components, so that your system is foolproof against any kind of consistency issues or availability issues. You do it when you're designing large-scale systems. Very similarly, there is a area of study which is called low-level design. This is that once you have figured out your components from high-level design, how do you structure your code so that it is, when you have to add a new feature or when you have to add a new object or a new actor, for example, let's say take Amazon, right? Amazon might have a tons of feature today. When they have to add a new feature, how should you design your code so that the additional amount of work to add a new feature is as less as possible? I'll give you an example, and this is again a very rudimentary example, nothing to do with the real world. But assume, let's say somebody said, hey, actually write a code where you design this creature called lion, and lion can eat, drink, walk, and sleep. So you write a code and you sort of define how eat works, how drink works, how walk works, how sleep works. Now tomorrow somebody else comes and says, now I also want to support a dog who can do exact same things: eat, drink, walk, sleep. In your format, you'll have to duplicate the same code for a dog and then redefine those functions. But it is possible dog and lion might have some similarities. Maybe they eat the same thing. The eat function looks exactly the same. So in the current case, you're duplicating code. But if you use OOPS principle, which is object-oriented programming principles, you can probably define a parent class which was animal, and then lion could have been defined there, and a basic eat, drink, walk, and sleep function is defined for animals. So as you add more animals, you probably don't even need to implement certain functions. Those just get carried forward, right? So your additional effort of adding a new feature or a new actor becomes significantly less. This is a different area of study altogether, which is called low-level design and design patterns. There are a bunch of books on that. We'll actually post links to certain books that you can read on your time on design patterns. Some of the design patterns are builder pattern, which exists in Java, factory pattern. Builder also exists in Python. There are singleton patterns, and so many more features, design patterns. And different design patterns are valid for different use cases. The third thing is, which is also, by the way, checked in interviews as well, is how do you interpret questions? Can you gather requirements? For example, let's take the same example of tinyurl, right? So I say, hey Archit, why don't you build a tinyurl, right? And Archit says, great, very easy. I'll build this service that stores the tinyurl to actual URL mapping in a database, and I will return whenever somebody says, give me the mapping of tinyurl.com/xyz. I look up the mapping and I return the actual URL. Great, all done. Now tomorrow, the person who had actually asked you came and says, hey, I actually want to see statistics. I want to see who is accessing which URL, what location are they accessing it from, what browser are they accessing it from, which age group is going to what kind of URLs. And you say, shit, I haven't built that. I'm not tracking when people are requesting, who is requesting. I'm only tracking tinyurl to actual URL mapping. So you forgot to store it. You lost all of that data. And when you lost your data, then there is no way to recover it, because you can't replay what happened in the last 7 days. So, but if you knew this requirement before, if you knew that statistics was important, you would have designed with that in mind. So when somebody gives you a problem, and in real world, in your job, usually problems are going to be not as well defined as you get in a competitive programming, right? Like competitive programming has everything defined. It gives you limits. It tells you what cases are possible, what cases are not possible. But real world problems are not that well defined. When you're defining Uber like cab service, you don't know, like at what speed cars might move. Maybe the driver goes to sleep. Maybe people are not reachable. There's so many different corner cases that nobody told Uber in the beginning. They had this big scandal that happened in Delhi that was never specified as part of the problem. You have to go and gather all of those requirements. You have to foresee a lot of these corner cases yourself. That is what would make you more effective as a software developer, right? Never jump to solutions. The first part is gather requirements, understand what the end user might want. The other thing is, a lot of us think, and this is just a myth, that CS fundamentals are not important. As long as I have done well with data structures and algorithms, I'm going to do well in my job. The truth can't be farther away. All of what you learn in as CS fundamentals in operating systems, networking, databases, everything gets applied. If you do not understand databases well, then you'll not be able to create the right indices. You'll not be able to create the right schema. You'll not be able to make the right choices. If you do not understand operating systems, then these are very common problems. If your code base is in C++, there's so many times that your application would have some kind of memory leak. Memory leak is basically when you're allocating an object. For example, you can say that A is equal to new int whatever, but you forgot to free A. So free the memory that you allocated for A. So it is very possible you have memory leaks, and then you do not understand how to debug those memory leaks. There are these softwares that help you analyze the memory and what kind of objects there are. But those softwares don't tell you like this object is of type this, it was declared on this particular line. That is not what they will give you. You will have to understand how memory is managed, how paging is done, to be able to make sense of that information. Java, for example, has garbage collection, right? So Java doesn't care about memory leaks. Java says, hey, actually, I'll maintain references to objects that you create. Whenever an object does not have any more points of code referencing it, I'll automatically, my garbage collection will kick in and it will free it. Now, garbage collection would has different kinds of variables, different kinds of lives of variables. So how do you tweak your garbage collection for your application? Because there are different kinds of application, right? There are certain applications where you want your requests. You have a lot of parallel requests, and in parallel, they are very low on memory footprint, and they get executed quickly. At the same time, you have these requests that might be very heavy, right? For example, I want to fetch my newsfeed in Facebook. Now, fetching a newsfeed for me, if I want, let's say, 100 different items in one go, that is very heavy on memory, right? Because I am getting like 100 different posts, along with number of likes, the content, and a bunch of links that might be in those posts. So, even understanding that for my kind of application, how do I need to tweak garbage collection? That also requires you to understand memory management well. That requires you to understand how is memory managed inside, let's say, a Unix operating system. So again, like CS fundamentals are important. Just busting a myth here. I heard somebody say it, so I wanted to make sure you guys understand that if you have to be successful as a software developer, CS fundamentals are important too. All right, this is the biggest myth that I have seen with people around me. When people move into their new jobs, they believe that writing unit tests is beneath them. It is somebody else's job. Somebody else should come and do it. It doesn't help me build a new feature. I should just be writing code, building a new feature. Why should I go and write test? Problem is, you write tests so that no other person, and you have to assume that There will be people who will not have the same kind of understanding as you do. There will be people who will not test your part of the code. They change something else for their own use, and your part of the code got affected. You want to write tests to make sure your part of the code is not affected. For example, the earlier case that we took, that there was a function that calculated some user's score, right? And let's say for my part of the code, I wanted that the scoring function gets changed a little bit. So I make some tweaks there. But that function could have been called from 99 other places as well. There is no way to guarantee that those 99 other places are not affected and something doesn't break. So you write tests. If you were one of the persons using it from one of those places, you write unit tests so that when this guy changes this function, your unit test immediately starts failing. And somebody comes and tells this guy, hey, dude, what did you do with the code? This unit test is failing. You should go and fix it. So the writing the test helps you with the initial parameter, which I told you, which was make sure your code is written to survive for the next 10 years. Even in 10 years, there are people looking at your code and admiring what you did. If you write tests, that is going to happen. If you do not write tests, then somebody or the other is going to come and break your code, and then somebody or the other is going to come and change your code. So your code will not survive 10 years. All right, so we're done with the hard skills part. I'm going to finish this part quickly, and then I'm going to take questions from all of you guys. Just please take notes about what we are discussing today, and then I'll take questions. Now, software aspects. This is more of how do you hack growth within a company. The most common mistake I see people doing is that they believe that their manager is somehow always judging them, and that is why they don't open up to their manager, and they crib कि my manager, यार मेरा manager ऐसा है, promotion नहीं दे रहा है, यार मेरा promotion हो नहीं पा रहा है, I don't know what is going wrong. Just translating it in English, I mean, they crib that the manager is at fault for not promoting me. My manager hasn't been helping, or like I'm not being promoted. I'm extremely unhappy about that, right? You need to make sure you're talking to your manager very clearly. In fact, the conversation that I used to have with my manager was, look, I want to get promoted as soon as possible. Tell me, what do you expect me to do to be promoted? And the answer there was, in Facebook, there were levels defined. And the answer there was, as long as you're doing what is the duty of the level above me, if I am already doing that, then I can be promoted. So the manager would very clearly outline for me, look, here is what you should be doing if you want to be promoted. Again, I'll give you my personal example. So the first promotion, I joined, and I had asked very similar question on the second day of my joining my team. And my manager told me, look, here is, I've seen you in the first 2 days, you've been writing code for this particular component. If you start owning this component end to end in the next 6 months, I'll get you promoted. So then I knew what I had to do. My manager was my friend, and he was helping me and sort of helping me draw a path to how do I get promoted. You guys should do something very similar, because your manager's job description is to help you grow. The job of an engineering manager is to help their reportees grow, to help them perform better. The manager is there to help you. They're not there to always judge you and stop your movement upwards. So that's the first thing. Second thing is, the second mistake I see people doing is they demand ownership. They say, I want to work on this component. Please ask the other guy to not work on it. I'll do it, and I'll own it, right? For example, let's say there is a service within InterviewBit, which is, let's say, takes care of engagement. Maybe let me take a different example. Let's say there's a part of the InterviewBit that takes care of how mentors function, how the sessions are done, right? Now, if somebody comes and says that I want to do it, and please remove the other people who are working on the mentor piece of code today, I want to take ownership, then that usually is not really executable, because if I go and remove the other person who are working on it, what explanation do you give them? The solution there is that if you really are interested in working on something or in owning a component, you start contributing there. You start looking at what is broken there, you start fixing it. Over a period of time, you would have made so many changes to the component, which are again like to on the positive side, that people would automatically start seeing you as the owner of the component. They know that nobody knows that component better than you do, and then you automatically become the owner. You don't need to ask anybody. So don't demand ownership, earn ownership. That was lesson number 2 on the softer skill side. And when you do this, like, you start be doing better than your peers automatically. You don't really have to go and demand things from people and or start a fight because you were unhappy on something. The third mistake that I see people do, and that is on both sides, getting feedback as well as giving feedback. I'll actually address the giving feedback part first. Most of us, when we graduate out of university, we are very raw, right? Like, you talk to your friends in a very informal fashion. You even abuse your friend, and your friends are okay with that. If something is wrong, you're very okay being very harsh to them, and your friends, being friends, they understand. However, that doesn't work in an office like scenario. Look, I mean, you might go and join a company. There might be 10 other people that you don't know of who might have joined along with you. And there might be people who are senior to you as well, right? Now, when you see something which is broken, or when you see somebody who has made a mistake, and if you really feel very strongly about what you're building, if somebody made a mistake and, let's say, created a bug in your code, you would feel really bad about it, and you'll go and give a very harsh feedback. You don't know anything, tumhe kuch nahi aata hai, kya kar diya tumne mere code ke andar. And but the thing is, when you give a feedback like that, that feedback is not constructive. You're not helping the other person understand how not to repeat the same mistake again. And especially when you attack the other person, they then start holding vendetta against you. They rather, instead of improving, they start thinking ki, how did this person talk in that tone to me? I will show him. I will do something which will hurt him. You don't want that to happen, right? Like, your the reason why you went and gave feedback to somebody was not to create enemies. So there is a very simple framework of giving feedbacks. This was actually created by McKinsey. So the simple framework is, when you are giving feedback, do not express emotions or opinion. The first part of the feedback should only be facts. For example, I'm going to take an example scenario so that it makes sense. Let's say InterviewBit actually hires problem setters to create some problems for contests, or let's say like assignments within Scalar Academy. Now, let's say I have hired a problem setter, and I had asked the person to create a problem for a contest, and it was a very, very important contest. So the person created a problem, did whatever they could from their end, but in the contest, let's say the problem broke. It had wrong test cases. So we fixed it, but like, obviously, like, that was not a very good thing to happen, where like you have this very important contest happening and there was a problem which was broken. Now, there are two ways of handling it, right? Like, I go to the person and I start saying that, hey, you are so incapable. You couldn't even handle setting a problem for this contest. I had told you this was a very, very important contest. Why couldn't you have tested it properly? And all of that. The person actually gets angry. The person becomes starts holding negative feelings about me in their heart. However, if I go and just tell them fact, if I tell them, hey, person X, you had set a problem called ABC for this contest. That is a fact. The person cannot deny it. ABC had a problem in the test cases, and we found that out during the contest. It was not fixed before the contest. What I feel is, we should be more diligent going forward. And the way to do that is, maybe we should be testing them by writing solutions in different languages and checking whether those pass or not. Now, when you give the feedback in that tone, the other person knows that you're not expressing your opinion or emotion, but you're rather telling them facts, and they cannot hold a grudge against you for stating facts. So your feedback should always be driven by facts, and then maybe corrective actions. And be willing to discuss corrective action with the person. When you're getting feedback in a very similar way, you should always be asking for feedback. I mean, even when you know you're doing well, you should go and ask your manager, your peers, hey, how am I doing? Do you think there's something else that I should be doing differently? And there would be people who would not have seen this presentation and will give a very harsh feedback sometimes to you. And in those cases, make sure you don't take feedback on your ego. to understand the underlying reason that somebody is giving me feedback is because I did something wrong. How do I fix what went wrong? How do I figure out corrective action for what went wrong? If somebody is giving me feedback, one very common thing that we do is we get defensive. We start saying, "अरे नहीं, but ये ऐसे नहीं, actually तो ये ऐसा हो रहा था, इस वजह से ऐसा हो गया. It wasn't my fault. I actually had good intentions, but look, the situation was like this, which is why it happened." Don't get defensive. Let the other person complete and try to reason. Maybe there was a mistake on your end. Whatever little, accept that and say that, hey, I'll figure out a way of fixing that going forward. When you do that, then you improve over a period of time. If you get defensive, if you never accept that you make a mistake, look, all of us make mistakes. If you do not accept, you will never improve. So always get feedback, never take it personally, and figure out corrective action. While giving feedback, be very polite, state facts, and state corrective actions that you feel. When you do that, you will move up the ladder because people will like you. You don't want to create enemies anywhere, especially so in your current company, right? The last thing, I promise this is the last thing. As I said, be nice, be respectful, do not create enemies. Mostly you would have to work in teams, more so because teams can get done a lot more than you can individually do. The third thing which a lot of people do is they spend too much time on counting how many lines of code I have written or how many number of hours I've spent in the office. Don't do that. Look at impact. What should I do so that, let's say, my product becomes better, more people start using it, and state that. I mean, when somebody asks you what have you done in the last 6 months, there are two kinds of people. There is a person one who would say, I have written 1,000 lines of code in the last 6 months, and I have gone and done these many meetings, and I have done some X and Y and Z. And there's a second person who would talk about the change that brought. That person would say, hey, actually, in the last 6 months, I have increased the number of users using the product from, let's say, 100,000 to 200,000. I have reduced, let's say, latency or the time that the service used to respond back with by let's say 100 milliseconds. So when you state impact, that's a very positive sign for the person who is asking you for what you've done, right? Like, managers usually optimize for impact rather than what number of lines of code you wrote or like how many number of hours you spent in office. And the last thing is, and this is again like something which was very common within Facebook, there was a very term which would go around, which was growth mindset. Always think about growing, no matter where you are. You might be the CEO of a company, you might have already become like this VP of your organization. Even then, always keep thinking about what do I need to do next so that I grow. Have a growth mindset. And usually growth happens when you learn new things. So prioritize learning new things. Never be afraid to take risks. Maybe today I am coding in Java. This new company that looks very exciting codes in Ruby. It's okay. I'll learn Ruby and then I'll be able to go and do well there. So do not be afraid of learning. Always prioritize learning. If you are capable, then everybody would want you. The best job guarantee is capability. Nothing else can give you job guarantee. Jobs go away. People get laid off. But a capable person is always in demand. So always focus on growth, learning, building capability. If you're capable, you'll always be in demand, and as a result, you'll end up making a lot of impact as well as a lot of money. Both happen in parallel. So that is all from my side, guys. These were my learnings, personal learnings. Again, there are some of you who might have had different learnings, but I would love to take up questions as well. And
Yeah.
Naman is also here.
Sure. Thanks, Anshuman. So guys, I will be taking questions from Slido, and you can post your questions here in this link, or the link is present in the description of this video. So we will be taking questions from there, or you can put your questions in the comments. I will be taking from both these sides. Okay. So let us start with the questions. The most popular question we have is that for CP, we mainly focus on algos and TS, right? But what topics should one be proficient for building large scale systems? I think in the chat you mentioned about high level design and low level design, but is there anything specific in them? How to learn them? And also, I mean, like an extension to this question is a question from a person who is not from a CS background. So,
Hmm.
as you mentioned, that CS fundamentals are important, and the high level and scalability things are important. So, how can he learn those things?
Right. So usually, like, there are people who learn in two different sets, and like there's some people who find it easy to learn on their own, like being very motivated all throughout. For them, I mean, if you want to learn, let's say, high level design, there are a bunch of resources on the internet. There are some very good books. We'll post links and resources just after this session is over, where we would give you links to some of these resources. In general, like, there's a blog called highscalability.com, which discusses the architecture of different websites, how have different companies scaled. So will post resources there. You can go through it. And there is a second set of people who might not have the same background as other people, and they might not be able to understand these resources at the in the same fashion as somebody else might. There are a bunch of courses that are there all around. I mean, there are some paid resources. For example, educative.io has some good content on high level design. Scalar Academy at the same time does very formal a course with proper teaching material on both HLD and LLD. So you can join Scalar Academy. That also will help you. At the same time, like, when it comes to CS fundamentals, now people who come from CS background, who have spent time in colleges, they have gone through formal coursework of doing that. Even if you're not, that doesn't put you at a disadvantage. There are still ways of learning it. And to be honest, like, you don't need to go and read the entire book for operating systems. There are certain things that get used more often than not. Anyway, so when it comes to learning CS fundamentals as well, again, like, Scalar Academy addresses that piece as well. But if you're again interested in learning on your own, we'll post some resources for CS fundamentals, HLD, LLD. These are free resources on the internet. You can go and read up there. If you're able to understand and go through all of it on your own, it would suffice. If you struggle consuming the content, then you should look at certain courses, paid courses that are there, which have live learning and which have mentors who can answer your doubts, which will help you understand these guys.
Sure. So the next question is, during the session you had discussed that how building systems is different from competitive programming. But if we have to talk about some skills from competitive programming that helped you at Facebook, were there any skills from competitive programming that helped you there, and what were they?
When you do competitive programming for a while, there are two or three things that you learn to do. One is, if you look at development cycle, let's say Sachin is a developer, right? And if Sachin is spending 10 hours developing something, the typical pattern is people write code for 2 or 3 hours and then they debug the code for the next remaining 5-6 hours. Majority of the time is spent on debugging. So if you've done competitive programming, if you keep writing code very often, I mean, you do well in competitive programming if you make less bugs. Like, you're able to get your code right in one go. I mean, your code compiles, runs just in one single go. So one thing which you get really good at is writing bug-free code. So your efficiency as a programmer goes up, because you've written these complex codes and which have run in the first go, right? So one is writing flawless bug-free code, saving you time on debugging. Two is that when you're working with a very large system which has a large code base, the one skill that you really need is that you go through the code once and you're able to understand what is happening in the code. And then, like, again, the more coding and the reading through other people's code you have done, the more skill you develop. So that also helps. That being said, most of the principles that you learn in DS Algo, for example, like, we would solve a lot of problem on network flow, max flow. All of these were not utilized in the dev work. But like the process to get there, the process to understand all of these principles, they help because it got me to a position where I could write bug free code. I could understand code quickly because I had just seen so much obfuscated code in the past.
Sure. So there is a question that how to deal with repetitive or the work which we don't like in project. I think you were fortunate enough to work on projects that were making an impact and probably you liked it. But many people are not at that situation. So how can they deal with that and learn alongside it?
Right. So yeah, that is again another another problem with a lot of work. I mean, and that happens with all kinds of organization. Even if you are studying at, let's say, or you're working at, let's say, Amazon, it is possible like there are certain teams that have very repetitive work, which might not give you enough opportunities to learn. I would say even in those cases, if your work is repetitive, the good thing is like your work isn't very challenging. You can finish your work quickly, and then focus the rest of your time to figure out what are the things you can do to upskill yourself. Right. So, as I said, like learning. I mean, when we talk about, for example, high level design, not everybody gets to design components. Not everybody gets to architect these high traffic systems. If there are 100,000 developers, then probably 100 out of them get that opportunity. That being said, if you understand that, that makes your transition into an SD2 or SD3 or an architect faster than everybody else.
Okay. So there have been some people are asking what are some good books how to develop that growth mindset. Do you have any book recommendations for that?
Actually, there are a bunch of books. Somebody actually in the chat had posted the 80/20 thing. I actually, on the growth mindset, I have never read a book, but it's been more through my own personal experiences talking to people. That being said, there are books like Zero to One. Zero to One is actually a very strange choice because it talks more about startups. But if you just read through the book, you'll understand like how the psyche is around growth most of the time, how compounding works. Even if I'm growing by 2%, 3% every day, that compounds to become a huge number over a period of time. So I mean, I'll actually research and then maybe suggest books. Right now, in my personal experience, I did not have to read a book. I just experienced that through people around me.
Okay, so there is a question that when to say that it is done with a company, when to quit a company. Is there any particular situation that happens that you just decide that nothing more is possible here? So when to quit?
Right. So if you're in a job and you're thinking of quitting, there are a few things that you should consider, right? So usually why people should stick around for more time in a company is because if you keep switching very often, you don't get to learn enough, because usually when you go and join a new company, it takes you about a month or two to get used to how things happen in that company. And for you to actually build something which has enough impact, it takes you about a year. But let's say you entered a company, you saw that, hey, actually, the culture is really bad. Usually, if you're in a situation where there is a lot of politics and people who butter up their managers get promoted, other people do not get promoted in spite of the contribution that they're making, then it's probably not the right place for you. You should look at moving out. If you're going and talking to your manager about these things and how to progress forward, and the manager is dissing you, you're not willing to cooperate. Good organizations do not have those attributes. They look at investing in every single employee. They want to optimize for every single employee's growth. If you are at a place where people are willing to invest in your growth, then you should stay there, because even though today you might be in a project where you're not getting to learn a lot, it is possible when you talk to your manager and you express your concern, the manager might be able to draw a path for you where you move to a project where you might get to learn a lot.
Okay, so there's a doubt from a person who probably is shifting from a startup to a MNC. Says that in a startup, focus is on speed of coding and not much on code quality. And now, suppose he is trying to shift to an MNC, will it be a problem? Because in MNCs, there is a lot more focus on code quality. So, is that a hindrance or is that a problem?
Yes, initially there will be. Initially, probably for the first 1 month or so, you'll see that there is so much more something that is getting to code quality, and you'll feel frustrated by it because you wrote a code, you know it works. Now somebody is telling you to go and change that code. You did some changes to code. Some people came up with other suggestions. Then you change that as well, and there's just so many much back and forth happening on the code reviews, which causes frustration. But believe me, it's just there for going to be there for about a month or two at max. Post that, you'll get into the habit of writing code that is structured, and that is actually good for you. I mean, like, understanding how to write code that is of very high quality, that is good for you. What is going to happen though is, like, depending on what team you end up at your MNC, the amount of impact that you were able to make at a startup versus the MNC, that might go down. But again, it's dependent. It's dependent on, like, which company you are at, which team you are at.
So there's a question on any advice to freshers on what to focus on early in the career, and an addition from my side, what not to focus as well early in the career.
Got it. By the way, today's session was primarily on things that you should focus on, what you should focus on, and what not to focus on. For example, bad thing to focus on is Hindi में एक word होता है शोषा, which is just like how flashy a company is, but doesn't really focus on getting people the right amount of learning. For a fresher, I mean, I would always say you should optimize on learning. Maybe you join a company and you figure out that the company is not helping me learn a lot. So then you talk to people around you, figure out a path on how do you get to the learning path. But the first 2 or 3 years of your career, the first 2 or 3 years when you join a job, they are formative years. That's when you are experiencing software development in a real life production environment for the first time, and that's when you start forming opinions. That's when you start, I mean, imagine you're a baby, and then, like, you're learning how to walk, how to run, how to stand. You want that the people who are teaching you those things are the best people, and the company where you're getting to learn all of this is best, and you're learning the right things, right? Like, you're optimizing for learning. A lot of times what happens is you go into a safe company, but in the first 3 years you don't end up learning enough, and then you see that there is a batchmate of yours who also has 3 years of experience, but that guy actually knows a lot more than I do, and then that's not a great state to be in.
Sure. So the next question is, what were the most challenging situations or tasks that you faced and were able to resolve in your professional life at Facebook or interview bit?
At interview bit, it was actually just dealing with people internally as well as externally. I mean, all of what I'm able to tell you today is my learning from the past, and I wish somebody had told me all of this before. All of this I had to try and do and fail and then learn, right? For example, the entire thing about the framework of giving feedbacks, I've been at the other side where I've given feedback to people harshly, just because, I mean, when things don't happen, you get angry, right? And then you shout at somebody, or you give them a feedback in a very, very rude tone, and then you realize after introspecting that that maybe was not the right way of giving feedback. How do you handle, I mean, machines are easy to handle, humans are not. Humans have emotions, humans have aspirations. So managing people, that was one thing which was extremely challenging for me. uh, Two was, in general, even the growth mindset that people talk about. I remember there was a phase of 6 months, even within Facebook, when I couldn't focus on the right things. I would be focused on short term things. For example, let's say I am leading the reliability and latency team for Messenger. So there were occasions when I was focusing on slightly short term benefits, and I would just over optimize for that. I would spend a lot more time that was required, versus not focusing on something which maybe required a month to do, but would have much bigger impact. Maybe it would have reduced the error rate to 1/10 of what it was. So prioritizing the right thing is something, again, which it took me time to learn. Slowly I developed that. I remember an incident actually from my college days, from the competitive days, and like, I was reading through some of the messages, so I was able to see what changes have come. So in my competitive programming days, there was this coder called Triple M, who was a very, very helpful coder. That person would actually help out everybody who would approach them. I remember when I was just getting started. I just like some of the other coders had reached out to him for help and figuring out why my code was not working. And Triple M was again very busy man, so he did not reply. After a while, I again followed up. The person replied saying that he doesn't have time, and I wrote a very harsh and rude message to the person. It's now that I realize that maybe I mean there is a better way of handling people. There's a better way of giving feedback. There's a better way of managing expectations. I mean, person was doing me a favor. Why should I be rude or harsh to the person? So these are things that you learn with time. My major learnings is handling people and prioritizing the right things, long term things other than short term things.
So a question is, what is the benefit of staying in a company for long period, even when you are not getting much hikes? Are there any benefits to stay? And what are the disadvantages of switching companies often?
If you switch companies often, then you usually, like, let's say if somebody comes and interviews at interview bit, I ask them what is the impact that they have made in the previous organizations. The If you switch too often, you'll never have a good answer to that question because you haven't stayed at a company long enough to change a lot of things. You cannot say that, hey, actually I worked at, let's say, Grofers for a while and I was able to increase their order volume by 20%, or I was able to increase the number of people visiting the site by 10% by the changes that I did, or I made the site faster by 20%. Right? You'll never be able to say that because you've never spent enough time understanding what is happening within. And Grofers is just an example, guys. Please do not quote me there. I just took a random example. So you never spend enough time within Grofers to understand how things are working there and change things for the better. But if you spend enough time, then you're able to create these impacts, and then you're able to talk about them when you go outside, right? It is okay if you're not getting hike initially, but if you know a lot more than somebody else who might be at a higher salary, then salaries would auto adjust themselves. As I said, like, capability is the best job guarantee. Your current position is not. There are CEOs that keep getting fired here and there. There are CTOs that keep getting fired here and there. If they know the right things, if they are actually the best capable people out there, then they get rehired. Otherwise, they go out of job. You don't want to be the person who goes out of job.
So a question is, how often should you ask feedback from your managers? Is there, I mean, like whenever you want or anything like that?
So I usually had the framework of I had set a one-on-one with my manager to happen, a formal one-on-one every 2 weeks. So every 2 weeks, I had reserved this 30-minute slot on my manager's calendar where I would make sure that I talk to my manager for 30 minutes. And the theme of that was, talk to me about things that I'm doing well, talk to me about things where I need improvement. And again, like, re-stressing on the fact, look, I want to move to the next level. What should I be doing? What am I doing wrong? What am I doing right? Tell me what else should I be doing? So the whole reason why you want to do this is because you never want last minute surprises. You might believe that I am performing really well. You do not want that at the end of the year or in 6 months, whatever is the frequency of review, your manager comes and says, hey, actually you were a bad performer. You don't want that happening. You want your reviews to be as surpriseless as possible. Whatever the review, you knew it was coming because you've been talking about that for the last, I mean, every 2 weeks anyhow.
Okay, so let us take the last question for the day before we end. So do you suggest a depth first methodology to learn, basically go into depth of each topic, system design, a programming language, even data structures and algorithms, or a breadth first approach is better? I mean, like, have a high level overview of multiple topics, but being master of none. What do you?
Actually, there are both kinds of engineers, and both end up doing well. There are people who specialize in something, in the sense that there are some people who become, let's say, a data engineer, or a systems engineer, or, if, well, even within front end engineer, like, specific on a certain tech stack. And at the same time, there are engineers who you would call as generalist. Both are in demand. Both are good positions to be in. But do whatever you're doing, either depth first search or breadth first search, really well. I mean, it's don't go half-hearted at any of those. Even within breadth first search, there's one caveat: make sure you know enough. Do not. I mean, there's a phrase in general when explaining things, which is called hand waving. Hand waving means that you know of certain terms, certain fancy terms, and whenever somebody asks you a question, you use those fancy terms to explain without really understanding what is happening beneath. So if you know less, that is okay, but whatever you know, you should have very solid knowledge on it. Always question what is happening, and never have superficial knowledge where you're just hand waving. Even within breakfast, you need to manage that too. So both approaches are fine as long as you're not doing hand waving in any of those approaches.
Sure. Thanks a lot for taking out your time today. I know it's a weekend and still you took a time. Thanks a lot. So thank you guys for listening to us. We will be posting the books and the other resources in the comments soon. And yeah, have a good night and enjoy. Bye bye. Good night.
Thank you so
Sure.
much. Thank you so much, guys, for being patient with me and bearing with me through this session.
Definitely, advices that you gave today will definitely help me in my career as well, and hopefully to the listeners who all saw this video. Thanks again.
Very quickly introducing what we're going to cover today, right? So today we're going to talk about sorting. And why is sorting important? I mean, sorting is essentially nothing but arranging data that you have in a particular order, right? For example, if I have a few numbers, I could say I want to arrange them in an increasing order. Or if I have people, let's say I want to arrange them in the decreasing order of their height or increasing order of their height, etc. The ordering, because you are able to order something, helps you in a lot of things. For example, sorting might then help you do binary search on that data if you want to look for something. Or if I give you queries around, hey, tell me how many numbers are bigger than a specific number. That also, I mean, if the array is sorted, you can just look for the index of the element, first element bigger, and then you know how many numbers are bigger, etc. So sorting helps in those contexts if it is ordered. In fact, most NoSQL DBs, they actually try to maintain data in a sorted form. Sorted set is what it is called. Because it makes searching for data, looking for data, doing a bunch of analysis on data easier and easier, right? So today, we're going to just to elaborate, we're not going to talk about searching. I'm going to talk more about sorting. Sorting is arranging data in a particular order, right? So for example, if let's say give you 5 numbers, I give you numbers, let's say 5, 10, 3, 2, and 8. These are numbers in no particular order, right? Now, if I say arrange these numbers in an increasing order, where the smallest number comes at the front of the list and so forth, that part is called sorting. So, I mean, if you sort this, then you'll have 2, 3, 5, 8, and 10. It's an arrangement of the given numbers so that they are in some particular form or order. As I said, like the reason why it is important is because it helps you do a bunch of different kind of operations on the data fairly quickly if what you have is sorted. And I gave the example of NoSQL databases where they maintain data in sorted sets because it lets them do a bunch of different kind of queries in a sorted form. In fact, we will talk about some form of MapReduce when we go to system design modules. There also you'll see like a lot of things are generated in sorted forms because it allows for certain more operations to happen later on. Does everybody understand like what sorting is? So maybe like the way I would explain sorting is taking just like in binary search, I took the real world example of searching in a dictionary, what we normally do in real life. I'm again going to be taking the example, a real life example of what we might have done in our lives before, right? All of us went to school, and in school we were made to stand in increasing order of our heights. Now, let's take that example, which is I have a class full of people and I want to arrange them in increasing order of their height. Right now, assume they are standing in some random order. What are the different ways in which I can actually arrange them in increasing order of their height? And I'm going to take various sort of approaches I would have taken. And then I would sort of map it to what that approach is in real life. So approach one could be that I ask everybody to come one by one. And I mean, let's say if I have a few people already standing in the line, let's say I have few people that I've already arranged in the line. And let's say there is this new guy with this height that comes. In fact, it is better to imagine, maybe I can write the height of each of those individuals. Let me just write the height. So imagine I had somebody with height 1, 5, 12, and 27 already in the line. Somebody with height 7 comes. One thing which I can do is I can find the right position for this person, which is between 5 and 12. And I insert 7 there, which means then I'll have 1, 5, 7 here. And then 12 and 27, I'll push one space back. Right? So 12 comes here, 27 comes here, right? And then as people keep coming, let's say there is a person called 32. I'll figure out where 32 should lie here. I'll figure out 32 should come here. I'll insert 32 here. Everything up after 32 would be pushed one space back to make space for 32. Here there is nothing. This is called insertion sort. This technique where I get numbers, I figure out what is the right location for them. I can do that through binary search, or I can do that through a linear scan. Either is fine. Once I find out what their location should be, I shift all of the other numbers one space to their right, and then insert this number, new number, at the new location. Now, that is called insertion sort. If I have to write the approach for this, or the steps for this, basically assume that I am maintaining my sorted array in, let's say, sorted array list. That's a sorted list, which is initially empty. And imagine I keep getting a few numbers, right? What I do is I start from the end of this list. For example, here, if I had 1, 5, 12, and 27, and I wanted to insert 7, I'll start from the end. Is 7 already bigger than 27? It is not. So what I would do is I'll shift 27 one space to its right. So imagine this was the array. I have one space left here, so I'll shift 27 to its right. So 27 comes here. Then I go and again check 12. Is 7 bigger than 12? No, it is not. So I'll shift 12 to one space to its right. 12 comes here. Then I check the next number, which is 5. Is 7 bigger than 5? Yes. That means this is the location of 7, and I insert it here. That is, I keep doing this with every new number that I encounter, and that makes for what is known as insertion sort. What is the best case complexity here? Best case time complexity here. And what is worst case time complexity here? Best case for sorting. Order 1 would be the time complexity of inserting a new element, best case, right? Because you start with 7, you'll find that, let's say the new element that we are inserting in this new array, let's say that is 32. Best case is I look at the first element and I find that 32 is bigger than that, and therefore 32 just gets inserted here. It is for the addition of the last, like the new element. Order 1 is the best thing that you can do, but you'll have to add n such elements. So therefore, if you do order 1 for n elements, you'll end up with order n best case complexity. So in the best case, insertion sort will take order n time. What is the worst case? When do we get the worst case? What is the worst case, and in what kind of data would we get worst case? If the array was reverse sorted, which means if, let's say, I was giving you numbers, I first give you number 5, you insert 5. Then I give you 4. You insert 4 here, right? Because you'll have to shift 5, 1. Then I give you 3. You'll figure out that actually 3 is smaller, so you'll shift 5 here, then you'll shift 4 here, and then 3 comes here. Then I give you 2. You'll again shift 5 here, you'll shift 4 here, you'll shift 3 here, and then 2 will come here. And then again, you'll do one more shift and to get 1 in if 1 is the next number, right? This ends up taking, for the first number, you take 1 step. For the second number, you take 2 steps. For the third number, you take 3. And for the fourth number, 4 and 5 and 6 and so forth. So this becomes almost order of n square. So worst case, this might take order of n square when the numbers are sorted in decreasing order. A very interesting question, which is, does the time complexity affect if we take linked list? There are 2 parts here, right? One is, there are 2 things that we're looking for. One is, what is the right index where this new number should go. And the second is shifting greater numbers to make space. One place right. So your linked list will save you on this time. So this time will become 0. However, finding this 1 in a linked list, because you can't really jump to a random location, you'll have to do a linear scan to figure out where the number should occur. Right? So that might still end up taking order of n square, because searching for the right index, the step number 1, that might end up taking order n. You can't apply binary search in linked list because you can't just jump to a random location in the linked list. Right now, the way I explained insertion sort was that you were getting a stream of numbers and then you're sort of sorting it by putting them in the right location. Now, whatever I said, that can also be applied to an existing array as well. Let me explain. Right now, the way I detailed insertion sort is by saying that, like 5, I'm getting 5, then I'm getting 4, then I'm getting 3, then 2, then 1. Imagine I was already given an array, right? So imagine I had the array as, let's say 5, 8, 3, 2, 18, hypothetically, right? And I asked you to sort this array in place without using extra memory. I do not want to use any extra memory. Can you sort this array without using extra memory? Insertion sort. So I don't again have the flexibility of creating a new array. I am doing this in place. How do we do that in place? Even when you're doing in place, imagine I start from 5, right? So first I'll start with 5. I'll say I only have to sort this. 5 is the new number that I've gotten, right? So I have one place, 5 is the new number I've gotten. Obviously, it will go at this position. So 5 comes here. Then I go to the second number. And I say, let's put this in a temporary variable. Temp is equal to 8. Now, 8 is the new number I'm trying to insert in the first two locations, right? So first I'll compare with 5. Is 8 already bigger than 5? Yes, it is. So it will come here. Then I look at sorting the first 3 numbers. I pick 3. So I delete 3 from here, imagine. And it is, this 3 is the new number to be inserted. So first I check with 8. Is 3 bigger than 8? No, it is not. So 8 will come here. Is 3 bigger than 5? No, it is not. So 5 will come here. And then 3 gets inserted here. So now if you look, by now I have the first 3 numbers sorted. Now I'll take this number 2, which is I'm trying to sort the first 4 numbers. I'll take the new number 2 and imagine that 2 is the new number that I was getting. So I put this in a temporary variable. I'll do the same comparison. Is 8? No. So 8 comes here. Is 2 bigger than 5? No. So 5 comes here. Is 2 bigger than 3? No. So 3 comes here. And then 2 comes here. And then finally 18 is bigger than 8. So 18 will directly come here. Does that make sense? So same approach. All I'm doing is I'm saving on the additional space if an array is given to me already. The worst case time complexity is still the same. Nothing has changed in the approach. I'm just using the same space that was there in the array instead of creating a new array. Okay, so if we apply binary search for position, it will contain more computations, right? Finding plus swapping. Yes. If you do apply binary search, you'll first take log n time to find the right location. And then in worst case, order n extra time to create the space. Right shifting all of the elements to create space for this other element, right? So it will end up taking n plus log n every single step instead of just n every single step. So this log n is additional. Overall time complexity will still remain n square because you'll do this n times. So instead of n into n, you'll get n into n plus log n, which is basically n square plus n log n, which is still order of n square. But why do that? Why do this additional operation? Why not just start from the end? You have to shift the bigger elements one step to the right anyway. So just start from the end, shift the elements to the right, and then fit the element wherever you find the first place. All right, everything clear till now? So that is one way in which you would sort, let's say, your classmates, right? The second approach that I have is, let's say I have an array, right? Let's say the same array. I had, in fact, let me go with the original 5, 10, 3, 2, 8. So 5, 10, 3, 2, 8. And I put this in an array. Now, what I know is that in the sorted array, the smallest number has to come at the beginning of the array. Do we all agree with that? smallest number has to come at the beginning of the array, right? So one thing that I can do, which is not very optimal, but still works. It is every single time I look at what is the minimum in my given array. For example, if I run this loop, I'll figure out that 2 is the minimum. I say, okay, great. If 2 is the minimum, let me push 2 to the beginning of the array. So 2 comes here. And then I can just swap it with 5. So 5 comes at the place of 2. So when I do this, 2 comes here, 5 comes here. Now what I know is that now 2 is at the right position. I only have to sort the remaining 4 elements. And I repeat the process. For the remaining 4 elements, I again look for the minimum. Find 3. So I swap 10 with 3. And then I sort the last 3 elements. And then again, like I look for the minimum 5, I put 5 here and then so forth, right? The only downside of this approach, while this approach works, the only downside is it is order of n square no matter what the input. So in the best case, worst case, everything is order of n square. The good thing with insertion sort was that there is a case where the best case was order n. So therefore, the average performance could have been better. If we do this, it is always order of n square. I mean, basically the steps were find minimum. 2 is put in start of array and then start plus plus. That was the approach. If the array is already sorted, even then to find the minimum in the array, you'll have to look at all n elements. So every single time finding the element is taking you order n, right? So that approach is a precursor to bubble sort. So while this approach works, the question is, can we do something so that if the array is already sorted, then we don't have to go through all of the elements all over again, right? Like every single time finding the minimum takes me a lot of time. How do we decide when to break? Check whether the array is already sorted or not. Let me maybe give some other case, right? So insertion sort will still be order n if, let's say, only one element was not in its right position. Every other element was in the right position. For example, if the array was, let's say, 1, 2, 3, 4, 0. The array is just very simply some random elements. Bubble sort is a variation of exactly this. Bubble sort is, as the name suggests, it is like bubbling something to the top, right? So what you do is you compare all adjacent elements one by one. And wherever you have a pair of numbers, so what you do is, for example, let's say people are standing in some random order in the line, right? So for example, I have people standing as 5, 10, 3, 2, 8. Let me just write it like this: 5, 10, 3, 2, 8. My objective is somehow bubble the smallest number 2 to the top. So what I do is I say the last person standing in the line, hey, you compare yourself against the next person to you. You obviously know how to compare yourself against the next person. You can check your height versus the other person's height. Obviously, if you're standing behind and you're smaller, then you should swap yourself, right? So I say 8, look at 2. If you're smaller than 2, then swap yourself. 8 says, I'm not smaller. Great. Then I say 2. Look at the next person ahead of you. If you're smaller than that, then swap. And I do see that 2 is smaller than 3, so I swap. So 3 comes here, 2 comes here. Then I say 2, swap yourself against the next person if the next person is smaller. I figure out 2 is actually smaller than 10. Sure, I mean, should get swapped. So 2 comes here, 10 comes here. And then I again say 2. Again, compare yourself against 5. If you're smaller, swap yourself. So 2 again gets compared with 5. 5 comes here, 2 comes here. So what has happened in this one order n loop? The smallest number has bubbled itself to the top of the array. This is why, I mean, because the smallest element is bubbling to the top, it is called bubble sort. Even this approach in the worst case will take order n square. There is one difference here though. If there are no swaps that happen all throughout in this order n loop, then we just stop there. Which means if the array was already sorted, then we would not do the next iteration. We'll keep doing the next iteration as long as there is swap happening. So let me elaborate again. What happens is, imagine you're standing in the line. I start from the last person. I say, compare yourself against your neighbor. You compare yourself against the neighbor. If you are smaller, then you swap yourself. And then you do that till the start of the array. One thing which is guaranteed in this loop, whatever is the smallest number will bubble up to the top of the array. Then you're left with sorting only the remaining part of the array. And you also know if there is any iteration where I went from the last person to the first person, there was no swap happening between the neighbors, then I know that elements are already in the increasing order. I can just stop. I do the same process again. Now 2 I don't care about. I already know 2 is in the right position for the remaining elements. So I again start from 8. I say 8, are you bigger than 3? 8 will say, yes, I am. And I say 3, are you bigger than 10? No, I'm not. So we'll swap. 3 comes here, 10 comes here. 3, are you bigger than 5? You're not. So sure, then let's again swap. So 3 comes here, 5 comes here. Again, if you see, 3 has bubbled up to the top, which was the next smallest element. And then you're left with sorting only the last 3 elements. Any iteration where you don't have any swaps, your array is already sorted, you can just stop. Since we had 1 or more swaps in the first traversal, we'll start again from 8, but we'll not go till 2. 2 will be ignored. The first element is already sorted, so we'll stop here. Now that in the second iteration, we know that the first 2 elements are fixed, we'll start again from 8, but we will stop at after 3. We'll not look at 3 and 2 anymore because we know that they are in the right position. Every single iteration, what is happening is the smallest element is bubbling to the top. And any single iteration, I know that there is no swap that has happened. I can just break. And therefore, I do have a best case complexity, which is if the array was already sorted, I will do an order n iteration to figure out are there any swaps. But post that order n iteration, I can just break. Or if I reach a stage intermediary stage where, let's say I did these and then the remaining numbers were already sorted, then also I'll just break, right? So I'm not really spending time sorting if the array is already sorted. Does that make sense? Let me actually write the pseudocode for this. What I'm going to do is I'm going to start. So here is my inner loop, right? So I'm going to start from the last element. Let's say there is a j that starts from n minus 1, goes to, imagine I'm doing a loop of I from 0 to whatever. I'll tell you what 0 to whatever is. It goes to I. Imagine that like numbers till I are sorted. Right now, nothing is sorted. So n minus 1 to I. What I do is here I compare a of j with a of j minus 1. Now I know that in the right order, a of j should be bigger. So if it is smaller, if there are 2 numbers where the second number is smaller, then obviously they should be swapped. The second number, if it is smaller, if this is smaller, then they should be swapped because they are not in the right order. So I just say swap a of j, comma a of j minus 1, right? By the end of this, a of I will have the smallest element anyhow. I is starting from 0. A of I will have smallest element anyhow. I also keep track of one variable here. Has there any swap that has happened? Let's say there is a flag, which is initially 0. Whenever there is a swap that happens, I make flag as 1. If at the end of it, if I see that flag is 0, then I just break, which means this element was already sorted. There is no need to look at other elements. And then I goes from 0 to n minus 1. Yeah, sorry, this is I plus 1. Correct. So again, like what is happening in the algorithm is the smallest element is bubbling to the top, and you're just taking in the process, making sure that if the remaining elements are in the right place, there was no swap, then the element is array is already sorted. So let's just break. Yeah, actually we don't need the n minus 1. When we come to n minus 1, I plus 1 would anyhow, this j loop will not run. So I can just do n minus 2. Again, let's look at what is the best and worst case complexity of this algorithm. Best case is order n, which is my array was already sorted or almost sorted. And then, I do this iteration, flag becomes 0, I break. And the worst case is when it is reverse sorted. So every single time I have to do a lot of these swaps, and it is actually order of n square. All right. So this is, by the way, called bubble sort. Find the smallest element, move it to the beginning. This is called selection sort. In selection sort as well, it's what we were discussing, where we were selecting the smallest element and moving it to the beginning of the array. That is selection sort. The reason why we are discussing this is these are intuitive ways of how we think about sorting, and the technique can come into use later on. Let's do a dry run with bubble sort just to see the best case, right? So imagine I asked you to sort this array 1, 2, 3, 4, 5. Imagine this was my input, correct? Selection sort is sort of an greedy algorithm, because what you're doing is you're saying that I know the smallest element should come at the beginning, so let's find the smallest element. You put it in the beginning, and then you sort the remaining array. Let me, however, show like how the bubble sort is till best case order n. I mean, selection sort, by the way, we can also make order n in one case. I'll also go over that. Selection sort, just slight variation, and it can become best case order n. Let's first look at how it becomes order n best case in bubble sort. Imagine this was your input, right? You start with I as 0. I is 0. J, your flag is also 0. J basically goes from, so you have your index 1, 2, 3, 4. J will start with 4 and it will go till 1. 4 till 1. And what do? Every single time you just compare A of J with A of J minus 1. So you check, is 5 less than 4? The answer will be no. So then you move on to the next J. So from 4 you will go to 3. From 4 you will go to 3. Then you compare 4 with 3. Is 4 less than 3? No. Then you will compare 3 with the previous element. Is 3 less than 2? No. Is 2 less than 1? No. So at no point this if condition gets executed. So there is no swap, and therefore flag never becomes equal to 1. So when this loop finishes, when the J loop finishes, you come to the point where flag is still 0, and therefore you break. So just after the first iteration with I0, you end up breaking because you figured out there was no swap involved in my array. So my array is already sorted. Why look at things again? So that's why you get the best case as order n. Worst case is obviously n squared. Now let's look at what is the case, or like how do we make sure that even my selection sort, which is like very greedy like, can I modify it somehow so that also becomes or best case order n? Let's see. Let's take some random input, right? So I had 5, 3, 8, 4, 6. Now the way selection sort works is you go from the beginning, you look at this, you try to find the minimum element in the array. This is the approach just before bubble sort that I had talked about. You try to find out the minimum element in the array. In this case, I find 3 as the minimum element. And for this, I take an order n loop, right? In order n, I find minimum of the array. Now, if in this iteration only, I would have figured out that the array is sorted in this order n, if I figured out that the array is sorted, which is all of ai is less than ai plus 1, then my work is done. However, if it is not, then the smallest number that I found, which is 3, I try to swap it with the previous element. Basically, I try to put it here and shift all of the remaining numbers one step to the right, which means the array now becomes 3 here. I have 5, 8, 4, 6. In fact, let me just change the array a little bit so that it becomes slightly better. Imagine if the array was 4, 5, 6, 8. When I do the swap, then the array becomes, or when I push it here, then it becomes 3 comes to the beginning, and then I have 4, 5, 6, 8. Now, again, I know that at this point of time, 3 is at the right position. I still need to sort the remaining array. I'll again have to do an order of n minus 1 loop, this, and this to figure out the minimum number. In this case, it is 4 as the minimum number. But by the way, in this order n minus 1 loop, I figured out the array is already sorted. So I can therefore stop my process. The key thing to do here is when you find the minimum element, you don't just swap, but you shift the prefix of the array one step to the right, create space for this new element, and then you put it in the right place. If you do that, then the selection sort also becomes best case order n. One thing is, in most cases, you will neither be using bubble sort or selection sort or insertion sort. Actually, insertion sort may be in certain cases, but most cases you will not be using these. These are algorithms that are good to think about. The approach that we utilized here, this might come into use later on in some or the other kind of context or in some or the other kind of problems. But the sorting algorithm that is currently in use in most of the libraries that you use are either merge sort or quick sort. Quick sort as being the most popular one because it has better average performance, does not use additional memory. But those are the ones because they sort of perform in order of n log n time. All of these are worst case order of n square. Average case is also order of n square almost. Java 8's array.sort also uses quick sort. But like bubble sort, insertion sort, 3 algorithms that I talked about, they're good to know from their approach standpoint because there are some problems that might utilize this approach. These are not necessarily the sorting algorithms you'll use in day-to-day. Sorting algorithms that you will use, I'll talk about that in a few moments. But just so that I, again, complete my discussion on selection sort, let me write the pseudocode for selection sort. Pseudocode is very simple. Right now, if I have to sort, imagine when I is 0, I need to sort everything from 0 to n, right? So what I do is I take This will go to some number. I'll figure out what. I'll take the loop from I to n. I'll figure out the minimum. In fact, let me actually also track its index. I can just keep it as a of I, and index is equal to I. And this loop can run from I plus 1. So if, let's say, a of j is less than min1, then minimum is equal to a of j, index is equal to j. Here, one of the other things which I also track is if a of j is greater than a of j plus 1, then there's a flag that I set to, let's say 1. Let's say there's a flag here which is also 0. And once I have found my minimum, then all I need to do is all of the other numbers, they are shifting one space to the right. So once I have found the minimum, I will take a loop of j is equal to, and then at the end you have a of I is equal to min1. That is one way of shifting. Basically what I'm doing is, if I have an array, let's say I have 5, 6, 3, 2, 8. I'm going through once to figure out what is the minimum. Once I find the minimum, I bring minimum to the front, which is 2 comes here. And then 5, 6, 3, I shift one space to the right. And then I try only sorting this piece, where every single time I have a flag to check, is this piece already sorted or not? If at all at any point of time I find that there is a section of array that has already sorted, then I just break out and I'm done. Here, I mean, I could very well also have done, instead of doing all of this, I could have done swap a of I, comma, a of index. I could have done this as well. As long as I'm checking that for the remaining array, is the array sorted or not? If the array is sorted, then I just break. That is the only optimization that I put in, nothing else. Now I'm going to be covering a few other sorting algorithms, and then we'll do a few problems on these. Count sort is the easiest one. Count sort is when the elements that you are sorting, they are limited in range. Limited in range meaning, for example, I tell you, hey, you have characters A to Z. You have a lot of characters and you need to sort them. Or you only have numbers 0 and 1. Or you only have numbers from 1 to 20. Then what you do is, instead of counting or basically maintaining like numbers themselves, you just count how many numbers. For example, I gave you an array of zeros and ones, right? So bunch of 0, 1, 0, 1, 1, 1, 0, etc., etc. And I told you to sort this array. One very simple way would be, I calculate the frequency of 0 and frequency of 1, which is basically exactly what count sort means, right? Like you're maintaining the count of the numbers themselves. So you say like, I'll count how many times 0 came. Let's say 0 came 10 number of times. And I'll count how many number of times 1 came. Let's say it came 5 number of times. Then I know my sorted array. My sorted array is 0, 0, 0, 0, 0, 10 times. And then 1, 1, 1, 1, 1, 5 times. So one very common application of this is, if I give you two strings and I ask you, are these strings anagrams of each other? Anagrams is like two strings are anagrams if they are just some or the other permutation of the same string. For example, if I give you a string banana and I give you another string, let's say, this is not really a word, but I give you these two strings, right? And I ask you, are these anagrams of each other? Your answer will be yes, because they have the same count of n. There are two n's here, there are two n's here. They have same count of a. They have three a's here, there are three a's here. And they have same count of b. You know that you only have 26 different characters. So in a 26 array of size 26, you can maintain the counts of number of a's, number of b's, number of c's, and so forth. And you can just compare the counts, right? So count sort is very simple. If you have limited number of numbers, if your range is very limited, you maintain the count of every single number you encounter, and then like you just print those numbers, those many number of times you go from start to beginning. So we are going to maintain a new array for 0 and 1. However, 0 and 1 are just two numbers, two variables. So it is still order 1 space. If you only have, let's say, 20 numbers, then it's just order of 20 space, which is not order n, right? Like it is not dependent on the number of numbers that you have in total. Let me maybe give you an example, right? And then I'll write code for it that will make it clearer. Very simple. Imagine I give you a string of characters, and I just ask you to sort that string of characters. For example, let's say the string is congratulations. Let's say that is the string. And then there were a bunch more characters as well. But like, let's just say that this is the thing. There could be, let's say, thousands and thousands of characters here, thousands, hundreds of thousands of characters. The one conventional way of sorting is like doing the bubble sort or the selection sort, etc. Right? Which is a selection sort would be you figure out which is the smallest character, which is A. You shift A to the front. However, I mean, if there are a lot of characters, that will take a lot of time. So what I say is, hey, by the way, I know that the kind of letters could only be from A to Z. Correct. I have A, B, C, D, E, F till Z. Correct. There are only 26 characters possible. 26 different characters possible. So if I somehow maintain the character count, right? I have only 26 characters. If I have an array which has the count of what are the number of A's here, what are the number of B's here, C here, and so forth. For example, when I encounter C, I say let's increase the count of character C by 1. So C's count becomes 1. And I mean this could just be an array, right? Because any character can be mapped from a number from 0 to 26. So I just maintain an array of size 26, which is all initialized to 0 to begin with. When I encounter C, I increase the count of C by 1. Then I encounter O, let's say O is somewhere here, I increase the count of O by 1. When I encounter N, I increase the count of N by 1. With R, I'll again increase the count of R by 1. A will become 1. Let's say when I encounter A again here, A's count will become 2. So that way, I mean, I'm just maintaining count of every character, right? Like, and if I have to write code for this, I would just do very simple. I would say that, you know what, like I have a array of size 26, which is initialized to 0. This is C++ format, but like Java, etc., it will be similar. And then I just say, you know what, like, let's assume that the character is CH, and I go over this string str, and I just say that ARR of CH minus A, which will now give me a number from 0 to 26 plus plus. At the end of it, I'll have frequency count of every character. And then like the sorting is very simple. I just go character by character, right? So I just go from for I is 0 to 26. I look at the count of the current character. Like for example, when I is 0, then I'm looking at the count of A. So what I do is I take a loop from 0 to ARR of I, whatever is the count. And I print A plus I, those many number of times. So what will happen is if the count of A was 2, then this will print A twice. Then let's say if the count of B was 1, then it will print B. If let's say the count of C was 3, then it will print C 3 times, and so forth. So all I'm doing is I'm just counting the numbers, frequency of the numbers, and then I'm just printing in them those many number of times, going in the order of numbers. Does that make some sense? Count sort, how is it working? As long as the range is limited. For example, let's say if you have numbers from minus 20 to 20, even then you can use the array, right? Because you can just say that every single number, num, corresponds to the index num plus 20. So when you encounter num, you just say, you know, ARR of num plus 20 plus plus. And when you print, then like for ARR of i's count, you print I minus 20. In general, if you see for doing this, if you have a range of numbers, let's say the range is R, count sort takes order of R memory, right? If the range from min to max of the array, if the range max minus min, if this is R, then it takes you order of R memory, right? Because you need those many number of counts variable, right? If R is small-ish, for example, let's say if R is 1,000 or 10,000 or 100,000 or 1 million, if let's say R is up to 1 million, then you can use count sort because you can maintain the counts and therefore like it will still run. However, let's say if the numbers were not limited, if there could be any integer, then you can't use count sort. Count sort is only applicable when the numbers are limited in the range. As I showed with counting characters in a string, because characters are limited. Characters can only have 26 different values. So it is not done in place in the sense that you're still counting the number of A's, number of B's and C's, and then you can fill it in the same array. For example, if you said, tell me here instead of printing A plus I can just say, you know what? Let's have an index variable, which is 0. And I have, let's say my original string was str. I can just say, you know what? Str of index plus plus is equal to I plus A. I can fill it in the same array instead of printing, but I mean, you'll still have to maintain counts, etc. Merge sort is if imagine you had to sort a deck of cards. One possible way, which is, by the way, also called divide and conquer, could be that I break down this deck of card to half deck of card and half deck of cards. So I divide into two parts, right? Like half goes, let's say, to the left, half goes to the right. I sort those individually, right? So half deck of cards, I sort them somehow by some magic. And right side also I sort somehow by some magic. So now I have two sorted deck of cards, right? I have two sorted deck of cards. Now the problem becomes, if I have two sorted deck of cards, can I merge them so that they still remain sorted? Imagine, let me give you an example, right? So let's say I have an array 2, 3, 5. Let's say I have another array 1, 6, 8. If I was given these two arrays, can I merge them into another array which is completely sorted? Is that possible or not? If that is possible, then this could become another algorithm, which is like whenever I need to sort an array, I can divide it into two parts, recursively sort them, and then I can merge them. So merge becomes the important step. The question is, I have given you a problem. You have two arrays, not necessarily of the same length. Let's say this is of size A, this is of size B. Can you create another array of size A plus B where all of the elements come from A or B and they're all sorted? Is the question clear? Like you have some A number of arrays in array A, you have B number of elements in array B. Array A and B are individually sorted. So A is a sorted array, B is also a sorted array. You have to merge them into another sorted array. How would you do that? Basically, if I have been given two numbers, let's say I have an array A, 2, 3, 5, and I have an array B, which is, let's say, 1, 4, 8. And I have to create a sorted array, right? Which is of size 3 plus 3, which is 6. 1, 2, 3, 4, 5, 6, correct? This is the eventual sorted array I have to contain or create. One thing is, the first element in the sorted array is going to be the completely minimum of everything in the array, right? So given array A is sorted, minimum from array A is on position number 0, correct? Minimum from array B is also on position number 0. So therefore, whichever is the minimum of these two, I don't need to look at any other element. Whichever is the minimum of these two is going to be the first element in the sorted array. Is that something you all agree with? And what is the minimum of these two? Minimum of these two is 1. So 1 comes here. Now, if I have inserted 1 here, then it is as good as saying that now I remove 1 from B. It is the same thing, right? So what I just do is, how do I remove 1 from B? I just change this pointer to now point at this number 4. This is as good as saying that I'm now merging two arrays, one array which is A and one array which is B, but B is starting from this point onwards. And I again do the same thing. What is the next number that should come here? It should be the minimum of numbers here and minimum of numbers here. What is the minimum of numbers here? Array at this pointer. What is the minimum of numbers here? The array at this pointer. Whichever is smaller, which is 2, comes here, and this pointer moves one step forward. So in short, the approach becomes that you have two pointers. Let's say there's a pointer 1, which is for array A. There's a pointer 2, which is for array B. And you just say the following: while pointer 1 is less than whatever is the size of A and pointer 2 is less than size of B, you do the following. You figure out which one is smaller. You just check. If A of pointer 1 is smaller than equal to B of pointer 2, then simple. This is what goes in the sorted array. So let's say sorted of, let's keep an index, A of pointer 1. You increment the pointer 1 plus plus because now pointer 1 has been assigned here. Else you put pointer 2 element here. So sorted of, again, index plus plus is equal to B, pointer 2 plus plus. The only thing is, when I'm done with this while loop, it is possible that all of the smaller elements were in one of the array. Imagine like this array was 1, 2, 3 here, and there were, let's say, 4, 5, 6 here. My pointer 1 will end up going here, and I'll end up breaking out where I've only filled in 1, 2, 3 in the sorted array. 4, 5, 6 is yet to be filled. So I'll have to check for that, which is at the end of this while loop. If whichever pointer is not done, so I just check while pointer 1 is less than size A, I just keep adding sorted of index plus plus is equal to A of pointer 1 plus plus. And very similarly, I do the same thing with pointer 2. While pointer 2 is less than size of B, same thing, sorted B of pointer 2 plus plus. right? That will cause the merge to happen. Does this make sense? Right. Now, if that can happen, which means now if merging can happen, and what is the time complexity of this merge? Imagine I have two arrays of size n and n each, n plus n, right? Like, so it takes me order n time to merge. If in fact the array A was of size m, this was of size n, it takes me order of n plus n time, right? That means if I have a order n array to be sorted, if I divide it into two parts, I say that sort the first part separately, sort the second part separately. Once they are sorted, then merging them will take me order of n by 2 plus n by 2 time, which is order n time. So merging them will take me order n time. Now, how do I sort the first half of the array? I can do the same thing with the first half as well. I can say that even to sort the first half, again break it down into two parts, and then sort the first half, sort the second half, merge it. With the end condition being that once I have an array of only size 1, it is already sorted. How about I modify this and I say that I have 3 arrays that need to be merged, right? Imagine I have an array 2, 5, 10. Imagine there's another array 1, 8, 9. And imagine there's another array 3, 4, 12. Let's say there were 3 arrays, right? How would you merge these 3 arrays into one array, which has all elements are sorted? We can do 2 at a time, but we don't necessarily need to, right? Like, we look at this, right? What is the first element going to be in the merged array? It is the smallest of all. Where does the smallest come from? It is either the first element from here, or the first element from here, or the first element from here. Whichever is the minimum from here, that becomes your smallest. So I can have 3 pointers. Pointer 1 pointing to the 0th element, pointer 2 here, pointer 3 here. Whichever is the smallest of these 3, which in this case is 1 comes here. And then all I do is I move this pointer 1 step to the right. And I again repeat the same thing. Whichever is the smallest of these 3, which is 2 comes here. And then 2's pointer moves 1 step to the right. Now again, 5, 8, 3, whichever is the smallest, 3 is the smallest, 3 comes here. And 3's pointer moves to the right. 5, 8, 4, 4 is the smallest, so 4 comes here. And its pointer moves to the right. 5, 8, 12. 5 is the smallest, so 5 comes here. And 5's pointer moves to the right. And then so forth, right? In the case of merge sort, it is only 2 arrays. An extension of the previous question. Then instead of 2, if there were 3 arrays, how do you go about merging 3 arrays? I mean, you can merge 2 arrays at a time. You can merge these 2 at a time, and then you end up merging these 2. But you'll end up using more memory, because to merge these 2, you'll need an additional array of size 6. Then you'll create an array of size 9. What I'm doing is I'm just directly creating an array of size 9 so that I reduce the amount of memory required to maintain that intermediate re-array. Also, I reduce a step. Okay, all right. Coming back to the merge sort. How does merge sort work? As the name suggests, it's divide and conquer, which is basically, now that I know that I have the superpower of taking 2 sorted arrays and merging them, what I can do is, given an array A, I sort the first half. So sort A to 0 to n by 2, sort A of n by 2 plus 1 to n, and then merge these guys. That can become my approach. And this, how do you sort the first half? This also can happen in the same way, where you again divide into 2 parts, 0 to n by 4, and then n by 4 to n by 2, and again, then you merge, etc., right? And if I have to write code for this, it becomes fairly simple, which is, let's say if the question was, how do you sort array A from index I to index j? If obviously, like, the size of the array is already 1, which means if j is equal to I, let's just put that, then your array is already sorted, so you can just directly return. If not, then what you do is you basically sort the first half, which is, you say, I'll go from A of I to mid, where my mid is I plus j by 2. Then I'll sort A from mid plus 1 to j. And once these 2 guys are sorted, then I will need a temp array where I'll merge the array from I to mid and mid plus 1 to j. And then I'll make sure that A of I to j becomes equal to temp. I'll just do that. But basically, I'm just applying recursion here. What I'm saying is, if you want me to solve, by the way, let's say there are 4 numbers, right? 5, 3, 2, 6. Let's say those were the 4 numbers. I say that first sort the first half. So let me call the function to solve these 2 numbers, 5 and 3. Somebody sort this and then give it to me. And then sort the second half separately. So somebody sort 2 and 6 and give it to me. And once I have them sorted, then I will actually merge them, right? Now to sort 5 and 3, I again do the same thing. I split it half. I say somebody sort 5 for me and somebody sort 3 for me. Here also, and somebody sort 2 for me and then 6 for me. Once they are sorted, then I'll merge. 5 is sorted, 3 is sorted. How do I merge? In my merge step, the same way we had seen, we have 2 arrays. We have to merge. When we merge, this will become 3, 5. And that is what I replace my original array with. So this array becomes 3 and 5. Very similarly, 2, 6 remains 2, 6. And then once I have 3, 5 and 2, 6, then I merge them to find 2 comes first, then comes 3, then comes 5, then comes 6. And this becomes my actual sorted array, which I replace this with. Just out of curiosity, why do we divide them into equal halves? Although in the end, we move 2 single elements and merge them in sorted order. Can't we take pairs in the array and do the same way of merging? Let's say I have more numbers, right? So imagine I had 5, 6, 8, 1, 2, 13, 15, 12, 3. How many do we have? We have 4. And let's imagine I remove 12 from here. Question is, if we have to sort anyway, why don't we take pairs by pairs, right? So let's just take pair 5, 6, 8, 1, 2, 13, 15, 3. And let's just first sort them. So we end up sorting them. And for example, we end up finding that this is 5, 6. This becomes 1, 8. This is 2, 13. And this becomes 3, 15. Right? Now, the problem is like we've done pairwise sorting, but the array is still not sorted. Then we'll have to do sorting of 4 elements each, right? How do we do that? We say that, you know what, like there are first 4 elements here. The first half is sorted. The second half is also sorted. Let's merge somehow, which again, I'll take another array and then I'll merge, etc. So this will get sorted. Then I'll do again the same thing, which is I take 4 elements, half is sorted, and I'll do the same thing. And then finally, I'll look at all of the 8 elements. So you're going just in the reverse order. What I just said, you're just going in the reverse order, which is also correct. It's just harder to code because the previous approach can be coded using recursion, which I'll just show. In your approach, what you're doing is you're building bottom up, right? Like you're sort of saying that let's first sort all pair of elements. Once they are sorted, then let's look at all 4 size elements. Great. Once they are done, then let's look at all 8 size chunks. Once they are done, then look at all 16 size chunks, and then 32 size, and then 64 and so forth. Right? And finally, I'll have the entire array sorted, which works. It's just harder to code. What I said was the other way around, that instead of going from 1 to 2 to 4 to 8 and so forth, let's start from n. Let's divide that into n by 2 parts, then n by 4, then n by 8. And I'll finally reach the 1 part anyway. And then my recursion function will keep returning and I'll have the eventual answer. So if you look here, my recursive function, this will do the same thing. My recursive function here will also do the same thing. Let me also just write it as merge step. So what is happening is, if I have an n-sized array, I'm dividing it into 2 arrays of size n by 2 each, n by 2 each. I'm sorting it using the same methodology, which is this n by 2 will create arrays of size n by 4, n by 4. Here also, again, same, n by 4, n by 4. These will create arrays of size n by 8, n by 8, again, n by 8, n by 8, same thing. And this n by 16, n by 16, and so forth. How many levels will you have here? I mean, we go from n to n by 2, n by 2 to n by 4, n by 8, 4 to n by 8, n by 8 to n by 16. How many levels? Log n levels, right? So in every level, n is becoming half of what it was. As we have seen the same pattern in binary search, etc., etc. I mean, as you go, if n is becoming half of what it was, it takes you log n steps to finally come to 1. At every step, what is happening? At every step, basically, I have n by 2 sorted array. I'm merging them, which takes me order n time. This takes me order n time. N by 2 plus n by 2 and order n. What happens on this level? These 2 guys merge and it takes them n by 4 plus n by 4, which is n by 2 time. These 2 guys merge and it takes them n by 2 times. If you add them up, it will take you order n time on this level as well. Very similarly, on the other level as well, where you have n by 8, there are 8 instances of n by 8. It will again take you order n time. So the total time taken on every level, it takes you order n time. There are log n levels. The total time taken is n log n. That is an intuitive way to understand. I can also explain the mathematical way of explaining this. But the intuitive way of understanding the time complexity of merge sort is that on every level, you're doing one merge. The merge is order n, number of levels is log n, and therefore, in fact, if you look at Arvind's approach, if you were to implement it, in every iteration, what you're doing is you're first creating pairs and you're merging the pairs. Takes you order n time. Then you're looking at all four blocks, right? Like blocks of 4 each. In one order n operation, you will have sorted blocks of 4 each. Then in again one order n operation, you would have sorted blocks of 8 each. And you'll keep doing that till you cover the entire array. So the number of steps to cover the entire array would be log n. And every single iteration is an order n iteration. So it takes you an order of n log n. I can explain the math behind it as well. Is it n log n in every case? Best case is, sure, I mean, you can probably put an optimization that if the array is already sorted, if a half is already sorted, you don't need to do all of the splitting, etc. So best case, you can still make order n. But yes, worst case is order n log n. Worst case, it takes you order n log n. And you can put a check to make sure that you're not doing the entire splitting, etc. if the array is already sorted. All right. What is the space complexity of merge sort? So if you look at the implementation here, we are allocating this additional memory temp to calculate this merged part, right? Why? Because when we are merging two sorted arrays, we need this temporary space where we put in the result, which is not a part of the original array. This is additional space. If I have to look at this tree, in this n by 2 part, I would have taken a temp array, which was of size n by 2. Here, I would have taken a temp array, which was of size n by 2. In fact, let's look at total space allocation, right? So this n by 2 will make a call to n by 4, 8, etc., etc. So this is a log n stack memory space. Plus, in each of these, so imagine I was sorting this array of size n. This will end up calling for n by 2. This will end up calling for n by 4, n by 8, and so forth. In each of this, I would have a temp array allocated, which will be freed as long as, I fill it back, right? So this temp array here is of size n by 4. As soon as I am done, then this will be freed. Then I come back here. Here it will be of size, additional size of n by 2. As soon as I'm done, it will be freed. And then I'll come back here and I'll have a temp array additional size n. So maximum space that I end up using additional is I have log n stack of recursion plus I have this additional order n size array that I might have used, which is my temp array. So order n extra space is what we end up using apart from the array space. So space complexity becomes order n. Time complexity becomes order of n log n. There's one more way to, by the way, calculate time complexity. If you assume that the time taken for sorting an array of size n is tn, then tn is nothing but, I'm saying first sort array, first half of the array, then sort second half of the array, which is also of size n by 2, and then merge them, which is it takes you some n time. Let's say it takes you n time. This is basically saying 2 times t n by 2 plus n, right? If you break it down further, your n by 2 is 2 times t n by 4 plus n by 2, which is the same as 4 times t n by 4 plus 2n, which you'll see will finally come to 2 to the power I t times n by 2 to the power I plus n into I. This is just a little mathematical. Therefore, I explain the intuitive way first, which if you want this to become equal to 1, I becomes log n. So you have n into t times 1 plus n into log n, which is n log n. This is how Master's theorem actually works. I'm just elaborating that, expanding that equation. Even if you don't know about Master's theorem, that is fine, as long as you understand the intuition of why it is n log n. Because in the recursion tree, there are log n levels. On every level, I'm using order n time. So time complexity becomes order of n log n. Space complexity becomes order of n. Is there any way without using the extra space? So actually merging two sorted arrays without using extra space in order n is not possible. That becomes the blocker, right? So if you can merge the array in place without using extra memory, then your problem would have been sorted. But the problem is merging without extra memory is the issue. All right, does this make sense? Merge, sort, space complexity, time complexity, all of that. All right. Today we'll be talking about quicksort, and today we'll be solving a lot more problems actually. By the way, I just wanted to maybe also share one news with all of you. Today was the first case when one of the fellow students at Scalar has gotten an offer as a CTO at one of the energy companies, which is a fairly big company now, right? And that the reason why I'm sharing this with all of you is to show you that, look, I mean, learning matters. I mean, and like, again, I can't disclose the exact salary of the person, but it is in a few CRs. We're not talking about lakhs, right? So the thing that matters at the end of, I mean, that is basically the North Star for all of us. He's 30 something, but like, we all should focus on the learning aspect. As long as we do that, eventually all of us will succeed. We'll go and build really, really great things in the future. He is part of Scalar Academy and not Scalar Plus. And I can't disclose the name of the company. And I'm sure like that news will come out later on. It will be shared with all of the community as well. Once he joins, it's still sort of confidential. But just letting you guys know, I mean, look, it is important that all of us focus on learning. As long as we do that, I mean, obviously, like, what you find later on is going to be a function of what you know at present, plus like some bit of experience. I mean, so again, just to also elaborate, this person is not somebody who is very young. As I said, like, he's 30 plus, already has more than 7-8 years of experience, actually has more than 10 years of experience. But as long as you keep learning the right things, you'll keep moving forward, right? And that is, all of us should just aspire to become 1% better every day. That being said, back to what is the agenda for today. Today, we're going to actually talk about one sorting algorithm, which is actually used in most libraries that you use, be it in Java or Python or C++. The sort function that you use, they all use a different algorithm, which we will talk about today. But instead of talking about the algorithm, which is, I believe, not the right way to introduce a concept, what I'm going to do is I'm going to give you a problem, a real life problem that you may take an attempt at solving. And then we'll use that to maybe introduce the approach. So imagine this. Imagine you have a bunch of nuts and bolts. You have nuts and bolt, right? So nuts basically look something like this. And then you have bolt that is basically a circle that fits into the nut. The nuts and bolt, and usually like they're created in pairs, right? So you have a nut of a size and then the bolt actually clearly fits. If the nut and bolt are of the same size, then they fit. Now imagine you have a lot of nuts and lots of bolts, and you are given that every single nut is of unique size. It is every single nut and bolt are of different sizes. So none of them have the same size. And you're also given that every nut has a corresponding bolt. One fact that is given is every nut has corresponding bolt, which means they both fit each other. 2 is no two nuts have same size. So they're all different sizes. However, it is very hard for you to just visually differentiate which one is bigger or which one is smaller. So what do you do? What you do is, like, if you pick a nut and you pick 2 bolts, if the bolt is loose, then you know that the bolt is bigger. If the bolt is not going in, then you know that the bolt is actually smaller. Now the problem is, given that info, can you sort all of the nuts and bolts in increasing order of their size with the right nut and bolt paired up? Currently, they are all just in disarray. You have a table full of nuts and bolts. You don't know which one is paired up with which one, right? One is, how can you arrange that? And 2 is, how can you do it as fast as possible? Let me explain again, right? So imagine this. Let's say I had only 2 nuts. Imagine I had this nut, another nut, and I had another bolt, and then another bolt, right? Now, what I can do is, I can pick, let's say, this particular one, and I pick this one, and let's say I try to match them. There are following things that can happen. One is, these guys clearly fit. In that case, I know that this nut is to be paired with, let's just call it bolt 1, bolt 2. This is nut 1, nut 2. If they fit, then I know these guys are in the pair. They belong together. And then I can just compare the other bolt. If it is smaller than this particular nut, then it goes before this nut, right? If it is smaller, otherwise if it is bigger, it goes after. And then I definitely know that the pair for this bolt is this nut, right? So I just put these 2 guys together, either after or before, depending on how it compares with this current nut. So if I have to define the problem formally, you can pick a random nut, an X, and you can pick a random bolt. If you pick these 2 guys, you will get either of the following result. Either you will get nx is equal to by, which means both of these guys belong together, or you will get to know that, by the way, this nut is smaller than bolt, or you will get to know that nut is bigger than bolt. These are the three results you can get. You cannot compare nut with nut. So for example, I cannot get NX and NY and compare these guys. I can't. Similarly, I can't compare bolt with bolt. This I can't do. This I can't do. However, I can take a random nut and a random bolt and I can compare them. Does that make sense now? It does, right? Now, I mean, the question is, how do I sort these guys? How do I sort these guys? When I can't really compare a nut with a nut and a bolt with a bolt. The bolt size is not given to you. I mean, think of it like this, right? You have a table which is full of these nuts and bolts, and there's only minor variation in the size. What you should end up with, for example, in this case, imagine that these guys were equal. N1 and B2 was equal. So I would put N1 and B2 together and assume that B1 was smaller than N1. So I would put N2 and B1 before this. And I will return this list. N2, B1 as the first entry, N1, B2 as the second entry, right? So if you just compare with a bolt with a nut, you do get the relation, whether a nut is bigger than a bolt or not. So imagine if this nut was paired with another bolt, BZ, then you know that BZ is actually smaller than BY. So you can compare the pairs by picking nut from one pair, bolt from another pair. There is no size given. The only way is you just pick a random nut and bolt and then compare whether one is smaller than the other or not. Let's actually look at how do we do that, right? So one is, if I pick any random nut, let's say if you're given, let's say n different nuts, let's say I pick some random nut. Let's call that nut N1, right? What I can do is now I have a bunch of bolts. I have B1, B2, B3, B4, B5 till Bn. I can compare each of those bolts with this N1. And I'll basically get three kinds of bolts. There will be one heap of bolts which are lesser, right? So there's one heap of bolts which are smaller than N1. There is one heap of bolt that we will get. Let's call this bolt bigger, which is bigger than N1. And there is exactly one bolt that I will get, which will be equal to this nut, correct? If I compare all of the bolts with this nut, I'll get three sets, one bolt which is equal, and then a set of bolts that are smaller and set of bolts that are bigger. How these guys compare amongst each other, that I don't know. But essentially, I do know which bolts are smaller than this nut, which bolts are bigger than this nut. That you guys all agree with? So if I pick any random nut, I can distribute all of these bolts this way. And very similarly, now that I know that this bolt is the same as this nut, so I can pick all of the nuts, which were N2, N3, N4, N5, N6, N7, N8 till N. And I can say, let me compare all of these nuts with this bolt, right? I'll get some nuts that are smaller. So I'll basically have some of these guys. If I compare with this bolt, I'll get some nuts here. Let me take a different color. Some nuts here, which are smaller. Some nuts, which are bigger. The equal one is already here. So you'll not find anybody who's equal. So what we have done is we first started with one nut, right? And then we use that to break all of the bolts in three parts. One bolt which is equal, a lot of bolts that are smaller, a lot of bolts that are bigger. And then once we found the equal bolt, we use that bolt to actually split the remaining nuts into two parts, smaller nuts and bigger nuts. Now what I know is all of the bolts, smaller bolts, will have their corresponding nut somewhere here. I mean, basically now I have three sets, right? I have a set of nuts and bolt which are smaller. And they are guaranteed to be present in pairs here. Same guarantees holds here. Then I have one pair which is N1, B1. And then I have set of nuts and bolt that are bigger. Now I can actually recursively sort this set separately. And I can sort this set separately. But my problem has now reduced to sorting smaller set of nuts and bolts. And if the set only had one element, then I know that they are already sorted. I don't need to touch them. This is exactly how quicksort works. I'll introduce it very, very shortly. But let me take a few examples just to show how is this working. And that will give you a sense of or sort of some intuition behind how quicksort works. So imagine I was given some random, let's say N1, N2, N3, N4, N5 nuts. And let's say I had random 5 bolts as well. What I'm going to do is I'm going to mark, let's say hypothetically, what the process is going to be like. So what I'll do is in step 1, I'll pick this nut and I'll say, let's compare it with all of these 5 bolts. And we'll find some bolts that are bigger, some bolts that are equal. imagine hypothetically, let's say N1 was equal to B3, and imagine that B2 and B4 were smaller bolts, and we found out, let's say, that B1 and B5 are bigger bolts. Very similarly, then what I did was that I picked B3 and I started comparing B3 with all of these guys, N2, N3, N4, and N5. And I would come to know whether they are bigger than B3 or smaller than B3. All of the bolts, again, let's say hypothetically N2 and N3 were smaller, and let's say N4 and N5 were bigger. Now the problem becomes that I know that N1 B3, whenever I sort, is going to be the third element in the set. I have two elements before. I don't know their order, but those two elements have basically B2, B4, N2, N4 as two pairs. And I have two elements after, which is B1, B5, N4, N5 that are yet to be sorted. That is after, right? However, this portion is fixed. I don't need to change this portion. It is in the right position. It is where it should be. I do not need to change this position. This is already in its correct position. So then what I do is I recursively sort the first half. And then once this is sorted, then I'll go to the second half. How do I sort the first half? I again do the same thing. I say, let's pick a random nut. Let's say I pick N2 as the random nut. And I compare B2 and B4 with it. Oh, sorry, this should be N3. So B2, B4, N2, N3, B1, B5, N4, N5. Right. Okay. So then let's say pick N2 as the one nut, right? And I compare B2 and B4 with it. I know that I don't need to compare B1 and B5. They're definitely bigger. I'll deal with them separately. I'm only concerned with sorting these two pairs. So I compare B2 and B4. And hypothetically, let's say I find that N2 is the same as B4. So I find these guys are equal. And hypothetically, let's say I find that B2 was bigger. I know that B2 will be paired up with N3. So I put it as it is. These guys are sorted now. Then I have N1, B3. And I do a very similar process here as well. I pick any one of these guys. Let's say I pick N4. And hypothetically, let's say N4 pairs up with B1. And I find that B5 is smaller. So therefore, B5 will come here. The pair of B5 is N5. That will come here. So this becomes your sorted array totally. Now this process where I actually picked one element and I started comparing all of the remaining elements with it is called choosing a pivot. So while this is a more complicated case, let me take an example of sorting an array of integers. And I'll show you with that. Imagine, let's say my array was 5, 2, 1, 8, 6. N1 of B3 is largest. That means this set does not exist. The set is empty. But the remaining set is still smaller set than what you began with. It has now n minus 1 bolt and n minus 1 nuts. So you still have a smaller problem to solve. So in every step, you're reducing the size of the problem. So that is actually your worst case where you will end up taking n square time. But still, I mean, that still gets you to your answer. So at each step, one of the pair comes at its right place. Let me just elaborate that with this array as well. So in the quicksort process, what you do is you pick one element, any random element, to be the pivot. For example, I say that I want to pick 5 as the pivot. So what you do is, the first part is you count how many numbers are smaller than 5, right? So you basically, let's say, have 2 is smaller, 1 is smaller, 8 and 6 are not smaller. That means the right position of 5 is the third position because there are 2 numbers smaller. So what you do is you put 5 here. 1 probably comes here. So your array is basically 1, 2, 5, 8, 6. And then once you have put 5 in the right position, then you compare all of the remaining elements. What you want is all of the smaller elements are on the left side, all of the bigger elements are on the right side, which in this case has automatically happened. But in case it wasn't, what you would do is you would start from here and you would start another pointer from here. The first number that you find on the right side, which is actually smaller than 5, you'll stop there. You'll try to find the first number from on the left side, which is actually bigger than 5. You'll stop there and then you swap those two guys. So in order n, you'll be able to get to a place where all smaller numbers are on the left side, all bigger numbers are on the right side. And then the problem becomes that 5 is in the right position. Now, as long as I can sort the left side of the array and right side of the array separately, my entire array will be sorted. And that I can again do recursively. So in every step, when I choose a pivot, one number will come at the right position and it will divide the remaining array into 2 parts, 2 smaller subsets that need to be sorted. Do we have to take pivot as the middle to make the swap easier? I mean, so if the thing is when you're choosing the pivot, you don't know which one is the middle element. I mean, you basically start with choosing a random number as the pivot. in the array that you have to sort. If you are unlucky, then it would turn out to be one of the numbers which is either the highest number in the array or the smallest number in the array. If you are, if it is just very, very random, chances are you'll find a pivot somewhere towards the middle. Let me actually go step by step. Does the nuts and bolt approach make some sense? Basically picking one nut, comparing all of the bolts with it to divide them into smaller heap, bigger heap, equal to, and using the equal to bolt to divide the remaining nuts into a smaller heap, bigger heap, equal to. And I know that the equal to part is in the right position. Now I need to sort the smaller heap of nuts and bolts separately, bigger heap of nuts and bolts separately. Let me take another example of this. Actually, here there was a swap. Let's see what kind of thing we can do where we would need a swap. Imagine I still have 5 as the first element. Let's say there is 6, 8, 1, and 2. Hypothetically, let's say this was the array. And again, we chose 5 to be the pivot. If 5 is the pivot, the first step, let's count the number of numbers smaller than 5. 1 and 2. So that means 5 should come at position number 3 in the array. So 5 should come here. So what do? The quickest way is I just swap, right? So I just bring 5 here. I bring back 8 here. So 5 comes here, 8 comes here. I remove the circle. Now I know 5 is the pivot. What I want is all smaller numbers should be on the left. All bigger numbers should be on the right. Right now it is the opposite. So what do? I say that I'll start with a pointer on the left side. Let's call it start pointer. I'll also start with a pointer on the right side. Let's call it the end pointer. Or maybe we can just call it left and right. Both are also okay. Left and right. I compare the first number and I see whether it is in the right half or not. In the correct half or not, right? So 2 is smaller than 5. It should have been in the left half. So it is not in the correct half. So I make my right pointer wait here. My right pointer is currently pointing at 2. Very similarly, I start a loop on left to find the first number which is not in the correct half. In this case, the first number that I find, which is 8, is not in the correct half because 8 is bigger than 5. It should have been on the right half. And then the first place wherever left and right is, I just swap them. So essentially 2 comes here, 8 comes here, and I now know that these two guys are in the right half. So then I again start moving my left till I find the next number which is not in the right half, which is 6. So my left will wait at 6. Very similarly, I start moving right to find the next number which is not in the right half, which would be 1, and I'll just wait at 1. And I end up swapping 1 and 6. So 1 comes here, 6 comes here. So your right pointer will move from this position to this position, and your left pointer will move from this position to this position. If you add these guys up, you'll get total sum as n minus 1, n being the size of the array. This will help you shift all smaller elements to the left of the array, bigger elements to the right of the array. So if I have to write the steps of quicksort, one is choose any number randomly as pivot. And then once you have chosen a pivot, put pivot in the right position. For calculating the right position, you'll have to count numbers smaller than pivot. So this is one order n iteration. Third thing that you do is using left and right pointer, shift smaller numbers in left half, bigger numbers in right. So the fourth step is sort left part and right part separately. Can be optimized by choosing the correct pivot. The most optimal pivot is your median, basically a number which can divide the array into two equal parts. That is the best pivot, right? Because then you're left with smaller arrays to sort. It is obviously faster to sort smaller arrays. However, the problem is it is very hard to know what is the median of the array. Why would you want to spend a lot of time finding out the median? So what quicksort says is, as long as your pivot choice is completely random. If it is completely random, then you're still fine. Average time complexity will still become n log n. All right. What is the approach behind quicksort? Quicksort is essentially choose a pivot, divide the array into smaller numbers, bigger numbers, sort the smaller number separately, sort the bigger number separately. Your array will automatically be sorted. Divide and conquer. Most of the library functions that you use, they use quicksort and they choose pivot randomly. I'll explain why randomly still works here. The one thing which you will notice is in this entire process, we have not used any additional memory. We did the swapping, etc. in place. So we have not created a duplicate array. All of this is happening inside the same array. That is important because while merge sort also is order of n log n, which we will see with quicksort, merge sort uses additional space, or it requires this separate array where you merge the two arrays, which is additional memory required. So one of the reasons why merge sort is not used extensively, but quicksort is used extensively, is because quicksort does not use additional space. The worst case of quicksort is still really bad. Collections, you also use quicksort. Now, since we don't have random access, how does it work? For example, if you use, what you're saying is, let's say if we have implemented the list with a linked list, then how would the quick sort sort of work there? Because here, I mean, if you see in the quick sort, you're not really doing random access. All of your access is still sequential, right? For example, let us go step by step. We say let's choose any number randomly as pivot. I can take a loop till the number, because I'll still anyhow have to take an order n loop throughout the entire list to count the number of numbers smaller, so that I know what is the right position. I'll have to do that anyway. So I take a linear loop to get to the number. That's fine. I take a linear loop to find out the right position. And again, I do the same thing. I anyhow have to split the numbers into left and right pointer. I can take a linear loop for that. So in all of this case, if you see, I'm not doing any random access. I'm actually going step by step in a linear loop. Let's do, what is the time complexity analysis? Let's do, what is best case? What is worst case? And what is average case? What is the best case with quicksort? What is the best pivot you can choose? Assuming that the array is not already sorted, what is the best pivot you can choose? Median. Let's say you were very lucky and you were choosing the middle element all of the time. What would happen is, if you were given an array of size n, you would put the median in the right place. So median would be in the right place. And then you'll have an n by 2 size array here, n by 2 size array here. You'll need to sort these separately. So what happens is exactly like merge sort. You start with an array of size n. This reduces to sorting array of size n by 2 twice. One on the left side, one on the right side. That becomes, I mean, basically time to sort an array of size n is the same as 2 times tn by 2 plus order of n for merging. And this basically comes to order of n log n. So if you are choosing the median as the pivot all of the time, then you end up sorting it in order of n log n, if you are choosing the median as the pivot every time. And by the way, this is probably not the best case. Best case is when the array is already sorted. Best case meaning that if you're given an array and then your median is the best, right? So you end up sorting in order of n log n. What is the worst case? I mean, what is the worst kind of pivot you can choose? One end, when your pivot is actually on one of the ends. So what happens is, in one step, in order of n, what you would do is you'll end up choosing a pivot that is on one end. So your pivot is here, and you'll find all of the other remaining n minus 1 elements are on one side, which means that in one order n loop, you have only fixed the position of one element, and you still have n minus 1 numbers to be sorted. And if you keep doing that again and again, if you're extremely unlucky, your time to sort will become n plus n minus 1 plus n minus 2 plus n minus 3 plus n minus 4, which is order of n square. So your worst case becomes order of n square. If you are very, very unlucky that you're choosing the extremes as your median all of the time. Does this make sense? Why is the best case order of n log n? Why is the worst case order of n square? Just in terms of how we choose the pivot. If we are really, really good with choosing the pivot, then we end up choosing the median as the pivot. That means it divides the array into 2 equal halves, which is exactly the kind of thing that we did in merge sort, right? Like you start with an array of size n, you end up with 2 equal halves of size n by 2 each, which you have to sort, which again will split further into n by 4 if you again choose median. This tree will have log n number of levels. On every level, you're doing order n operation. So your becomes the best case. If you're choosing the best pivot, then it becomes n into log n. If you are choosing the median as the pivot, then you'll have order of n log n complexity. That is clear to everybody, right? Okay. What is the worst case? Worst case is when you're choosing one of the pivot. Your time to solve or sort n sized array is in order n, you were able to fix the position of one element. The other n minus 1 still need to be sorted. And if I just expand on what tn minus 1 would look like, it would be n minus 1 plus tn minus 2, which is what? N plus n minus 1 plus, what is tn minus 2? N minus 2 plus tn minus 3, which if you keep adding up will become n square. I was not talking about the best case really. I was talking about given an array. If let's say I had flexibility on what I choose as the median. So what kind of pivot? What kind of pivot will give me the best complexity? What kind of pivot will give me the worst complexity? That was what I was looking at. Right. So what is the average case complexity? one algorithm that I wanted to address, which is called bucket sort. If you guys remember, we did something called a count sort, right? Which is when the elements were in limited range. We would just count the frequency of elements and that would help us sort. Bucket sort is a slight variant of that. Variant being that if I can categorize numbers into buckets where I know the buckets are sorted in some fashion, then the sorting problem becomes easier for me. Radix sort is exactly bucket sort. For example, hypothetically, let's say you had a lot of numbers. So let's say I had 456, 923, let's say I had 150, let's say I had 268, and let's say I had 12. And maybe I also have 950. Now imagine I was to create 10 buckets. 10 buckets. Bucket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is for the most significant digit of the number. Let's say the 100th place of the number, assuming that all of the numbers are smaller than 1000. They can be 1 million, 10 million as well. So then we'll choose the most significant bit and we'll keep it the same position for all numbers. If I do that, then I know that 423 will go in the fourth bucket. Most significant digit is 4. Most significant digit here, assuming for all of them, the most significant digit that we're looking at is the third digit from the back. So 923 will go in the 9 bucket. 150 will go in the 1 bucket. 268 will go in the 2 bucket. 012 will go in 0 bucket. 950 will go in the 9 bucket. What I know is, now if I start going bucket by bucket, and I have sorted the numbers within a bucket, and if I just start picking numbers from here and appending them, then I end up getting the entire array sorted. Why? Because I definitely know that any number that is starting with 0 is definitely going to be smaller than any number starting with 1. So dividing them into buckets and then sorting the buckets within themselves, sorting the numbers within a single bucket, that helps me reduce the complexity to some extent. And I'll show you an example of that to a major degree, which is what is called as radix sort. But the idea is, if I can break them into buckets where buckets already have some ordering defined, then my job becomes just simply appending the numbers in the buckets, and that might give me a sorted array. And I'll give you a few examples to sort of talk about what bucket sorting is. And we'll do one problem on bucket sorting as well, which is a hard problem, but we'll do that. What kind of data structure can I use for buckets? Think of them as, for example, vector of int. So for example, your v of 0 is a vector of numbers. V of 1 is also a vector of numbers, and then so forth. So the concept of bucket sort is very simple. If you can split numbers into buckets, where buckets themselves are ordered in some fashion, then I can sort numbers within the buckets, and then I merge them. That gives me a sorted answer. If numbers are not on the same order, how do we put them in bucket? So even here, if you see, like 12 was not of the same order. I just added another 0 to get it to the same order. So imagine I have numbers as 950, 1, 12, 923, 256. I'll just add 0 to make sure they're all of same length. How do we keep the values sorted in one bucket? Within the bucket, just use quick sort or whatever kind of sorting you want to use there. Insertion sort, quick sort, whatever you want to use. Let's take an example. Bucket sort alone isn't enough. Bucket sort paired up with a few observations is actually very powerful. So one observation that leads to sorting algorithm is called radix sort. The way radix sort works, imagine again you have a bunch of numbers to sort, right? Again, I'll pick the same thing, which is, let's say I have 923, 950. Let's say I have 12. Let's say I have the number 1. Let's say I have number 100. Let's say I have 150. Let's say I have 650 and 688. Hypothetically, let's say I have a bunch of these numbers. So what radix sort says is, look, at the end, if I was at the end, let's make all of these guys equal length. So add zeros wherever applicable. If all of these numbers are of equal length, then at the end, most significant bit, this bit, is the most important bit. Obviously, if the most significant bit of one number is smaller than the other number, then the overall number is definitely smaller. It is only a problem when they both are equal. Then I will look at other digits. So I know that. So what I want to do is, I want to start sorting digit by digit, with most significant digit being the last place where I sort, because I know this is the final step. So what radix sort does is, it says, let's start with the least significant digit. Let's first sort based on this. And what do? I basically create, again, 10 buckets corresponding to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I will first look at the last digit. Based on that, 923 goes here, 950 goes to 0, 012 goes to 2, 001 goes here, 100 goes to 0, 150 goes to 0, 650 also goes to 0, 688 goes here. And then I append these guys, right? What will happen once I have done this step? All of the numbers will be sorted by their last digit. So I get 950, 100, 150, 650, 001, 012, 923, and 688. I sorted numbers based on their last digit. Now let's look at the next digit. I repeat the same process again, but with the next digit now. I'm going to erase all of these guys from here. We are now going to look at the second digit. I say that now let's look at these numbers again, one by one. But the second digit is what we are looking at. So 950 goes at 5. 100 goes at 0. 150 goes again at 5. 650 also goes at 5. 001 goes at 0. 012 goes at 1. 923 goes to 2. And 688 goes to 8. I'll again append these guys. What this would make sure is now everything is sorted based on the last two digits. So I append, and when I append, I basically get 100, 001, 012, 923, 950, 150, 650, and 688. And now the last step is the magic step, which is where I look at the most significant bit. So I erase all of this again. I look at the most significant bit and I bucketize these guys based on the most significant bit. So 100 comes here, 001 comes here, 012 comes here, 923, 950, 150, 650, and 688. Now once I append them, all of the numbers should be sorted, which you would see 001, 012, 100, 150, 650, 688, 923, 950. Now this final array that we've gotten, this is sorted. What has happened? We can take MSB directly. The only problem is then within the bucket, if you have multiple numbers, and think of like when you have 1,000,000 numbers, right? You only have 10 buckets based on MSB. That means every bucket on average will have 100,000 numbers. And if you go to solve or sort of sort each of those buckets separately, it will take you a lot of time. But here, I can sort the entire array by doing this function, the number of digits number of times. So imagine all of the numbers had 5 digits. I'll do this operation 5 number of times and my entire array would be sorted. For every single digit, I am putting them in buckets, 10 buckets, and then I'm appending them, which is an order n operation, right? So my total amount of time taken is order n into max number of digits. Space is assuming that we are taking a vector of vector. The total space taken by vector of vector combined across all of this is order of n. So I'm using an order on n extra space. Actually, order of 10 plus n, which is order n. Do we need to compare an element with the existing elements present in the bucket? No. Right now, because the moment you start doing that, then your complexity increases. Currently, it is just very dumb way of appending to existing numbers in the bucket. Why can't we take MSB to LSB? I mean, when we start with MSB, in the first step, we would definitely have put the bigger numbers to the first half of the array, the smaller numbers to the second half of the array. That I completely agree with. In fact, numbers would be sorted based on their first digit. But as you go to the second digit, within these numbers, if the sorting is happening in the right way or not, because you'll have, let's say you look at second digit as 0, right? Now, some of those 0 numbers will come from the numbers that had the first digit as 9. Some of those 0 numbers will come with some numbers where the first digit was 6. For example, let's look at this example itself, right? If I started from MSB, then what would have happened? Let me erase this. My first 2 numbers will go in the 9 bucket, 923, 950, 012, 001, 100, 150, 650, and 688, which is great. Now, if I append them, then I get this, which is almost sorted. The problem is when I move to the next digit, it's then that it becomes a problem, because 012 will come here, 001 will come here. Now 100 will also come here. However, I know that 100 should only come after 012. When I will merge, then I wouldn't know how to maintain this ordering. I mean, I'm using digits here. You can do the same thing for bits. There you will only have 2 buckets, 0 and 1. Here I have 10 buckets. You'll only have 2 buckets when you're dealing with bits. When you go from LSB to MSB, that means MSB takes higher priority because it is the last deciding factor. When you go from MSB to LSB, then LSB starts taking higher priority. So time complexity is n into number of digits. If D is the number of digits, that is your time complexity. Usually, the number of digits is the same order as log n. It's actually log n to the base 10, n being the maximum number in the array. Number in array. So, usually radix sort is good number to know and good approach to know because this can be applied at multiple places. That being said, again, like not very commonly used because n log n, you can just directly use your sort function. Why would you go and take the pain of implementing radix sort when it has very similar time complexity? If all of what we have discussed till now, if that makes sense, I'll give you one problem which will actually make the bucket sort even clearer. The reason why we have bucket sort. Explain the time complexity again. So if you look here, what are we doing? We are taking digit by digit, right? So first we look at the last digit. And for that digit, what do? We put them in these 10 buckets, right? So basically what happens is, what is the last digit of any number? Let's say I do this, right? I say I goes from 0 to n and we calculate the last digit. Digit is equal to array of I mod 10. That is your last digit. And then you put it in the same bucket. So for example, let's say if you have bucket array, you say bucket of digit dot add AI, right? You do that. All of this is order n process for the last digit, correct? And then eventually I'll basically look at numbers in every bucket and I'll keep appending them in another array. All of this is order n process. I'll have to do this for every digit, correct? So if all numbers have, let's say 5 digits, then my complexity would be n into 5 because for every digit I'll do an order n operation. If every number has d digit, then it becomes order of n into d. How n log n is similar to n into d. So n into d makes sense, right? Order of the algorithm is n into d. That makes sense. Correct. Okay. Now what is d? What is given a number x, what is the number of digits that x would have? How do you find that? Basically, how do you find number of digits? You basically divide x by 10. You check if it is 0 yet. Then you again divide it by 10 further, which is 10 power 2. Then you divide x by 10 power 3, x by 10 power 4, 10 power 5, and so forth, right? When x by 10 to the power I is 0, which is like now 10 power I has become bigger, then that is where you have the number of digits, okay? If I just put it like this, basically if x has I digits, then x is approximately equal to 10 raised per I. Approximately, which means if I take log 10 on both sides, then I basically get I is equal to log of x. That you agree? So if there is a number x, then x has basically log base 10 x number of digits. So therefore I'd say like whatever is the highest number in the array, then d is basically log of that highest number. So your d is almost the same as n log x being the highest number. So bucket sort is more generic. Right? Like bucket sort just says, hey, look, my fundamental is you can create any sort of bucket you want. You can create a bucket of all numbers from 1 to 100, all numbers from 100 to 1000, all numbers from 2000 to 3000. You could create any bucket that you want as long as it covers all range. You put numbers in the bucket where you know that every number in bucket 1 is going to be smaller than every number in bucket 2. So you just bucketize these numbers, you sort them separately, and then you append. That becomes bucket sort. It is very generic. Radix sort is using bucket sort in one way. Why this type of bucketing works? Going for all positions instead of just MSB or LSB. Let's say if you just go for MSB, there wherever two numbers have different MSB, most significant digit, there, you probably can only do with most significant digit. The problem is there will be a few numbers that will have the same most significant digit. In fact, there are only 10 possible most significant digit, right? So if you have, let's say 1000 numbers, then on average, you'll have 100 numbers in every bucket, right? For example, here as well, I had 950 and 923. They'll all go to the 9 bucket. Now, how to actually decide the ordering between these? In fact, if you have a lot of numbers in the bucket, then how do you figure out the ordering between those? That is not clear. So therefore, you can't decide only based on most significant digit. You'll need to somehow sort these guys within who have the most significant bit as 9 as well, right? Internally, you'll need to sort them. So there are two ways. One is like you just say, I'll bucketize based on the most significant digit and I will sort each bucket, right? So what happens is if I had n numbers, then on average, each of the buckets will have n by 10 numbers. To sort them, I'll take n by 10 log n by 10. and I'll have 10 such buckets. So I'll finally multiply by 10. This will give me n log n by 10, which is the same as n log n. So I end up reaching the same algorithm which I have anyhow done before. This does not seem to be an improvement. So therefore I said, like, can I improve further on it? And there we said, maybe if instead of saying that we'll sort the numbers in the same bucket, if we could do bucket sort multiple times in a way where at the end of it, all of them would have been sorted, then that would be nice. So I say, you know what, like, for the sorting based on the most significant bit, one thing is if I can somehow reach a state where numbers with the same most significant bit, they are already sorted in some way, that would be awesome. But to sort the numbers with the same most significant bit, for example, if you remove the most significant bit, you'll need to sort them by the remaining bits. There also, if you just again break it down recursively, you'll reach the same state. Like, you'll first have to sort based on the least significant bit, then the least significant and most significant together, and then the last three together, last four together, and so forth. In radix, you have log base 10 of not the number of elements. I mean, so in n log n is number of elements. This is log base 10 x, which is the highest element in the array. This is not the number of elements. This is highest element in array. Two different things. But yeah, I mean, in cases of log n, if you have, let's say, 1 million entries, 10 power 6 entries or 10 power 7 entries, the log n is typically 20, 22, 24. In the case of numbers, the number of digit is probably still 8 or 9. So it can perform twice as faster. If max is less than n, go for radix sort. That I wouldn't say. If your log of 10 max is less than, in fact, significantly less than log n, then go for radix sort. Okay. In case of integer, we could use radix. That's why I said, like, if your log of max is less than log of n, you could use radix. That might run just slightly faster. Even if you go with bits, yes, you will eventually end up sorting. Just that the number of iterations will be more. All right, let's move to the next problem. Imagine you're given a bunch of numbers, which are not sorted, by the way. So let's say you have 5, 8, 3, 1, 6, some numbers, right? And you've been given this array that you cannot modify. So this is a constant array. Cannot be modified. Now what you need is that if this array was sorted, let's say if this array was sorted, the numbers would be 1, 3, 5, 6, 8. Actually, let me change the numbers a little bit. Let's say this number was 7, right? If this number was 7, then the numbers would be 1, 3, 6, 7, 8. And then in the sorted array, if you were to look at adjacent difference, the difference here is 2, difference here is 3, difference here is 1, and difference here is 1. There you have to find out what is the maximum gap between the numbers when the array is sorted. In this case, the maximum gap is 3. So you say the answer is 3. So given an array, how do you find this maximum gap if the given array is constant? And obviously, like, one answer is you make a copy of this array, you sort the array, and you look at the adjacent differences and you take the maximum of that, which becomes time complexity order of n log n, space complexity order of n. Can you do something better than this? I'll repeat the question once more. You're given an unsorted array. The array is not sorted. What you have to find is if the array was sorted, and if you looked at the adjacent numbers differences, what is the maximum difference you can find? What is the max gap you can find?
Hey folks, I welcome you all to Scalar Academy's YouTube channel. So if you want to be a good programmer, then you need to have a good mathematical aptitude. Or in other words, you need to have mathematical way of thinking to solve the coding problems which you face. So understanding the importance of this, we have brought you this tutorial on mathematics for programming. Now, before we start off, I'd like to request you guys to subscribe to our channel and also hit the bell icon so that you do not miss out on our upcoming videos. So on that note, let's get started.
Hello, so we are back with a live class. Today's topic is factorization. These classes are for people who want to become better programmers, right? Better at DSN algorithms. So please make sure that you subscribe to the channel and press the bell icon to get notifications, right, about any new videos. As always, there will also be a practice set available to you. This practice set will have a few problems so that you can apply whatever you learn in today's class, right,
actually applying, actually practicing the problems will help solidify the concepts. All right. So we are going to cover factorization today. Now, factorization is a topic of mathematics. All right. And as computer programmers, you will need to have a decent understanding of mathematics. In fact, I mean, in all sciences, and computer science is a science, right? The stronger you are at maths, the easier your life will be. Now, programmers, I mean, you don't have to be very good at mathematics, but there are certain areas that you need to focus on to be a good programmer. Now, these topics are like discrete math, probability, statistics, combinatorics, linear algebra, modular arithmetic, number theory, graph theory, right? So it is still a very large section of topics that you will need to be a very good programmer. So we're going to start with that. And today's topic is from number theory, and the topic is factorization. All right. So let us begin. All right. Cool. So before we begin, let us start with a question directly, right? Let us say that you have been given a number n, all right? And this is an integer. This is an integer. In fact, this is a positive integer, right? Your task is to find all the factors of this number, right? So for example, let us suppose that you have a number like 16, perhaps, right? So can someone tell me all the factors of 60? What all numbers is 60 divisible by? So when we're talking about factors, we are talking about the positive numbers, right? The positive integers that divide 60, right? And do not leave a remainder. So what numbers are those? So firstly, we have 1, right? Then does 2 divide 60? Yes, it does. So we have 2. Similarly, 3 divides 60. 4 also divides 60. 5 does. 6 does. 7 does not really divide 60, right? Now 8 also does not divide 60. Neither does 9. 10 does. Right? 10 definitely divides 60. After that, what numbers we have? So we have 12, right? Then we have 15. Then we have 20, right? What more? We have 30 and 60, right? So these are all the different factors of 60, right? Cool. Now, before we dive further into this problem, let us try to draw some observations. Right? Let us try to draw some observations and see if there is some pattern to what the factors of a particular number are, right? So first of all, you will notice that 1 and the number itself, they are always factors of this number. Yes, do you agree? Well, 1 divides every single number, and if you have a number, let us say n, then that number will divide itself, right? So that has to be a factor. What else do we notice over here? Is there any other pattern that we notice over here? Yes? So we notice one more thing. So the first thing is that 1 and n are divisors of n. The second thing that we notice is that factors come in pairs. Factors come in pairs. What do I mean by that? I mean that given any factor, there is a corresponding factor, right? So if I pair 1 with 60, then I will get 60, right? 1 times 60 equals to 60. Similarly, if I pair 2 with 30, then I once again get 60. So 2 times 30 is 60. Similarly, 3 times 20 is 60. 4 times 15 is 60. 5 times 12 is 60. 6 times 10 is 60, right? And then if I continue from here on, you will see that I will just repeat these things, right? So I will just repeat these things. I will say 10 times 6 is 60, right? So 10 and 6 have been repeated. Similarly, I will next say 12 times 5 is 60. So after all this, the numbers are being repeated. Is that clear? The factors will always come in pairs, right? That is the main observation that we draw from here. All right. Now, given that we have these observations, could we write a program? Could we write a function, let us say find factors, right? That takes an integer n. and let's suppose prints out all the factors of n. So let us in fact call this, instead of find n, let us call this print factors. This function accepts an n, and it is supposed to print out all the different factors of n. Right. So what approach do we see over here? What approach do we see over here? So one way to do this would be the naive way, right? The very, very simple way. The first way would be to go through all the numbers. Go through all the possible devices. Right? So to go through all the possible devices, we will need a few more observations, right? Let us quickly see what those observations are. So the first observation was that 1 and n are devices of n. There is one hidden observation over here. Right? Let me mark this as the third observation. And that observation is there are no devices that are less than 1, and there are no devices that are greater than n. Right? So the divisors, so 1 is the smallest divisor and n is the largest divisor. Yes? Does that make sense? So when I am trying to find the divisors of a particular number, I only have to go from 1 all the way till n. Right? Because I cannot have divisors that are greater than n. Does that make sense? Is that part clear? Right? Perfect. So how do we write this program then? This is a very simple for loop. So we will say for I goes from 1, right, all the way till n, and we'll increment I. So we'll go through all the different numbers. What we will do inside this? We will check if n mod I equals to 0. Right? So everyone is familiar with this mod operation, right? This is the remainder operation. This says that when we divide n by I, then what is the remainder? Is that remainder 0? If that remainder is 0, then I must be a factor. Right? I must be a factor. Then what do? We simply print I. Right? So this is our code for factorization. Right? Cool. Now this is the first approach. This is very naive. We can do much better than this. But why is this naive? So let us analyze the time complexity of this particular program. So how much time does this take? If I have a number n, then what is the time complexity of this particular program? Well, this is a simple for loop, right? We are going from 1 all the way till n. So this is linear. In fact, this takes order of n time. Right? Cool. Can we do better? Well, certainly we can. So the first thing that you will notice over here is that whenever you are looking at these numbers, we know that the largest factor is the number itself. Right? The largest factor is the number itself. But what is the second largest factor? How big can the second largest factor be? So I know that the largest factor is n itself. Right? What about the second largest factor? Second largest, that must be less than or equal to n by 2. Right? That factor must be less than or equal to n by 2. Why? Because if it is greater than n by 2, then its corresponding pair, right? Divisors always come in pair. Right? Factors always come in pair. Its corresponding pair will not be an integer. Right? 2 is the smallest integer that might divide this number apart from 1. Right? So we know that the second largest has to be less than or equal to n by 2. So one thing that we can do over here right away is, instead of having this loop from 1 till n, right? We can modify this. Right? So let me just modify this over here. I will say I is less than or equal to n by 2. Right? And notice that this is integer division over here. Right? So in this loop, I will print all these divisors, but now I do not print n, right? I have missed n now. So I will have to add another statement over here, which will simply say print n. Is that clear? Because now our loop is going from 1 all the way to n by 2. So I will not print out n in this loop. I'll have to print it separately. Yes? So how much time did we save just now? We made a program twice as fast. Right? That's very nice, right? We certainly made a program twice as fast. Asymptotically, it is still linear. Right? It is still order of n time, but practically it is twice as fast. Right? Perfect. All right. So can we extend this? Can we extend this observation further? What about the third largest factor? What about the third largest factor? How large can that be? Well, if the number is divisible by 3, then the third largest factor can be up till n by 3, right? Does that make sense? So third largest factor has to be at max. It has to be less than or equal to n by 3. Similarly, the fourth largest factor has to be less than or equal to n by 4, right? And so on. So we see this pattern over here. Is that clear? Cool. Now the question is, we could use this particular observation to reduce our time complexity by half. How do we utilize all these observations? How do we really utilize all these observations? So to do this, let us make one more observation. Right? Let us actually go back to this observation that we had previously. Let us look at this thing once again. Okay. So let us say that instead of going from 1 all the way till 60, right? Instead of going from 1 all the way till 60, we only go till this midway point. Right? You clearly see that there is this midway point over here. After this midway point, so this is the midpoint. After this midpoint, the numbers will repeat. Yes, 6 into 10 repeats as 10 into 6. 5 into 12 will be repeated as 12 into 5, and so on. Right? So we only need to go till this particular point. We only need to consider this half. We do not need to consider the other half. All right. So if we are considering this half, then we have to go from 1 all the way till what number? We have to go from 1 all the way till this number. How do we find what this number is? How do we find what this number is? So basically, we are looking for a number I, right? We are looking for a number I such that I times something else. First of all, this should be equal to n, right? Because they are numbers, they are factors, right? So I times something should be equal to n. Secondly, I am looking for a number such that I is less than or equal to this something, right? Because so basically, I'm going till 6 because the pair of 6 or the number which is paired with 6 is greater than 6, right? 10 is greater than 6. If I go any higher, then the numbers will swap. 10 will now become, the first number will become greater than 6 now, right? So we are looking for a number over here that follows this property. Okay, so if this is x, then what can I say from here? I can say that x equals to n divided by I. Right, so I can put the value of x over here. I will get I is less than or equal to n divided by I. What can I get from this? I can move this I to the left hand side. Right, so I will get I squared is less than or equal to n. And what does this tell me? This tells me that these numbers, they must be less than or equal to. So I must be less than or equal to square root of n. Is this part clear? Is this derivation clear? This is very simple. A lot of you might already know this, but it is important from where this is derived. Right? This square root sign, this is not magic. All right. So once again, we are saying that we are looking for a number I, we are looking for a factor I, such that its paired factor, when we multiply them, we get n. Right? They are factors. Now we are also saying that, okay, we are going to make sure that this factor must be less than or equal to its pair. Right? This factor must be less than or equal to its pair, because if it is greater than its pair, then we are just repeating ourselves. Right? Because 2 times 3 is the same as 3 times 2. So we only need to make sure that this number is smaller than this number. Otherwise, we will be repeating ourselves. So we put this in the equation. We say I is less than or equal to n by I, which means that I square is less than or equal to n, which means that I is less than or equal to square root of n. So what did we get from here? So now we can improve our program. We can now say that we have a for loop for I equals to 1, I less than square root of n, right? Square root of n and I plus plus. I less than or equal to square root of n and I plus plus. Right? Now I will check if in fact n is divisible by I. So what should I print over here? If n is divisible by I should print I, right? I should print I. But is that all? Is that all? No, because I also have to print the other pair. Right? Remember, we are only going to half the pairs down. So we also have to print the other pair. So I will also print n divided by I. Right? N divided by I. Right? And that will complete the list of factors. Is this part clear? Yes? Perfect. Right? Now, first of all, there is a mistake in this program. There is a mistake in this program, a very subtle mistake. Can someone point that out? Yes? Exactly. So over here, let me just point it out. So over here, Lucky says that, hey, this is the mistake, right? What happens when I is actually equal to n by I? Which means that when n is a perfect square, you will be printing this number 2 times, right? That is not very good. You will be printing this 2 times. That is not very good. So how can we fix this? Right. So first of all, is everyone clear? If n is 9, n equals to 9, what we will see? We will see I equals to 1. We will print 1, 9. Right? I equals to 2. We will not print anything. I equals to 3. We will print 3, 3. Right? So we see that we printed 3 2 times. That is not a good thing to do. Right? So we need to resolve this. And we see that this only occurs when n is a perfect square. Right? Otherwise, this issue cannot occur. Right? So how do we resolve this? We simply say that I goes till less than square root of n. Right? I goes till less than square root of n. And after this, we will specially check. After this loop is over, we will check. So after this loop, what will be the value of I? It will be exactly square root of n, if it exists. Right? So we will say if n mod I equals to 0, then print it just once. Right? Print it just once because it is a square root. So just print I. Right? Notice that we are not printing the pair over here. Is that clear? Cool. So this will give us the correct answer. Now the question is, how much time did we save? What is the time complexity? Of this particular code? Yes. So who can tell me that? Well, this is very simple, right? Just like the previous case, we have a simple for loop. And this for loop now goes from 1 all the way till square root of n. So the time complexity is supposed to be order of square root of n. Right? Simple. Is that clear? There is one more thing over here, that if you were actually using a function to calculate the square root of n, you would not do this again and again. Right? You will actually say sqrt or square root equals to, you will calculate the square root of n outside. And then you will just use that variable. Right? So that whenever you hit this condition, you don't have to calculate it again and again and again. Okay? So this will give us the correct code. And the complexity will be order of square root of n. Now that is a huge improvement. Right? That is a huge improvement, going from order of n to order of square root n. This is huge. This is massive. Imagine that you had a number which was, let's say, 100 trillion. Right? 100 trillion. 100 trillion is how much? 100 trillion is how much? It is 10 to the power 14. Right? If you were to check this number, if you were to check a number of this order of magnitude on your computer, it will take a lot of time. Right? How much time will it take? It will take around 10 to the power 5 seconds. Right? Or you can say it will take around 30 hours. It will take around 30 hours of time. Whereas with this particular algorithm, how much time will it take? It will take just 10 to the power 7 operations. So this is 10 to the power 7, square root of 10 to the power 14 is 10 to the power 7. So it will just take how much time? It will take 0.01 seconds. Right? That is amazing. We went from a program that took 30 hours to a program that ran in 1/100th of a second. All right? Cool. So this is how we would factorize a particular number. Okay. So I hope this is clear to everyone. Now let us move on to a question, right? To a related question. Okay. Suppose that we have 100 doors, right? And all these doors are closed. All are closed. So we have basically door number 1 over here, door 2, door 3, door 4, all the way till 98, 99, 100. Right? We have all these different doors, and initially all of them are closed. So let me say that these are closed. Okay. Now we are going to play a game. We are going to play a game. This game will have 100 steps because we have 100 doors. We will have 100 steps. So the first step, in the first step, what will we do? We will toggle all the doors. Right? So you understand what toggle means, right? Toggle means that if it is open, you close it. On the other hand, if it is closed, you open it. Toggle basically means to flip it. Right? Cool. So we will say that in the first step, we will toggle all the doors. In the second step, we will toggle all the doors, all the even doors. Basically, we will toggle every second door. Every second door. Right? In the third step, we will toggle every third door. And so on and so forth. It will continue like this forever. In the 100th step, we will toggle. So there will be just 100, right? We will toggle the 100th door. Right? So this is what we are going to do. Is this part clear? So first of all, what happens after the first? So what happens after the first step? Initially, all of them are closed. After the first step, all of them will be open. Right? Then what will happen? After the second step, we will toggle this every second door once again. So this door will become closed. 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 Right? In the third step, we will once again toggle every third door. So this third door will become closed. There was a sixth door over here. Right? It was initially closed. So we will open it up. Right? And so on and so forth. Does that make sense? So we are doing this thing. That is the game we are playing. The question is that after we are done with this game, after 100 steps, which doors remain open? All right. Is the question clear? Yes, after the third step, we will toggle every fourth. So in the fourth step, we will toggle every fourth door. In the ith step, we will toggle every ith door. Right? And the question is, after all these 100 steps, which doors will remain open? Okay. All right. So, I mean, this 100 is a very, very large number, right? So let us actually reduce the problem. So whenever you have a difficult problem, you try to check that problem on smaller numbers, right? So let us say that we only have 10 doors. Okay, we only have 10 doors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Initially, all of them are closed. Okay. What happens after the first step? So this is the 0th step. This is step 0. Step 1, step 2, step 3, step 4, 5, 6, 7, 8, 9, 10. Right? What happens after the first step? After the first step, every door is open. Right? After the second step, what happens? After the second step, what happens? So after the second step, 1 is open, 2 is closed, 3 is open, 4 is closed, 5 is open, 6 is closed. Right? 7, 9, these are closed now. What happens in the third step? In the third step, 1, we do not change it. 2, we do not change it. 3 was open, right? 3 was open, so we will close it. 4, we do not touch it. 5, we do not touch it. 6 was closed, so we will open it. 7, we do not touch. 7 remains as it is. 8, we do not touch. 9 was open, so we will close it. 10, we do not touch. Yes? Okay, we move on. So in the fourth step, we will keep 1. We will not touch this. We will not touch this. This was closed, so we will open it. We will not touch this. We will not touch this. We will not touch this. This was closed, so we will open it. We will not touch this, and we will not touch this. And so on and so forth. So can someone see what is happening over here? Can someone see what is happening over here? Basically, what happens in the ith step? What happens in the ith step? Exactly. So Srinivas has the right idea over here. Srinivas says that in the ith step, all the doors all the doors that are divisible by I get toggled. Right? That is the problem over here. Now the question is, let us suppose that I am talking about the nth door. Right? Let us suppose that I am talking about the nth door. For which all numbers, for which all steps will toggle this door? Will toggle this door. Right? So is the question clear? If in the ith step I toggle every ith door, then given a door number, right? Given that I am saying that, okay, let's talk about the 20th door. Right? Let's talk about the 20th door. Then in which all steps will this 20th door be toggled? In which all steps will this 20th door be toggled? All the factors of n. Exactly. Right? All the factors of n. Yes. So basically 20th door will be toggled in the first step, in the second step, fourth step, fifth step, 10th and 20th step. Is that clear? Yes, because these are all the factors of 20. Cool. So how many times will this door be toggled? How many times will this door be toggled? Well, we already know that factors come in pairs. Right? Which means that if there is a step number 1 on which this is toggled, there is also a step number 20 on which there is toggle. Right? Similarly, for step number 2, we have step number 10. For step number 4, we have step number 5. Right? So we know that the nth door will be always toggled, an even number of times. Right? Because why is this true? Because the factors will come in pairs. Right? So every door is going to be toggled an even number of times. Is that correct? Well, not so fast. Is there any particular number which has an odd number of factors? Right? What happens? So you have this pairs coming up. Right? You have these pairs coming up. What if there is a middle value? What if n is a perfect square? In that case, this value root n, it doesn't have a pair. Right? Root n is going to pair with itself. So it will not have a pair. So basically, if the nth door, so if n is a perfect square, right? If n is perfect square, then nth door will be toggled an odd number of times. Right? In all other cases, it will be toggled an even number of times. Is that clear? Yes. All right. Cool. So what happens if you toggle a door even number of times? Initially, it was closed. Then it became open. Then it became closed. Then it became open. If we do this an even number of times, what will the end state be? It will be closed. Right? Because we started with closed, we toggled it even number of times. So eventually it will be closed. On the other hand, when n is a perfect square, we will toggle it odd number of times. So what will be the final state? We started with closed, we move to open, we move to close. Since we will do this odd number of times, the final state will be open. Right? So which all doors will be open? Now we know the answer. Which all doors will be open? All the doors whose numbers are perfect squares. Right? And all the doors from 1 to 100, which all doors are those? So that is 1, then 4, 9, 16, 25, 36. Then what do we have? 49, 64, 81 and 100. Right? Exactly 10 doors will remain open, and all these are the doors that will remain open. Is that clear? No. If n is prime, the answer will be even. So Vishwajit has a question over here. Vishwajit says that if n is prime, then how many factors does it have? Well, for any prime number, it has 2 factors, right? 1 and n itself. So for prime numbers, it will be even, not odd. Only for perfect squares, will we have odd number of factors. All right? Cool. Okay. So what did we learn from this particular problem? This was not a very difficult problem, right? This also does not involve a lot of programming. We did not do anything fancy. We did not do any fancy maths over here. All we did was we sat down, we made some observations, right? We made some observations. We looked at the problem, we tried it with a smaller number. Instead of going to directly 100, we tried it with a smaller number. So that is something that you have to keep in mind, right? Whenever you're facing a problem, whenever you're facing an algorithmic problem or any problem in life, please, your first step should not be to come up with a solution. That is a very, very wrong way of doing things. The first step should be to make observations. Make observations. Right? Once you do this, only then you will be able to find a solution. Find a solution. If you do not make observations, you will never be able to find a solution. All right. So please do not skip this step. Okay. Cool. So that was a nice little exercise. Let us go back to what we were doing earlier, right? So first of all, what we did was we found all the factors. Found all the factors of n, right? That is the first thing that we did. Now, while we were doing this, we kept talking about something, right? We kept talking about prime numbers. We kept talking about prime numbers. So first of all, can someone quickly tell me what a prime number is? So what is the definition of a prime number? What is the definition of a prime number? A prime number, so first of all, it has to be a positive and it has to be an integer. Right? It has to be a positive integer. Secondly, it must have exactly 2 divisors. Right? It must have exactly 2 divisors. There is a lot of people think that this is the definition of prime numbers, right? A lot of people think that a prime number is a number which is divisible by 1 and itself. Right? By 1 and itself. If this was the definition of prime numbers, then 1 would be a prime number. Right? Then 1 would be a prime number because, hey, 1 is divisible by 1 and 1 is divisible by itself. But 1 is not a prime number. All right? Is that clear? So this is not the correct definition. This is very close, but this is not the correct definition. The correct definition is that it must have exactly 2 divisors. Exactly 2 distinct divisors. Right? So can someone very quickly tell me what the prime numbers are? A few prime numbers from the start. So is 0 prime? Is 0 prime? No, it is not. Is 1 prime? No, it is not. Is 2 prime? Yes, 2 is prime. 2 is the smallest prime number. Then 3 is prime. 4 is not prime. 5 is prime. 6 is not prime. 7 is prime. 8 is not prime. 9 is not prime. 10 is not prime. 11 is prime, and so on. Right? How many prime numbers are there? How many prime numbers are there? 100, 200, 500, 1000, million, billion. How many prime numbers are there? There are infinitely many prime numbers. Infinitely many prime numbers, right? Everyone knows this? Cool. There's a very simple proof for this as well. All right. Okay. So now that we know the definition of a prime number, some people are saying 4 prime numbers are there. That's nice. Suppose now that we know the definition of prime numbers, can we write a program? Can we check if a number is prime? Right? So we know that the definition of prime number is a number which has exactly 2 divisors and it is a positive integer. So given a number, can we check if it is prime? So is prime, right? It is going to return a boolean and it is going to take an integer. Yes. So how can we write this program? So very simple, right? Very simple. We can say that count is 0, right? We can write a loop for I equals to 1, I less than equal to n, I plus plus, right? And we can check if n mod I equals to 0, then we will do count plus plus, right? And finally we will return what? If the count is exactly equal to 2, then it is prime, otherwise it is not prime. Yes? right? Cool. What is the time complexity of this program? What is the time complexity of this program? This program runs in order of n time. We already know that we can optimize this a lot. Right? We already know that we can. So Suraj says why Boolean. So this is prime will return true or false, right? It will return true or false. True if the number is prime, false if it is not. Right? Which is why we are returning a Boolean. TechGeos is asking, sir, just confirming, is this code Java, right? So this might not exactly be Java. For example, in Java, you will have to put a semicolon over here, right? I'm not sure if you write bool or boolean in Java. I kind of forgot, but the rest of it pretty much looks like Java, right? Pretty much looks like Java if we add these semicolons. This will also work in C++, almost exactly the same way, right? However, when we are doing these classes, we will not be following any particular programming language. If you have any questions of a particular programming language, that let's say if you want to ask, okay, how will I do this in Rust, or how will I do this in Haskell, or how will I do this in, let's say, Python, right? So you feel free to ask that. Okay, feel free to ask that. I will be able to give you an answer for most common programming languages. However, we will not be focusing on the programming language in this particular class, right? We will be focusing on the pseudocode. We will be focusing on the intuition. Okay, cool. Okay, all right. So we see that this is linear in time, but we already know that we can improve this a lot, right? So how can we improve this? Instead of going from 1 to n, we can go from, so if 1 is a factor, right? If n is a factor, right? And prime numbers have exactly 2 factors. What does this mean? What does this mean? This means that if n is prime, if n is in fact prime, then it must not have any factor, not have any factor between 2 all the way till n minus 1. Yes, is that clear? It must not have any factor between 2 all the way till n minus 1. In fact, it must not have any factor between 2 all the way till n by 2. In fact, we can even generalize this and we can say that a prime number does not have any factors between 2 all the way till square root of n, right? Because we see that the factors will come in pairs. Right? The factors will come in pairs. Is that clear? So we can improve this code a lot. We can improve this code a lot. We can say Boolean is prime, right? We have an integer n, and we will say, so now we don't need that count anymore, right? Because we are just checking if there is a prime factor or not, if there's a factor or not. So we can say for I goes from 2 all the way till square root of n, I plus plus, right? If there is any factor, if n mod I equals to 0, if we did find a factor, then what can we say? If we did find a factor, then what can we say? Hey, we found a factor, so it must not be prime. If you found a factor between 2 and square root of n, it cannot be prime. So we'll just return false. Return false over here. Right? And after this loop is done, we will return true. Because if we did not find any factors except for 1 and n, then the number must be prime. Is this clear? And the time complexity of this code is? The time complexity of this code is order of square root of n. Right? Perfect. So we know that we can check if a number is prime in order of n time as well. Now, one question, it's not, I mean, we are not going to teach that today in the class, but one very common question is this the fastest we can do? Is this the fastest we can do? And the answer is no. The answer is no. In fact, primality testing, this is in P, right? This is in P. P stands for the polynomial time algorithms, right? I'm not sure if you have heard of P versus NP, right? But primality testing is in P. That means that we can check for primality in log n time, right? In order of log n time. All right, we will not be going over this particular algorithm today. So there are several algorithms. One of the most famous ones is the AKS primality test, right? Okay, But primality can be checked in order of log n. It is in P, right? And no, this is different from sieve of Eratosthenes. Right? This is different from the sieval word. This is a different thing. Okay. Cool. So if someone asks you how much time does it take to check if a number is prime, the answer is log n. Right? You can test primality in polynomial time. Okay. Cool. Vikas says, what if n equals to 5? So Vikas has a question over here. Let us look at this code and see what happens when n equals to 5. Does this code work correctly? Right. So let us try that. So what happens? So first of all, we will say I equals to 2. Right. So we will first come over here. We will check I equals to 2. Then we will move on to the condition. We will move on to this condition. Right. That is how a for loop works. We initialize, we check the condition, we go inside the block, we increment, and we check the condition again. Right? So we will check this condition. Well, what is the square root of 5? The square root of 5 is? Well, the square root of 5 is 2 point something, right? Let us suppose that we are doing integer things over here. So we will say that, okay, this is 2 is less than equal to 2.5, right? Less than equal to 2 point something. So we will go inside. Right? We will go inside. We will check. Is n divisible by 2? Is 5 divisible by 2? No, it is not. Right? So we will continue the loop. We will increment I. I will now become 3. Now once again we will check. Is 3 less than equal to square root of n? No, 3 is not less than equal to square root of n, right? 3 is greater than square root of n. So we will exit this loop and we will return true. So we will say that yes, 5 is prime, which is correct. Okay. Okay, so there's another question. Santosh says that, okay, what if 2? What if we check with n equals to 2? Right? What happens when n equals to 2? Won't this program return false? Let us see. Right? So when n equals to 2, we start. Right? We start with I equals to 2. Right? Then we move on to the condition. We check if 2 is less than equal to square root of 2. Is this true? Is 2 less than equal to square root of 2? No, it is not true. Right? This is not true. So it will directly come outside the loop. Okay, it will directly jump outside the loop. It will not go in the loop. And we will return true. So even for true, we will return true. Is that clear, Santosh? Yes. But this program is not 100% correct. This program is not 100% correct. Can you tell me one value for which this program will fail? Exactly. So Ayush has the right idea over here. What if n equals to 1? Or what if n equals to 0? Or what if n equals to minus 100? Right? For all the numbers that are less than 2, we will never go inside this loop. So we will automatically return true. Right? So we need to improve on this program. We need to add a check over here. Right? So let me just insert some space. So we will very quickly, let me just clear up the mess. This was square root of n. So we will add a check over here. We will check if n is less than or equal to 1, then we simply return false. Right? We simply return false. Right? Is this clear? No, this is not a base case. Base case happens when you are in a recursion. Right? Base case, we talk about base cases when we are in a recursion. This is a edge case. This is a boundary condition. Okay? Sujit, it's almost the same, but it is better if we follow the correct nomenclature. Okay? Base case is when we talk about recursion. Currently, we're talking about edge cases or boundary condition. All right. Yes, we can also say that this is less than 2. Right? We can, instead of saying less than equal to 1, we can also say less than 2. That is perfectly fine. All right. Okay. Let us continue. So now we know how to check if a number is prime. Now a very common question comes up. Let me just check how we are doing on time. All right. So a very common question comes up now, which is called if you had to find all the primes till n. Right? So I give you a very, very large number n, let us say 1 million. Right? And I ask you, find out all the primes till 1 million. Right? How will we do that? Is the question clear? We have to find all the primes till 1 million or some number n. So one way of doing that is to very simply go through all the numbers and check if they are prime. Right? So we can simply do for I equals to 1, I less than equal to n, I plus plus, right? and we will say if is prime of I, right? So this is prime is the function that we have coded earlier. If this is prime is the function that we have coded earlier, we will simply print I. Simple enough? Yes. How much time will this algorithm take? How much time will this algorithm take? Well, this is prime function. This takes order of square root of I. Right? This takes order of square root of I. And we are doing this thing n times. Right? We are doing this thing n times. So how much time does it take? It definitely takes, it is bounded by, it is upper bounded by, so the time complexity of this program is upper bounded by order of n times square root of n. Right? N times square root of n. It is a little lesser than that, but as importantly, this is what the type bound is. Okay. Cool. Can we do better? Now the question is, can we do better? This was the simple approach. We had the program, we had this function is prime that we have already coded, right? And we simply say, okay, let us go through all the numbers and let us check them. So this will take this much time. The question is, can we do better? All right. Cool. So the answer to this is yes, right? In general, yes. There is something called sieve algorithms. Sieve algorithms. All right. And there's a lot of different sieve algorithms. So one of the most famous that you will come across is the sieve of Eratosthenes, right? The sieve of Eratosthenes. And this is how you pronounce the name. You say Eratosthenes. Okay? Eratosthenes. So this sieve algorithm can achieve much better time complexity. All right. Now, let us continue this particular thing in tomorrow's class. All right. We are going to keep the today's class simple enough because you will have a lot of practice problems that you can go and try. We will talk about this sieve algorithm tomorrow. And this is a very elegant algorithm. This is a very nice algorithm. It is also very simple to code. Right? So it only has like 5 to 6 lines of code. And that gives you a very powerful algorithm that checks, that finds all the numbers, all the prime numbers up to a given number. All right. Cool. So one thing that Ankush is pointing out over here, or not this, where did that comment go? Interesting. That comment just vanished. Yes. So Ankush is pointing out over here that in this particular program that you wrote, right? In this particular program that you wrote this loop as I equals to 2 all the way till square root of n. We can rewrite this in this manner as well, right? So I'm just pointing it out over here, as Ankush said, that these two loops are equivalent. I equals to 2, I is less than equal to square root of n, right? I plus plus. This loop is the exact same as this loop for I equals to 2. I times I is less than equal to n, I plus plus. Okay, so instead of calculating the square root of n and then comparing it with I, we square I and then we compare it with n. Right? It will work exactly the same. And this is one more way that you can do it. If you were to do it this way, then you will have to pre-calculate the square root of n, right? You will say square root of n equals to, you will use some sort of a math library. You will say math.square root of n and things like that. So if you do not want to do that, you can simply use I into I is less than equal to n. All right? Bridge says, but don't we have to check for overflow? Well, not really, Bridge, because I into I will not overflow, right? If I into I overflows, then n itself should overflow. Does that make sense? We are not really considering the overflow case over here. We're talking about not too big numbers. Okay, we are talking about numbers that will fit in the integers. Now, if n fits in your memory, if n fits in, let's say, a 64-bit integer, then I into I will also fit in 64-bit integer. All right. Srinivas says, sir, how to deal with very, very big numbers? Well, Srinivas, there are a lot of different ways that you can tackle big numbers. One very common approach is to use a big integer library, right? Big integer library, right? But usually this is not a very good approach, right? First of all, the question is, why would you need to deal with big numbers, right? If you are implementing, let us suppose, some sort of an RSA algorithm, and you want to check if a number is prime or not, then you might have other ways of generating large prime numbers. Right? In practice, we don't really have to deal with we don't have to check very large prime numbers with something like a sieve. Right? With something like a sieve, we don't do that. Okay. So let us end the class. Once again, please subscribe to the channel, hit the bell icon so that you can be notified of the videos. And in the next class itself, we will be going over prime numbers once again, and we will be going over a lot of different things. So we have to cover GCD, so greatest common divisor, Euclid's algorithm for that. We have to cover model arithmetic and a lot of different topics. All right. So please make sure that you subscribe to the channel, hit the bell icon, and please go and practice the problems.
Hello everyone. So in the last class, Pragya has taught you about how to check whether a number is prime or not. Okay, so is everyone clear with that? If given a number n, can you all check whether the number is prime or not? Now, once you know that whether a number is prime or not, now let's try to modify the problem a bit. Okay, so instead of getting a direct problem of checking whether a given number is prime or not, let's say that you have to print first n prime numbers. Okay, given a number n, you have to print the first n prime numbers. Or another question could be that you have to print all the prime numbers less than n. Another question would be that you have to print all the prime numbers in the range from L to R. Okay, so these are the three types of questions which we are going to solve optimally in today's class. Okay. Now, if you all remember, if when you have to check whether a given number is prime or not, what is the time complexity of that operation? You are going to run a loop that starts from 2, goes till square root n, right? And with every number in this range, you try to divide n, and you see whether n is divisible by that number or not. If n is divisible by none of the numbers, then you can say that n is prime. So the time complexity of this operation is order square root n, right? Now, if you have to check, if you have to print the first n prime numbers, what will be the time complexity of this approach? If you have to print first n prime numbers, you will be checking for all the possible numbers, right? You will run a loop for all numbers from 1 to n, and then you will run another loop. Maybe you will have to increase the size of the first loop because first n prime numbers might exceed n as well, right? So the time complexity of this is going to be n root n, right? For each and every number, you will be checking, you will be running a square root n check, right? Similarly, if you have to print all the prime numbers which are less than n, again, the same time complexity will be there, n root n. If you have to print all the prime numbers in the range from L to R, then again, size of range multiplied by square root n. So all these types of questions can be solved in this time complexity n into square root n using a very easy check prime algorithm that we have learned in the previous class. Okay, can we do it optimally? Can we do something to make all these problems easy for the computer? Now, there is a very, very well researched algorithm, with very famous algorithm, which many of you are already writing in the comment. It's called the Sieves algorithm, right? So in today's class, we are going to learn about the Sieves algorithm. Okay. Do you guys understand what is a sieve? What is the literal meaning of a sieve? If you just translate sieve in Hindi, what is that? It is nothing but a channi, right? This is chai sante hai ghar pe. So it has a net, very fine net, and a handle. Right? This is a sieve, right? And printing all the prime numbers using a sieve is going to be exactly same as how you filter your tea. Okay, we'll see how. So जब चाय छानते हैं तब क्या होता है? You have a utensil, right? In this utensil you have the cooked chai, right? And then you pour it on the sieves, and after this you have your tea mug, right? So at this point, this complete mixture is called chai, right? At this point, you say that everything which is there in the utensil is my chai. But when it is filtered, then whatever is in your teacup is called chai, right? तो पहले तो जो उसमें था पूरे को हमने बोल दिया कि यार ये चाय है, चाय बन गई है, इसको छान लेते हैं. जब छन के आई तो फिर हमने बोला यार चाय तो ये है, ये जो इसमें रह गया है ये चाय नहीं है, ये चाय पत्ती है, अदरक है, जो भी है, चाय नहीं है, है ना? So sieves is going to function in an exact same way. We have to figure out what are the prime numbers. We'll say that all the numbers are prime. Right, so we'll take all the numbers and we'll say that all of them are prime. Then we will pass them through a sieves. After passing them through the sieves, we will see that only the actual prime numbers are remaining. All the composite numbers will be filtered out by the sieves. Okay, let us see how it is going to work. So first of all, let us write down all the numbers on which we'll be running the sieves. Okay, so we have all these numbers. Initially, just like the T, I'm saying that all of them are prime. Okay, all the numbers are prime. Now for 1, we are very sure that 1 is not a prime, right? Is everyone clear with this thing that 1 is not a prime, right? Why is 1 not a prime? Because a prime number has to have exactly 2 divisors. 1 has got only and exactly 1 divisor. So 1 is not a prime, so we can directly remove 1. Okay. Now, whatever is the first number which is present in this in the list of all these numbers, which is available in the list, we'll say that this number is a prime number. Okay. So what is the first available number here? The first available number is 2. So I'm saying that 2 is a prime number. So we'll filter out 2. 2 comes out of the seeds. Okay. So we have poured all the numbers here till 40, and now 2 has fallen. 2 has been successfully, he has crossed the seeds. Okay. 1 has stuck here. Now, if 2 is a prime number, can I say that all the multiples of 2 will never be a prime number? Right? Because all the multiples of 2 will definitely have 1 as a divisor, themselves as the divisor, and also 2 as a divisor. So they are not satisfying the criteria of being a prime number. Does this thing make sense to everyone? Does this thing sounds obvious to everyone? That any multiple of 2 can never be a prime number. Right? So if any multiple of 2 can never be a prime number, so what can we do? Filter them out, cut them. So I will just cut all the multiples of 2 which are present in this list. So 4 is gone, 6 is gone, 8 is gone, 10 is gone, right? So all these multiples are removed from this list. These all have been filtered out and thrown away. What is the next available number which is there in the seeds? What is the next number that I can see? The next number is 3. So I can say that, okay, 3 is also a prime number. Let's add 3 as well. Okay. Once I am declaring that 3 is a prime number, can I say that any multiple of 3 does not stand a chance for being a prime number? Any multiple of 3 is always and always going to be a composite number, right? So let us filter them out. Let us remove them from the list. So let us remove all the multiples of 3. 6 has already been removed. Then we remove 9. 12 has already been removed. We remove 15. 18 is already gone, right? And then 21. 24 is gone. 27. And then 33. 36 is already gone. Then 39. Okay. Now, which number is the next available number in this list? The next available number is 5, right? So I can say that 5 is also a prime number. Okay. So out of all these numbers, we have till now filtered out 3 numbers which are prime numbers, right? So now 5 has come. So any multiple of 5 will never be a prime number. So all the multiples of 5 will also be removed. So currently I can see that all the multiples of 5 have already been removed. 10 is gone, 15 is gone, 20 is already gone, 25 is remaining. So we'll remove 25 as well, and then 35. Okay. Then what is the next available number in this list? The next available number here is 7. So 7 becomes the next prime number. Okay. And all the multiples of 7 will also be removed. So now 14 is gone, 21 is gone, 28 is gone. All the multiples of 7 have already been removed. Okay. What is the next available number that we have? Now we have 11. So 11 becomes the next prime number. And all the multiples of 11 again have already been removed. Then we have 13. Then we have 17. Then we have 19. Then we have 23. Then we have 29. Then we have 31, 37. And that's it. So now you can see that we have got all the prime numbers in the range from 1 to 40. These are all the prime numbers in the range. All the prime numbers which are less than 40 are now with us. Is the idea of the algorithm make sense to everyone? Is the idea clear? How the algo is going to work? Initially, we said that all the numbers are prime numbers. Assume that all of them are prime numbers. Pass them through the sieve. What does the sieve do for us? The sieve's algorithm takes the first available number and declares it a prime number. So we declared that 2 is a prime number. Since 2 is prime number, none of its multiple can be a prime number. Cut them out, remove them. Then take whichever is the next available number, call it a prime number, remove all the multiples of this number as well. Okay. Now let's try to see how can we write the code for this. Okay, the code is going to be very, very small, very, very easy. Right. So what we are doing here is initially what we are doing is we said that let us first take all the numbers. So if let's say we have to print all the prime numbers in the range n, so then we take an array prime of size n plus 1, because if n is 40, array indices are going to start from 0. So I also need 40 as an index. So I will take the size as n plus 1. Okay. And I will say that all of them are prime. Okay. So this primary, what does it hold? This primary, for every index, it holds true or false based on whether the number is prime or not, right? So currently I'm saying that if this is my array, okay, currently I'm saying that all of them are prime, so have true for each and every index, okay. Then what we will do is we'll first declare some of the already known values, right? So we know that 0 is not a prime, so we can say that prime of 0 is false. So this will be turned false. And we also know that prime of 1 is also not a prime, right? So 1 will also be converted to false. Now starting from 2 to n, we have to check each and every number whether they are prime or not. So how did we do this in this algorithm? We selected whichever is the first true value. Basically, the first available means the first true value, which is currently declared as a prime number, right? So we'll run a loop which will start from 2, and this loop will go till till n, and we'll be incrementing the value of I one by one. And then we have to check whether this value has been removed or not. So if it has not been removed, then we will always be having a true value, okay? So we'll just check if this number at index I, if it is true, if this number is currently a prime or not. What is the first available prime number that we have here, right? If it is a prime number, this means that none of its multiple can be a prime number. So for all its multiple, make them false. So if 2 is true, 4, 6, 8, 10, all these numbers should be turned to false. So I will just run a loop. Let's take a different variable. So now what we have to do for I, we have to make 2i, 3i, 4i, all these numbers as false, right? So we'll quickly run a loop starting from 2, and we'll see till where we have to run this loop, and then do this. We'll say prime of I into j, right? So I is already there. This is our j, right? This has to be false. So we till what value we have to increase j? We don't know, right? We don't know that. So we actually don't know till when we should be incrementing j. But what we know is that this product, this 3i, 4i or ji, this can never be greater than the maximum value that we have. So this product can never be greater than n. This always has to be less than or equal to n, right? So here what we'll have is j into I is less than or equal to n, okay? Because if you see in this list, when you select I is equal to 2, then from where to where your j ranges, j starts from 2. So if j is equal to 2, you cut 4, then j becomes 3, you cut 6, j becomes 4, you cut 8, and you will go till 40, right? So j becomes 20. You don't want to increase j such that you are trying to cut a number which is greater than 40. So always we are keeping I into j less than or equal to n, okay? Cool. Now let us see. Let us try to quickly see what happens when we are actually cutting the numbers, right? So when my I takes a value 11, okay, when I'm taking a value 11, in this case, when we selected 11, what was the first number that we tried to cut? The first number that we tried to cut was 11 into 2, which is 22, right? So if I is 11, we are going to check it for value of j is equal to 2, right? Which will give us 22. Then we will try to cut 33. Then we will try to cut 44. Then we will try to cut 55, and so on. Then j will become 11, and we'll cut 121, and so on, right? Now I have a question. When I'm trying to cut all these numbers for the value of I equals to 11, can I say that 22, 33, 44, 55, all these numbers would have already been cut? Because before I takes the value 11, I will also take the value 2. When I takes the value 2, 22 would have been cut by that, right? So you must have observed in this case also that when we reach to 11, all the multiples of 11 were already cut, right? When we reached to 5, what was the first number that we cut? 10 was already gone using 2. 15 was already gone using 3. 20 was already gone using 2. What was the first number that we cut using 5? It was 25. If I start from 11, then we can see that none of the multiple of 11 is available here, which has not been cut. All the numbers have been already cut, right? Why that happened? Because before taking a value 11, I must have taken all the values which are less than 11. So all those values have already been cut. So 22 has been cut by 2, 33 has been cut by 3, 44 has already been cut by 2, 55 has been cut by 5, and so on, right? So what should be the first value from where we should be starting the second loop? From where we should start the second loop? This has to start from j is equal to I, right? Because when we were trying to cut the numbers from 5, we saw that the first number that we are cutting is 25. Similarly, for 11, the first number which will be available there is going to be 121. All the other numbers must have been cut by the smaller values of I. So we don't need to start from 2, we can start j from I, okay? Now, if we are starting j from I, what is the maximum value that I can take? Do we need to run the first loop till n? Okay, let us try to analyze the second loop, and that will give you the answer whether we should be running the first loop till n or not. Should it go till n by 2? So what is the maximum value that we have to cut? The maximum value that we have to cut is here 40, right? Okay, and whenever you are starting to cut, you are always starting from the I value, which means that the first value that you are cutting is I square, right? For 2, you are cutting, the first value that is being cut is 4, right? For 3, the first value that you are cutting is 9. For 5, the first value that you are cutting is 25. For 6, the first value that you will be cutting is, for 6, you will anyhow won't cut any value. For 7, what will be the first value that you will be cutting? For 7, the first value should be 49. 7 into 7 is 49. Is 49 in this range? No, 49 is out of this range. So what should be the maximum value? The maximum value till which we can go is I square. So I can never go beyond square root n, right? Because the first number that you are cutting here, like this number, which is the last number, would have been cut when I becomes square root n, right? So this n can be turned to square root n. Right, so either you can say I is less than equal to square root n, but if you are using this function square root n, this is an expensive operation of finding a square root of a number is actually an expensive operation. It will take at least log n time. So what you can do is you can replace this by I into I less than equal to n. So now you are doing the checking order 1 operation. This is going to take log n time, at least if you are printing the integer part, right, using binary search. Okay, so now let us come to the time complexity. Okay, this loop, the first loop is running from 2 to square root of n. Let us actually remove all the optimizations that we have done. We'll try to calculate a very relaxed upper bound. Okay, so tell me one thing: when the value of I is equal to 2, how many times does the inner loop run? If let us say that this starts from 2, if we are considering the previous loop, the totally unoptimized loop, which was starting from 2 and going till n, and this loop is also going till n, we are considering the most unoptimized version. Now tell me, if value of I is equal to 2, how many times are we going to run this loop? This loop will start from 2, go till n by 2, right? We'll be cutting exactly n by 2 numbers. For I is equal to 3, how many times is the inner loop going to run? The inner loop is going to run for n by 3 times. For I equals to 4, how many times is the inner loop going to run? For I equals to 4, is it going to run for n by 4 times? For I equals to 4. So see, what happens is when I takes a value 2, we cut 4. We say that now 4 is not a prime because 4 is a multiple of 2. And before running this loop, we are always checking whether I is prime or not. Is 4 a prime? No, 4 is not a prime. So this loop, the inner loop, is going to run how many times? Exactly 0 times. This if case is going to fail for 4, right? For 5, it is going to run for n by 5 times. For 6, this is going to run for, again, 0 times. 6 is not a prime. For 7, this is going to run for n by 7 times, right? So can you see a pattern here? If we have to add all these time complexities, what will we get? We'll be getting n by 2 plus n by 3 plus n by 5 plus n by 7 and so on. What are these? If you take n common from here, you get 1 by 2 plus 1 by 3 plus 1 by 5 plus 1 by 7 plus 1 by 11 plus 1 by 13 and so on. What are all these? These are nothing but sum of reciprocals of prime numbers, right? First n prime numbers basically, correct? So I can say this is equal to I equals to 1 to n 1 by p. All the prime numbers, the first n prime numbers, or maybe all the prime numbers which are less than n, right? All the prime numbers which are less than n. This is the time complexity. Now, if you are really good at mathematics, you will be able to you will be knowing that this whole sum can be approximated to log of n. Okay, so this is the overall time complexity of Siev's algorithm. Okay, so if you are really good, or if you are interested in mathematics, you can read about the Merton's theorem, which proves this thing. Okay, that sum of reciprocal of first n prime numbers is same as log of n. So the overall time complexity can be approximated as order of n into log of n. Okay. Okay, I will quickly brief over the time complexity part once again. Okay, so if we are just checking for every value of I, how many times is the inner loop going to run? Okay, so I said that if I is equal to 2, how many times is the inner loop going to run? Inner loop is going to start from 2. We are assuming the most unoptimized version. We are removing all the optimizations that we had done. So inner loop will start from 2 and it will run for n by 2 times, right? If you are starting from 2 and you have to go till 40, you will be running 20 times, right? You will cut 20 numbers in this loop. Similarly, for I equals to 3, you will be running the inner loop for n by 3 times. For I equals to 4, now this is a very important thing, that before running the inner loop, you always check whether this number is prime or not. 4 is not a prime. So for 4, the inner loop will never run. For I equals to 5, the loop runs for n by 2, n by 5. Then for 6, again, since 6 is composite, loop does not run. Then for I equals to 7, loop runs for n by 7, and so on. So if you add all of them, right, because when you have to calculate the time complexity, you will be adding how many times the inner loop is running in total, right? And that will be the overall time complexity. So if you add all of them, you get this series. Here, if you take n common, then you get something which is nothing but the sum of reciprocal of all the prime numbers. And if you apply Merton's theorem, if you are aware about the Merton's theorem, you will be knowing that sum of reciprocal of all the prime numbers can be approximated as log of n. So that is why the time complexity of Siev's algorithm is order of n log of n. Okay. Now this is the most relaxed time complexity that we have achieved, because we removed all the optimizations, right? The optimization that says that the first loop should run only till square root of time. This loop should start from I. We have removed all of them, and then we have calculated. So whatever, if you do any optimization here, your algo is definitely going to be better than this time complexity. Okay. The question is, will this work for a range whose first element is not a prime number? This is only going to work if you are starting it from 2. If you are starting from any random number, this algorithm is never going to work, right? Because you have to make sure that all the composite numbers are cut. So if, let's say, if you are trying to find the numbers in the range from 40 to 100, right? So you have these numbers, and now if you start cutting the numbers from 40, you're trying to cut the multiples of 40. This is not what Siev's is suggesting. Siev's is saying, give me the first prime number. What is the first prime number? First prime number is 2. Cut all the multiples of the first prime number, not the first prime number in this range, the first prime number overall, right? So you will always be starting, or this algorithm will only work if you are starting cutting the numbers from 2. However, if you have to find the numbers in a range, what you can do is you can pre-compute all the prime numbers. So what you can do is, if you have what would be the maximum value of range, then starting from 2 to that range, you can pre-compute all the prime numbers. Okay. Once you have all the prime numbers in this range, now what you can do is, you can this array is going to be a sorted array, so you can apply binary search and you can find all the positions of the lth prime number and rth prime number and print all the values. Okay. Cool. Is the Siev's algorithm clear to everyone, including the idea, the intuition, and the code? Is everything clear to everyone? Great. Now what we'll do is we'll try to see a problem. Okay. So we still have 30 minutes. So we'll try to solve a very, very good problem, which is a very commonly asked problem and a very generic problem. Okay. The problem says that given a number, return the prime factorization of this number. What is prime factorization? So is everyone here clear with the thing that any composite number can be written as the multiple of all prime numbers? Not all prime numbers, but multiple of prime numbers. Is everyone clear with this thing? So if I give you n is equal to 24, what would be the prime factorization of 24? 24 can be written as 2 into 2 into 2 into 3. Basically 8 3s are 24, right? So 8 is nothing but 2 raised to power 3. So 24 can be written as this. So the prime factorization of 24 would be 2, 2, 2, and 3. This is what you have to return. Okay, is the problem clear to everyone? If the value of n, let's say, is 10, you will be returning 2 into 5. Okay. If the value of n, let's say, is 42, then we have 2, 3, and 7. Okay. Is the problem clear to everyone? Given a number n, you have to return the prime factorization of n. Prime factorization means you have to represent that number in terms of only prime numbers, and that is possible for each and every number, right? Because any number either will be a prime number or a composite number. If it is a composite number, you can further divide it into prime numbers, right? For example, if n is 24, you can write it as 2 to 2 into 3. There can be many ways. Can there be many ways? Varun, just try to think and figure out. Can there be many ways? If you are breaking down the number into prime numbers, not composite number, none of the numbers in the returned array should be a composite number. Okay, what can be? What is the first thing that comes to the mind? So if, let's say, I'm given 24 and I have to, so we must have done this in schools, right? We all have done the prime factorization of the number in school in the elementary mathematics, right? This was, I think, in 6th class maybe or 5th class when we learned about the prime numbers, right? So how did we used to do it at that time? So if I'm given 24, what will I try to do? I will pick what is the smallest number with which I can divide it, right? So the smallest number that I can figure out is 2. So I will try to divide 24 with 2. I get 12, okay? And this 2 gets added to my answer. Now I have got 12, and I know that again I have to do the exact same thing. Find the smallest number with which I can divide this, and that number obviously should be greater than 1, right? So again, here also the smallest number that I can think of is 2. So I divide it with 2, I get 6. Again, I can divide it with 2, so I get 3. Now 3, the smallest number that can divide 3, bigger than 1 is 3, so I get finally 1. All these numbers are definitely going to be a prime number because we are always selecting the smallest number, right? If that smallest number is not a prime number, then there must be a number which is smaller than this that can divide this number. Does this make sense to everyone? What I'm trying to say is, if there is a number x, which is the smallest number, which is dividing 24, and x is not a prime number. If it is not a prime number, then it must be a composite number, and then it can be broken down into 2 prime numbers, at least, right? So 24 will also be divisible by these 2. So that means x was not the smallest number that can divide it. There are smaller number than x which can divide 24. So using this proof by contradiction, I can always say that the smallest number which is able to divide any number is going to be a prime number. Okay. Now, how to code this thing? I'm just going to code the same approach that we used in our 5th, 6th class mathematics, right? So to do this, first we can initialize an answer array or maybe a prime factor array. And what we are going to do is, so here in this case, I just used my mind and saw that this is divisible by 2. But for computer, we'll have to check with every number starting from 2, right? What is the first number that divides 24? And then keep dividing it by that number till it is divisible, right? So I will start from 2 and I will say that this has to go till somewhere and then I plus plus, and then I will say while this is divisible, if it is not divisible, then it will not go inside the loop. But if it is divisible, first of all, add this I to the answer. So we'll do prime fact dot add I. Okay, add this to the answer and then divide n. So n will become n by I. Okay, so what we are doing in this case is n is initially 24, right? We are starting from I, and we are and the first value of I is 2. So we are checking if it is divisible. If it is divisible, then keep dividing it till it is divisible. So we divide it, make it 12, n becomes 12. Then the loop still checks that this is still divisible by 2. So keep dividing it, and also keep adding it to the answer. So the answer will have 2, then in the next step again 2, and then again 2. Then you have 3. So this will break out because now n mod 3 is not divisible. Sorry, n mod 2 is not divisible. N has now become 3, right? 3 mod 2 is not equal to 0. So we'll increment the value of I. So I now becomes 3. So then we'll check n mod 3 is now divisible. So we'll add 3 to this and we'll divide n further. So now n becomes 1. Okay. So the question is, till when this loop should run? What should be the breaking condition here? What can be the maximum number that I can take? The maximum number that I can take is, we may use set instead of array. No, you cannot take set, because set will guarantee that the occurrence of every number will be limited to exactly once, whereas we need 3 twos. If you are taking a set, you will have exactly 1 2, right? So set is not useful in this case. You'll have to take a list, array list, or array which supports multiple occurrences of same character, right? Okay, so what should be the maximum value that I can take? The maximum value that I can take obviously is going to be square root of n, right? So the I that we are going to increment is going to be till square root of n. Okay. Now this code is going to print all the prime factors for us. I can see that there are 2 mistakes in this code, 2 very big mistakes. Can you guys quickly figure out them? This code has 2 blunders, and one of them is the most commonly done mistake while writing a code. Even when people write the most simplest of the codes, they make this type of mistakes. Can you quickly figure that out? It doesn't work for 0 and 1. Yes, so this is guaranteed in the input that n will always be greater than 1, because even the question who is the person who is asking the question knows that 0 and 1 will not be are not eligible for this question. Okay, right. So I can see that one of the mistake has been pointed out. The other mistake no one is able to guess. Let us see what we are doing. Let us quickly reiterate over the code. We are saying that I is starting from 2. I should go. What is the maximum limit that I is taking? It is taking square root of n. So here, instead of this, I would be writing what? Actually square root of n, or maybe to keep it optimized, let us have I into I less than equal to n, right? This is the more optimized version of the same thing. Okay. So what we are doing here is we are initializing I. We are checking that I should not go more than square root of n. And inside this loop, what we are doing is we are changing the value of n, correct? N is changed inside this loop. N is also there in the breaking condition. So initially we started this loop with an assumption that n is going to be 24. So the maximum value that I can take is going to be root 24. In the next iteration, you changed n to 12. So this loop here, now this condition is not going to hold true because n has been changed. This is the most common mistake that I have seen students doing while writing most easiest of the codes. If you are changing a value inside the loop, you should never be taking it in the breaking condition. So always do one thing, assign some variable this value and then use it here. Okay. Otherwise, you will see your code behaving in very unexpected way and you will not be able to realize what is going wrong there. Okay. So assign the value and then keep it inside the loop. This is one mistake. What is the other mistake? The other mistake most of you have already pointed out, which is if the number is already prime, right? If the number is already prime, or maybe number is having a prime factor which is greater than square root of n, right? If a number is having a prime factor which is greater than square root of n, for example, let us talk about 404. Okay, so for 404, how will this loop run? We'll start from 2. We check that 404 is divisible by 2. We divide it. Okay. Then we again check that this is again divisible by 2. We divide it. Now this is not. So we have added 2 and 2 in the array. Now this is not divisible by 2. then this is not divisible by 3. And what would be the maximum value of that I will be taking in case of 404? The maximum value that I can take is going to be 20, right? Because the square of 21 is going to be greater than 404, right? So the maximum value of I is going to be 20, but we can see that for all these values of I, the prime factorization of 404 is not complete, right? So what we can say in this case, right? Because this is not complete. 101 would also have been there, correct? So this is another mistake in this code. How to fix that mistake? Can I say that even after removing all the possible prime factors from that number, if I have got a number which is greater than 1, that number must be a prime number? Can I say this? So to actually fix this code, can I just add another if condition? It says that if this number is still not reduced to 1, that means that this number has to be a prime number. So directly add this remaining number as well. Okay, so what we'll do here is, if n greater than 1, then prime factor dot add n. We'll add this line here itself after the for loop completes. So if this number has not been reduced to 1, we will add 101 as well, and we will get the correct answer. Does this make sense to everyone? So this is about prime factorization. What is going to be the time complexity here? What is the time complexity of this code? So calculating the time complexity is pretty easy here, right? The first loop runs for how many times? The first loop runs for root n time. Okay. Then the second loop is going to run for how many times? We are dividing the number n by I every time in every iteration. So how many times the second loop is going to run? The second loop is going to run for log n time. So what should be the time complexity? Is it going to be root n into log n? Is the time complexity going to be root n into log n? No, right? This is wrong. This is not going to be root n multiplied by log n. Okay, why? We can quickly see that this loop runs for root n times, and here we are dividing the number by I every time. In the worst case, the value of I is going to be 2. So in the worst case, if you are dividing n by I, how many times can you divide it? If given a number, how many times can you divide that by 2? This is given by log, right? This is given by log of 16. Log, whatever is the value of log of 16, you can divide 16 that many times by 2, right? But this is incorrect. Why? So let us try to analyze what is going on here. So if we have a value, let's take 16 itself. Okay, so in the first iteration, when the value of I is equal to 2, we check that this is divisible and we divide it. So we get 8. Then again we divide it by 2, we get 4. Again we divide it by 2, we get 2. Again we divide it by 2, we get 1. Okay. Now after we have divided completely with 2, for the next value of I, which is equal to 3, how many times is the inner loop going to run? For 3, how many times is the inner loop going to run? 0 times, right? Inner loop is not going to run because this has already been reduced to 1. Okay. If this has already been reduced to 1, now this inner loop will never run again. If this inner loop is not going to run again, for 3, number of iterations are going to be 0. For 4, the number of iterations are going to be 0, right? So what is the total number of times, including all i's, the inner loop is running? For all the i's, the inner loop is going to run for log n time. This is not for each and every I. This is for all the i's combined. For 2, it runs for log base 2n. Then for 3, it runs for log base 3n if n is there, right? So if let us talk about any other number. So if I talk about 24, 2 can reduce it to 12, then 2 can reduce it to 6, then 2 can reduce it to 3. Now 3 is not going to have log base 3 24 these many steps, because 3 is going to reduce this number which has already been reduced by 2, right? So the total number of steps, including all the i's combined, is going to be log of n. So this is going to be log of n plus square root of n, which is nothing but square root of n. So the time complexity of this algorithm is going to be exactly square root of n, not root n log n. Okay. Guys, in mathematics, there are multiple topics which are very, very important for programming point of view, or both the interview point of view as well, right? So there is modular arithmetic that you must learn, and you must solve multiple problems on this. Okay, then there is GCD, the LCM and HCF problems. Okay, GCD is also very, very important concept. Okay, then of course you definitely have the prime numbers. And in the prime numbers, you can also optimize this approach that we have discussed, right? You can optimize this approach using a concept called the smallest prime factor of a number, which is called the SPF, which we haven't discussed in the class, but this is also a very important concept. Okay, so after the class, please go through this. What is SPF and how you can actually optimize this algorithm using the smallest prime factor. Okay, and then in the modular arithmetics, there is also Fermat theorem, which is very important. So just Google all these concepts and go through all of them. Try to solve problem based on all of them. Okay, they all are very, very important. They will help you in problem solving as well as in interviews. Okay, cool. So this is it for today's class. If you liked the video, if you understood everything, please like, please share it with your friends. Please tell us in comment which all topics you would want us to discuss next. Okay. Tomorrow's class is going to be on bit manipulation. So if possible, before joining the class, if you can go through how numbers are represented or what are the basic bit operations, then the class will go very smoothly, right? So next class is going to be on bit manipulation. So just read about some bitwise operators like OR, AND, XOR, left shift, right shift, etc. Just read about them. And if you found this video useful, you can just like it and share it with your friends. Okay.
Why do we use arrays so extensively everywhere? The reason for that is because arrays provides us random access in order 1 time complexity, right? And this is the biggest advantage of array. In most of our use cases, we want to access random index in the most optimal way. That is why we use arrays. But this random access of any index, this also comes with a cost, right? Do you guys know how an array is able to provide order 1 random access? So array is able to provide order 1 random access because all the elements of an array are stored in contiguous memory location, which means that, let us say, if I have an array of size 4 and first element of the array is, let's say, stored somewhere here, that means that the next element will be stored next to it, the third element here, and the fourth element next to it. So all the 4 elements are going to be stored next to each other in the correct sequence as well. And we are only going to have the address of the first element of the array. And using that, since you know the size of the data set, using that you can find the address of any index in order 1 time, and then you can access that value. This is how array provides us order 1 random access. But for this to happen, it also needs to know what is the size of the array beforehand. Before you create the array, you need to know what is going to be the size, because only then these many slots will be allotted, these many slots will be reserved for this array, and then you can use them to insert or access the values in the array, right? So you need to call out the size before you are creating the array. And that is the reason why whenever you create an array, you have to declare the size. You cannot create an array without telling the size of the array. Now, how is it a disadvantage? So the disadvantage which lies here is that whenever you are creating an array, you need to have a very good idea about how many elements are going to be there in the array. Because if the size that you have given here, if that size is very large than your actual data set, which means that you have created an array of a larger size, but you have very few elements to fill in there, then that means you are going to waste memory, right? Because if you have, let's say, created an array of these many slots, but you have only filled, let's say, 2 elements inside the array. Since all these slots have been reserved for this array, they cannot be used by any other thing, right? So if you are not filling them, that means that this memory is wasted. On the other hand, if the number of slots that you have created, if the size of the array that you have, if it is smaller than the size of your data set, then you can definitely not insert all the data that you have. For example, in this array of size 4, if you want to insert, so let's say we have this array of size 4 here, and you have filled this complete array, all these slots are occupied. Now, if I want to insert a 5th element inside this array, is that possible? Can we extend the size of the array? No, right? That is absolutely not possible, because these slots which are next to the 0th or the last slot, they might already have been taken. They might not be free. And this is not how you can simply extend the array, right? Maybe we cannot do this in a normal array, but we can do this in a vector or in an array list, right? Even if an array list is filled, even if a vector is filled, you can still insert values inside it. Internally, vector or an array list is also having an array, a normal array only. And when that array gets filled, the best that we can do is declare a new array. Discard this array, declare a new array of a larger size, right? So if you declare a new array of larger size, which means that another set of contiguous memory locations will be allotted to that array, and then you can copy all these values from your original array to this array. All these values are now in this new array, and then in the subsequent slots you can insert the new values, right? So if you had this array of size 4, if it gets filled in a vector or in an array list, a new array will be created of larger size. These values will be copied, and then the new values that you need to insert, they will be inserted in the subsequent slots, and then this array will be discarded. And once this new array gets filled, the same thing will repeat again. Another new array of larger size will be created, all these values will be copied, and then the new values will be added in the empty slots. So whether you are using a normal array or a vector or an array list, it totally does not matter, because both of them are working in the exact same way, using contiguous slots in the memory. And whenever you try to book contiguous slots, whenever you are trying to reserve these contiguous slots, there are a lot of chances of wasting the memory. Arrays definitely are the best suited data structure if we require fast random access. But if we do not require fast random access, in that case, we can optimize for the memory. We can save some space, and we can save ourselves from wasting extra space by using a data structure which is one of the most important data structure with respect to the interviews, especially if you want to prepare for companies like Amazon, Microsoft, or Adobe. And this data structure is known as the linked list. So we are going to study linked list in today's class. We are going to see linked list from scratch, how it is stored, how it functions, and we are also going to solve a lot of interesting problems on linked list. Okay, so now let's see how using a linked list can actually save space for us, right? And always remember that whenever we are using linked list, we do not aim for having a fast random access, right? That thing is totally lost. But we are going to save some space, right? And let us see how we are going to save space for us. So in an array, the space was being lost because we were trying to reserve a chunk of memory location next to each other for the array. And if that is not being used, then all that memory is wasted, right? But in a linked list, what we are going to do is, first of all, we do not reserve these spaces in chunks, right? We are going to reserve one slot at a time for one data, right? So for example, if you want to insert 4 in your linked list, then when you want to insert 4, when you actually create a node in your linked list, only then are you going to reserve this slot or insert 4 in this slot, right? And let's say that we want to insert 5, then only when you want to insert this number, only then you are going to do this. And these slots do not need to be next to each other. They do not need to be in contiguous slots. They can be anywhere, right? For example, if you want to insert 7, this 7 can be somewhere here as well. And these slots also need not be in the same sequence. The sequence can also be completely out of order. For example, if now you want to insert 3, this 3 can also be somewhere here. Okay. So all these slots are arranged randomly. Wherever you find a slot in the memory, you can insert these numbers. But now the question is that if they're stored in any slot in any random location, then how do we preserve the order in which we have inserted the elements? How do we iterate over these elements in the exact same order? To preserve the order, we need to have something known as the links. Every element should also have the information about what is going to be the next element. So element definitely cannot have the information, but every node should have the information. And that is the reason why the list node class that you are going to have is going to not only have this data, but also a link to the next pointer. Okay, so the node class that we are going to have, it's going to have some data. And this data can be anything. This can be integer, float, double, string, character, array, hash map, anything. But for simplicity, we are taking integer right now, right? So it's going to have a data, which are these values in our case, and it should also have a reference to the next node. Okay, so this reference we are generally going to represent with the name next. Okay. So this means that all these nodes which we have stored in the memory, they are not only going to have this data, but along with this data, they also have the reference, which means this stores the next pointer. 5 stores the next pointer to 7, and 7 stores the next pointer to 3. So whenever you need to iterate over this list, you should have the address of the first element. And if you have the address of the first element, you know what is the next, you know what is the next of that, you know what is the next of that, and so on. This is the reason why you if you might have seen, like I'm sure all of you must have seen a representation of a linked list, right? And it is represented something like this. So all these squares which are created in a linked list, these are nothing but they all represent the node, and inside these you just insert the value which is there in the nodes. These arrow pointers represent the next pointer, which means that after 4 you are going to get 5, after 5 you are going to get 7, and so on. For 1, since this is the last node of this linked list, there is nothing after this, right? Which means that the next pointer of 1, next pointer of this node is going to point to nothing. It's going to point to null, right? And we are going to represent null like the earth symbol. One very important thing to keep in mind, guys, which will also be used in a lot of problems that we'll be solving, that in a linked list, you can only iterate from left to right direction, right? Because every node is holding the information about what is next to it. In a normal linked list, you don't have information about what is previous to it. You only have the information about which node is next to it, which means that you can only iterate a linked list from left to right, correct? So if that is the case, that you can only iterate the linked list from left to right, and if you want to iterate over the complete linked list, what is the minimum information that we need to have for that? The minimum information that you need to have if you want to iterate over the complete linked list is the reference or the address of the first node. Okay, so having the first node is essential, because if you do not have the information about the first node, let's say you only have this node, then you cannot go back and visit these nodes, right? So it's like these nodes do not exist for you. You can only move from here to the right side. Okay, and this is the reason in all the questions that you will be solving, whenever you are given that you are given a linked list, that means that you will always be given the reference or the address to the first block of the linked list, and this first block is generally known as the head. This is known as the head of the linked list. Cool. So if that is clear, let's maybe quickly solve a problem. So the problem says that you are given a linked list, and whenever we say that given a linked list, you will only be given the head pointer, right? And because all the complete linked list is linked from that head pointer, so that is why you will always only be given the head pointer. Okay, so you are given a linked list. You need to find out what is the length of the linked list. Okay, is the problem clear, guys? The values inside the linked list can repeat. Also, the linked list is not in sorted order. Okay, you need to find what is the length of this linked list. So length of this linked list is going to be 5. We'll quickly see how to find the length of the linked list, because there are a few important points that we need to notice here. First of all, we are given the head of the linked list, right? We are given the reference to this node. And we also know that there is exactly one node in this complete linked list whose next is equal to null, right? There is exactly one node whose next is null. And this node is definitely going to be the last node of the linked list. So what we have to do here is we just need to iterate, we just need to go next and next, starting from the head pointer till we reach a node whose next is equal to null, right? So till our node becomes null, we can keep counting all the nodes. So let's say that the length is initialized with 0, and then we can say while your head not equals to null, till it is not equals to null, we can keep incrementing the length, and we can keep going to next. Is this code clear to everyone? Simple. But there is something wrong in this code, guys. So what we are doing here is, let's say that this is the linked list which is given to us, right? And the initial head was pointing here. What we did was we started with L equals to 0, head is currently pointing here, and then we say if head is not equals to null, increment L, length keeps increasing, and with that, our head pointer is also moving. And this is going to stop when our head pointer reaches null. So when you are done with this whole thing, when you are done with this function, the position of your head pointer is this null node. Now, since you have changed the position of the head pointer, can you again iterate over the list? If it is required that you need to iterate over the list again, is that possible now? No, right? We have lost the list. right? We have effectively lost our linked list. That is why you have to make sure that whenever you have to iterate over the linked list, you do not change the head pointer. You will have to fix your head pointer here. Then you can take some temporary variable with a meaningful name, and you can iterate that temporary variable instead of your head pointer. Okay, your head will remain steady. Does that make sense to everyone? Okay, so now before we start solving the problems, let us first see some of the basic operations like insert or delete in a linked list, right? Okay, guys, actually the time complexity of insertion in a linked list is going to depend on where you want to insert the values, right? So we are going to consider three cases here. First is going to be insert or delete from the top or from the first position or from the front, and then from the back and at any kth position. So when you're inserting anything and you want to insert at the front, so for example, you are given this linked list, okay, and when we say given the linked list, that means that you are already given the head of the linked list, right? So when you want to insert an element in this linked list at the front, which means that you're going to update the head, right? Inserting at front means your linked list is going to have a new head after the insertion, right? So for example, if you want to insert 2, how are we going to do that? First of all, we need to create a node with this value. Once you call this constructor, once you create this node, we are going to have a node with value 2 and next pointing to null. Okay, so we have this node after this line, and then what we need to do is we need to connect this pointer, the next of 2 to 1, for which we can say new node dot next is equals to the current head. Once this is done, this pointer is removed from here and 2 is now pointing to 1. And now to make sure that 2 is a part of the linked list and 2 is also like it is possible to traverse 2 in this linked list, we need to update the head, right? So what we are going to do is we will say that now the new head should point to the new node that we have created, and that is it, which means that now this head will move from 1 and now it's going to start pointing to. So we have created a node we have inserted a node in the front of the linked list. What is going to be the time complexity here, guys? Time complexity of this operation is order 1 because we haven't done any traversal. We have just created a node and just changed the pointer and inserted it in the front. Similarly, when you have to insert in the back, what do you guys think should be the time complexity in that case? If you want to insert in the back, right? So in a normal linked list, you are only given the head pointer of the linked list, which means that if you have to insert anything at the back, you need to traverse till you find the null node and then you insert your new node there. Or what you can do is you can maintain a tail pointer, very similar to how we have a head pointer. We can also maintain a tail pointer, right? With every insertion, we can keep updating the value of the tail pointer, and this tail pointer should always point to the last valid node in the linked list. If we have such a pointer inside our linked list, then what is going to be the time complexity of inserting at back? Because now if you have such a pointer, then again you only need to create a new node first of all, right? So if again you want to insert 2, you will first be creating a new node 2 with its next equals to null using the exact same line here. And then what you need to do is you can simply say that tails next should now point to the new node. So this 5 is now going to point to 2 and 2 is already pointing to null. So that is it. And now we just need to update the tail. So we will say that the tail should now be equal to new node. So the tail will be updated and will be moved from this node to the new node that we have created. What is the time complexity of this operation? Correct. Again, it's order 1. Okay. Now, if you have to insert element at any random kth position, in that case, what is going to be the time complexity? Is going to be order n, right? Because in the worst case, you might need to traverse the complete list till the last but one node. In that case, the time complexity becomes order n, right? Now, one thing to notice here is that if you have to insert element at any kth position, right? For example, if this is 0, 1, 2, 3, if these are the positions, and if you have to insert an element in the third position, which means between 3 and 4 here, in that case, you need the pointer of this node, right? You need the reference of this node because only then you will be insert anything after this. So whenever you need to insert an element in the kth position, you need the reference to the k minus 1 in node, right? The node which is present just after the required node. So in this case, what we are going to do is we again create, let us say we want to insert 12 in this case. So we create a node 12 and then we say, so we should be having if we want to insert it at the kth position, we should be having the k minus 1 node here, and then we'll say that 12's next should point to whatever is the next of this node, which means that 12 next should be made pointing to this node, and then we will say that the k minus 1's node next should point to 12. So this will point here, and this link is broken, and 12 is inserted in between. And the time complexity, as we have discussed, is going to be order n in the worst case. Okay, cool. Now, very similar to insertion, we can also delete the nodes from the front, from the back, and from any random kth position, right? What is going to be the time complexity of deleting the first node from a linked list? Deleting the first node from a linked list is nothing but just updating the head pointer. That's it, right? Because we know that anything which is before the head pointer is obviously not a part of the linked list, right? So if here is our head pointer currently, and if we want to delete this node, then if we just move our head pointer by one position, and we say that now the head is updated to this node, then that's it, right? Your node is deleted. Now, if you're using C++, then you can actually delete this node, or you can free this node, right? Delete this or free in C++. If you're using Java, you don't need to do anything because the garbage collector is there and it's going to do its job, right? So you just need to increment the head pointer. Time complexity is just order 1 because you are just updating the head pointer. What about deleting from the back? If I have to delete anything from the back, can that also be done in order 1? We already have the tail pointer maintained with us, right? So we just need to delete whatever is present in the tail pointer. Can we do that, guys, in order 1 time? So, right, if we have this tail pointer maintained here, we can definitely just say that whatever is this tail pointer, just change it to null. As soon as we do this, this starts pointing to null, and this tail pointer, the node which was pointed by tail, is deleted. But after we have done this, now can we do another deletion from back in order 1 time? No, right? We cannot update the tail pointer. Why? Because as we have discussed earlier, you cannot go back in a linked list. You cannot travel from right to left in a linked list. So you cannot update the tail pointer while deleting a node. That is why you can do first deletion in order 1. You just need to convert this tail to null. But after that, you won't be having any tail pointer maintained to the last node of the linked list. So after that, you won't be able to do it. So the time complexity here is going to be order n, because then after you have done the first deletion, you will have to iterate over the complete list and you will have to reach the last pointer to delete it. Is that clear to everyone? Same is the case for the kth position as well. In this case, you will definitely have to travel till the k minus 1 position, right? And once you reach the node just previous to the kth node, right? So for example, in this case, let's say we wanted to delete this node. If you want to delete this node, then you need to reach the node which is just previous to this, and then you will simply change the pointer here. You will say that the next of this node should point to next of next, and that's it. Again, the time complexity is going to be order n, because in the worst case, you might need to traverse to the complete list. Cool. So let's solve a problem, which is again a very, very frequently asked problem, has been asked in Amazon and Microsoft multiple times. The problem says that you are given a linked list. You have to find the mid node of the linked list, node which is present at the middle position. Okay. So for example, if this is your linked list, so in this case, the node which is present in the middle is this node. So the answer is going to be 7. Okay. If there are even number of nodes in your linked list, then you can return the first node of the second half, which means that if this is the linked list, then you can return this node. Okay. You can find the length of the linked list. We know how to do that. If the length comes out to be L, then the middle is going to be at the position L by 2. So you can start another iteration from the head, and you will only traverse till L by 2 distance, and you will be getting the midpoint. Okay, that is one approach. Another approach, as suggested by many of you, is by using 2 pointers, right? Using a fast pointer and a slow pointer. Now, guys, a lot of problems in linked list will be solved using 2 pointers, traveling in multiple different ways. That is why we will quickly see this approach and we'll try to understand the intuition behind this. Okay. So, as many of you have said that we can consider a fast pointer and a slow pointer. When the fast pointer reaches the end, the slow pointer will be at the middle point, right? So the intuition behind this is very similar to what would happen in a race of two cars. Let us say we have two cars and we are having a race between these two cars. Okay. And both are starting at the same time from the same from the same position, and both have to reach at this point. Now one of the car is moving with a speed x, the other is moving with a speed double that of the other car. So when this car, the moment this car reaches the end point, where do you guys think would be this car? The moment the car with 2x speed reaches the end line, what would be the position of the other car? The other car is going to be at the center of the road, right? Exact center. Why? Because this car has a speed double that of the other car. So the amount of distance traveled is also going to be doubled in the same amount of time, which means that if it has traveled this L length, then the other car must have traveled L by 2 length. So if this works in physics, this is also going to work in our linked list. So in a linked list, what we can do is instead of having two cars, we can have two pointers, two iterators, right? And one of the iterators, both of them are going to start from the same point at the same time, right? One is slow, the other is fast. And the fast one is going to move with a speed double that of the slow pointer, just like the cars. Which means that the slow pointer, if it is moving with one step at a time, the fast pointer moves 2 steps at a time. So after the first iteration, slow pointers moves from here to the next position. Fast pointer moves from here to this position. Again, the slow pointer moves from here to this position, and the fast pointer moves from here to this position. Okay. Now fast pointer does not have any further nodes to travel. So this means that this has reached the end. And if this pointer has reached the end, it has covered the complete distance. That means that the slow pointer must be at the half distance, right? It must be pointing to the middle element. Okay. So what we have done here is we are just moving two pointers starting from the head. Slow pointer moving one node at a time, fast pointer moving two nodes at a time. The moment fast pointer does not have any other node to move on, the moment fast pointer's next is null or next dot next is null, we stop there. And at that moment, wherever the slow pointer is going to point, that is going to be the middle element.
If you like the video, please do not forget to like, comment and share this video with all your friends. Also, subscribe to our channel to get notified about the new upcoming videos.
Okay, so today we are going to cover stacks. So let me give you first a little introduction about stack. So first of all, the stack is very much important. It's the most favorite topic of the interviewers. Be well versed with this topic. Like first go through the basics, understand it because they are very straightforward, and then attempt as many questions as you can. There are some, standard problems that you should definitely attempt. That was the gist about stacks. Now let's get started. Cool. So stack is very much similar to the stack of objects you see around yourself. So be it stack of plates, stack of books. So stack of plates, stack of books, then stack of, let's say, bowls. So you see it and use it every day, right? So let me draw the stack of plates. So this is how a stack of plates look like. Now from this stack of plate, you can insert a plate only from this end, that is top, right? You can only insert a plate on top, and you can only remove a plate from top. You cannot insert or remove a plate from in between, because that will disturb all the plates, right? So you cannot do that. You can only remove and insert a plate only from top. So that's essentially the idea behind stack, that we can only insert an item from top and we can only remove an item from top. Okay. So conceptually or logically, you can think of a stack like this, where one end is open and three ends are closed. So from only this end, we are going to perform operations, that is to remove an item and to insert an item. As I was saying, that we can only insert an element from one end and remove an element from that end only, and therefore stack is known as LIFO data structure. That is the last, as you can see the stack of plates over here. So this plate which was inserted at the very end will be the first one to come out. That is last in, first out. Okay, cool. So first what we are going to do, we are going to understand stack as an abstract data structure. That is ADT, abstract data structure. What do we mean by abstract data structure? In which the implementation details are hidden, but the operations are given to us. Okay, so let me write it over here, that implementation hidden. Okay, it's not there, it's not given, but only the operations are there. Only the operations are there with which, using which we can use the stack. Okay, so for example, you can see the fan on top of you, right? So you don't know how it's working internally. All you care about its operation, as in you put down the switch and it turns on, and you put off the switch and it turns off. That's what you care about. So that's an abstract. Cool. So we are given, let us understand the basic operations that are available with stack. Okay, so there are 4 basic operations. The first one, I am sure you guys, if you know about stack, you must know about all these operations. So that is push function, and then second is pop, the third is top, and the fourth is empty. Okay, so the push operation actually helps us to push an element on the top of stack. So this pushes an element on top of stack. Then here we have pop. So pop removes an element from top of stack. Then we have top, so it returns the element present on top of stack. So whatever element is present on top of stack, it just simply returns it. Okay, so don't worry, we are going to see an example over here. Is empty is the function that tells us if the stack is empty. So if the stack is empty, it returns true, else it returns false. Okay, so these are the 4 operations, that is push, pop, top, and is empty. Push pushes an element on top of stack, pop removes an element from top of stack, top tells what is on top of stack, and is empty returns true if stack is empty, else it returns false. Remember that pop simply removes an element and top does not remove an element. It simply tells what is present on top of stack. Is it clear now? Okay, so basically while performing a question, you will have to use in C++, let's say you can use STL, right? In STL you have stack. So in C++, you declare a stack like this. You can use a stack like this, and on this object basically you can call all these functions. So push x, then s.pop, and so on. Likewise in Java, you have collections using which you can use stack. So while attempting a question, you don't have to implement a stack of your own until and unless told. Okay, so but in a while we are also going to see how to implement a stack. We are going to actually implement these operations. Okay, cool. Okay, so let's actually see a dry run of these functions. So here this is a stack, and these are the operations that I would want to perform: push 2, push 1, push -1, push 5, then pop, pop is empty, top. So let's perform these functions. Okay, so it's push 2. So what we'll do, from where we'll put it from here. So basically 2 will come over here, then it's push 1. So 1 will come over here, then -1, -1 will come over here, then there is 5, 5 will come over here, then we are popping. So 5 will be gone, right? 5 will be gone. So we have removed 5. Now again pop is there. So -1 will be gone. So we have removed -1. Okay. Then we are checking, is the stack empty? What will it return? What will this return? it will return false because the stack is not empty, right? The stack is not empty. Okay, so now there is top. So what will be the top function return? It will return whatever is present on top of stack. So basically top is pointing over here. So whatever is on top of stack, it will return that. So it will return 1, right? It will return 1. So that was a simple dry run of how can we use these operations. Okay, how these operations work. Now let us come to the applications of stack, which are very important. Applications of stack. So some of the applications are undo, redo. Then we have arithmetic expression, evaluation, right? Then we have recursion. So these are some of the, then we have string reversal and so on. So these are some of the applications of stack which are very important and you must know. So try to figure out that how a stack can be used in these operations. You know, that's an activity for you, that do try to search that how we can perform an undo redo. So this is actually present in your browser, right? So whenever you go to any page, from any page and want to come back, so basically you store, for example, let me give you an example. So you are at link, let's say 1, then you go to link 2, then you go to link 3 and you want to come back to link 2. So what you can do, you can actually maintain a stack of them. So like first you are on link 1, you can put it on a stack, link 1. Then you are going to link 2. So put it on top of stack. Then you are going to link 3. Then put it on top of stack. Now you want to come back to link 2. So what you can do, you can simply remove this. And now you are back to link 2. Does that make sense? So likewise, you can also have a redo stack. Okay, so that's an activity for you, that how you can perform a redo operation. Okay, so likewise try to figure out. And we have arithmetic expression evaluation. So I think you all must be very much familiar with this. That is, you know, converting to infix to prefix or postfix, then evaluating the postfix notation. So that's where you can use stacks. Okay, and then you have recursion. Stack is a core of recursion. So you make function calls, and when you come back, so that basically those function calls get stored on top of stack. Okay, likewise string reversal. Okay, so there is another application that you may be using in your daily life. You must have seen this InShots app, right? So what happens in this, you are on this screen, okay, and so here I am actually at my feed. I am at my feed, okay, and I am watching this news. So I can only see another news if I remove it, if I remove this. So can you see that how this is an implementation of stack, right guys? Now let's talk about the implementation of stack. So could you guys tell me how can we implement a stack? So using arrays, second is using linked list. Okay, so how can we implement a stack using arrays? So basically, let's see. So we can have an array. So size of the array is, so array is A, and size of the array is 7. Okay, so what we can do, so let's say I want to push 2, push 3, push -1, pop, push 7, pop. Let's see how can we implement these operations using stack. Okay, so what we can do, basically we can actually enforce that one end of the stack will be there to perform all the operation. So you can imagine it like we are pushing the elements from here and removing the elements from here. So let's say I want to push 2, so 2 comes over here. Now you can also maintain a top variable which is right now pointing over here. That means what is on top of stack? 2 is on top of stack. Then we have push 3, So what we can do, we can simply increment this top variable and push 3 in here. Then push -1. So we can simply increment this top variable and push -1. Now how to pop it? How can we pop it? Top minus minus. So basically we are now at index 1 and we have, so basically -1 is gone. Okay. Then we are at, so this was done, then we are at 7. So again we can increment the value of top and 7 comes over here. Now again pop's coming, so we can come over here and this is gone. So basically that's how we can operate a stack using arrays. Okay, and now can someone tell me the problem of stacks? So problems of stack are, which are very important if let's say an interviewer asks you to implement a stack using arrays or linked list. So if I talk about arrays, then we have problems, overflow and underflow. Let's say I want to push 1, 4, 0, 5, 6. These are the items that I would want to push. So 1 comes over here, then 4 comes over here, then 0 comes, then 5 comes, then 6 comes, and now I would also want to insert, let's say, -1. So as you can see, as I move my pointer forward, there is no space because array has a fixed space, right? So I cannot insert any more element, and that leads to the condition of overflow. Okay, and it's very important. So if interviewer has asked you, he's basically maybe judging you that will you cover these cases or not. Okay, so this is the thing. So how can you handle it? So basically here you have mentioned a size, right? You can keep a check that if size, so if top is equal to the size -1, so in that case that's an overflow. You cannot insert any more elements. So that's a drawback of arrays, and to overcome that, basically you can use something known as dynamic arrays. Okay, you can use something known as dynamic arrays. Okay, now let's say I want to pop, I'm calling pop 7 times. Okay, so basically this is gone, third time, fourth time, fifth time, sixth time and seventh time, and now I am again calling. So now what will happen? Will I be able to pop any more element? No, I will not be able to pop any more element because the stack is empty. So if I attempt to do so, that will lead to underflow condition. So how can you make it all right? Basically, you can put a check that if top, so if top is equal to, let's say, -1, then print underflow. Okay, and simply return. So that's how you can manage underflow and overflow condition. Does that make sense, guys? Underflow is when you are trying to pop an element when there doesn't exist. When you are popping an element when there is no element. So how will you be able to pop? Will you be able to pop? No, right? So that's the case of underflow. So you can manage the case of underflow by checking that if top is equal to -1, that means you have no element, so you simply print underflow and return. Cool. So let's talk about linked list. So in linked list, what you can do is, so you have nodes in linked list where this is the data part and this is the address part. So basically the nodes of the linked list can be present anywhere in the memory, right? Like array, you don't have everything in a contiguous manner. Everything is scattered. Every node is scattered in linked list. Basically, if you have this as a memory, so if let's say one node is present over here, another node can be present over here. Okay, third node can be present over here. So basically, this address field actually links node. So basically, this will be linked to, let's say, this, then this is getting linked to this, and so on. That's how we store data in linked list. So basically, let's say you have 2 and 1 right now. Then you want to insert, you want to push, let's say, 7. So how you can do? Right now, top is here. So at what position, if you, so you are actually, remember, you are actually implementing stack using linked list. Where would you want to insert this node? This is your linked list. This is what you are building. this is the temp node, current node, that you new node that you want to insert into your linked list. So where will you insert it? That we can actually put it on top of head. So now we can actually make this its next pointer point over here. So this is how our stack would look like. Now top will be over here. Okay? So you can, in case of a linked list, you can imagine a stack like this. Like this it's growing, right? Like this is it's growing. And when you want to pop an element, so basically you can actually shift this top to the next position, and this will be, so basically you can free up this space. Okay? So that's how you can implement a stack using linked list. Now with linked list, the concept of space, a lot of space is used in linked list. Okay, so basically you are storing pointers as well, that will take a lot of space. And pros of both stack and cons is that you will be able to perform push and pop operation in just order of one time complexity. Okay, in just order of one time complexity. Okay, cool. Let's get to the question. Okay, so the first question that we have is of very much famous question and very much asked question. It's of valid parenthesis. Okay, valid parenthesis. So the question says that you are given brackets, the round brackets, okay, and you have to tell whether the parentheses are balanced or not. Let's say you are building this compiler in which you will be writing your code, right? So basically you will be you want your compiler to check, verify your code. So in that case you will definitely want how can we check if the bracket are valid or not. So how can we do that? Let's see. First of all, let me give you some examples. Let me write down the examples. Okay, so what do you say about the very first parenthesis? What do you say about the very first parenthesis? Are these set balanced? Is it balanced? Yes, it is balanced because a corresponding opening bracket has a corresponding closing bracket. So yes, it's balanced. Then if I talk about this, is it balanced? No, it's not, because this is complete. They are balanced, but here this opening parenthesis is lacking a closing parenthesis, or you can also say that this parenthesis is lacking a closing parenthesis. So this is not balanced. This is not balanced. Likewise for this, so this is lacking an opening bracket, or you can also say that this is lacking an opening bracket. So this is also not balanced. Okay, so you have to basically tell, are the parentheses balanced or not? Let's say we want to attempt this question without stack. Can anyone think of something? Okay, so let me first actually put some observations. Let's do the question step by step. Okay, let's do the question step by step. So observations are, the first observation is that, can an opening bracket make a string invalid? As in, let's say I'm traversing the string and I find an opening bracket. So can that opening bracket make the string invalid? Well, it depends upon the future. It depends upon the future, that if I have this opening bracket, maybe in future I'll find a closing bracket and that will be valid. Or let's say I don't find a corresponding closing bracket, in that case it will be invalid. So it totally depends. It totally depends if I get an opening bracket. Okay. Now if I talk about a closing bracket, so what about a closing bracket? Can a closing bracket be a problem to us if we encounter it? Well, so if till now for a closing bracket there was no opening bracket, in that case, yes, it is a problem, because even if we move any further, the string that is given to us will not be valid in any case, right? In any case. So basically, let's actually okay, let's take look at it like this. So I have something like this. So what will happen? Let it be like this. So I am at here. I will maintain, what I can do, I can maintain a left and right count which can be initialized to 0. Now I am at an opening bracket. So that means left actually tells a opening bracket and right tells the count of a closing bracket. So I found an opening bracket, this becomes 1. And so let this be the thing. Let this be the bracket. Now I am here. Now I am here. So what I can do? I can simply decrement the value of this, and that will tell us that we actually found a match for an opening bracket. We actually found a match for an opening bracket, so we can actually set this to 0. Right. Now let's say I have a string like this. What will happen? What will happen? That I am here, left and right. So basically I have left 1, then I have a closing bracket. So initially both are 0. So now this is a closing bracket. So is left greater than 0? Yes, it is. That means there is an opening bracket. So we can simply decrement it, telling that we have found a match. Now next we go to the next character. This is a closing bracket. Okay. So what's the value of left? It's 0. That means there's no opening bracket. In that case, we will simply return that it's invalid, because at this point there is no use to move any forward, because this closing bracket does not have a matching opening bracket. So we can simply return from here. Does that make sense to everyone? Okay, so whosoever is saying that can we count the number of opening bracket and the closing bracket? Guys, we cannot simply count the number of closing bracket or opening bracket. Okay, let's take an example of that. Let's say I have this as a string. So now left is equal to 2, right is equal to 2. But are they valid? Are they valid? No, they are not valid, because they are not placed in the correct order. Therefore, this is not a right approach. Is that cool? The time complexity of the approach is what? What's the time complexity of the approach? So if we have this case, here the number of opening brackets, closing brackets are 2, number of opening brackets are 2. So are they valid? No, they are not valid. So this is wrong. This way is wrong. So what's the time complexity, guys? Time complexity is just order of length of the string, because we are iterating the string just once. And what's the space complexity? Just order of 1. We have not used any space. Okay, we have not used any space. Now let me make a question little trickier. Now let's say I have brackets these and these. So this is an extension of the question. Extension hai ye question ka. Now I am saying that I have these 3 sets of parentheses. Now I have to tell, basically my string can contain these set. So I have to tell if those are valid or not. Let's take an example. Examples can be this, then we have this. So this will be given to you. Now you have to tell, are they valid or not? Now can you, how can you do it? How can you do it? So whenever in the interview you're telling the interviewer that okay, we can use stack for this, but she or he already knows, right? You have to get to it. Like how? What's the intuition? So that's is very important. Okay. Some of you are saying that we can use 3 variables. So that will be wrong, because then you won't be able to actually find the order. You cannot judge the order by taking that many variables. So first of all, I am sure that you guys understand that it cannot happen by taking just the left count and the right count, because if okay, so first of all, let's take the example of this. Now here left is 1, okay, and now I find a closing bracket, but here they are not same, right? So this will not work. Having left and right is a bad idea. Now taking 3 variables. So here I have this string. So if I take 3 variables, let's say round, or let me write first bracket, second bracket, third bracket. Now here the first type. So this is type 1, type 2, type 3. First bracket का left right, इसका left right, then इसका left right. First का left is 1, okay. Third का left is 1, okay. First का right, So we have found a right bracket and this manages to be 0. Then we have third ka right. So this becomes 0. But is this valid? No, it's not valid because the order is different. Order doesn't match. So therefore, that's a bad choice. Does that make sense? You should have a clear idea that why your approach is wrong. You should take as many, like if you are stuck, you are not able to think, take examples and try to generalize it. You guys are clear with it? Cool. So let's move forward. Now let's actually build some intuition of this. So one thing is that let's consider these bracket. One thing is that so this is invalid, right? This is invalid. This is also invalid, right? This is also invalid. This is valid. This is valid. They have right set of pairs. Now this is also, this is what? This is what? This is also valid. Okay. This is also, as you can see, that this is also valid. So if I talk about this string, then it's a property of the valid parenthesis that if the complete parentheses are balanced, then their sub parenthesis will also be balanced. As you can see that this is balanced, this is also balanced, this is also balanced. So we are not considering all the substrings, right? We cannot consider anything like this or something. We have to choose the right set. But what it means is that whatever the parentheses are inside it, they will be balanced anyhow. So this is its corresponding pair. Then we have this, it's correct, then it's correct, then this is there. So does that make sense? That inside of it parentheses are balanced? Now, so an opening bracket does not bother us, right? An opening bracket does not bother us because in future we may find a closing bracket for it, right? But let's suppose I am at this closing bracket. Let's suppose I am done with everything and I am at this closing bracket. Now for this closing bracket, this is an opening bracket, this is an opening bracket. Does these brackets are of any use to me? No, they are not. Can I get rid of them? Then that will be great, right? So if I can get rid of them because they are valid in itself, right? As I told you by this property. So since they are valid, if I can get rid of them, then I can actually find out if this bracket has a matching opening bracket. Okay. So let's actually see a dry run of this using stack, because stack is the data structure that helps us find. Just look at just the past. Okay, just the past. So how and what we can do? We are at this bracket. This is our opening bracket. We'll see about it in future. So push it onto the stack. Then this is an opening bracket. We'll see about it in future. Put it on top of stack. Again an opening bracket. Put it on top of stack. This is a closing bracket. Was there an opening bracket for this? Yes. Where can I see? I can see it on top of stack. If there is a corresponding match for this closing bracket, then I can simply pop it off. Next time here, this is a closing bracket. Does this have a match? And see how nicely we have removed between whatever was presented. That is here, we have removed it. We have removed it. And now we are actually comparing this. Where can we find it? On top of stack. So yes, it has a match. Remove it. So now we are here. Now we are here. Put it. So this is our closing bracket. Yes, match found. So remove it. Remove it from top of stack. Then we have an opening bracket. Push it on top of stack. Okay. Then we have a closing bracket. Is the corresponding opening bracket present? Yes, it is present. Remove it from top of stack. Now we are at the last bracket. Is the corresponding opening bracket present? See here how we have gotten rid of all of this, right? So basically, yes, it's present. From where we can find? On top of stack. Just remove it. What's the condition we have to check for validity? That if the stack is empty, then return true, right? If the stack is empty, return true. But if the stack is not empty, so we have to return false. That tells, even after iterating the string, let's say we have completely iterated the string, even if the stack is not empty, so we will have to return false, right? Because there are still left some unmatched opening brackets. So at any time, let's say you have something like this. So at any time you don't find, so okay, let's do a dry run of this as well. So this is an opening bracket, move ahead, opening bracket, move ahead, closing bracket, but no corresponding match. Simply return from here. Simply return from here. Okay, so now let's move on to the next question. But before that, let's talk about the time complexity. The time complexity of this approach is just order of n, because we are going to each and every bracket not more than twice. How? Once while pushing it and another time while popping it. So that's only 2 into n, which makes it order of n, right? That makes it order of n. And the space complexity is order of n, because in the worst case we may end up pushing all the brackets in the stack when, let's say, the string was something like this. In that case you will end up pushing all the brackets in the stack. So the space complexity is order of n. Okay, so I hope that's clear, and we'll quickly move on to our next question. So intuition is that how can we, previously clear up something to get just the, so here as I talked about that step by step we made the intuition, like, sorry, I just removed it. So as I was talking about that, inside of it will also be, balance. So if we can remove it, I will just be able to look at here. That's what I want to do. So we can simply remove it, and that is possible using stack. Okay, so let's move forward quickly. Cool. So question 2, and this is very, very famous question, which is of next greater element. Okay, so question is that, let's suppose you are given an element, you are given the elements in an array. Let's suppose 10, 13, 22, 7. For each of these elements, you have to tell that what is the next greater element to its right, just the next greater element to its right. So what's the next greater element to the right of 10? It's 13. Okay, it's 13. The next greater element for 13, it's 22. The next, is there any next greater element for 22? No, it's not. So we can put -1 over here. We can put -1 over here. Then we have 7. So next greater of 7 to right of it, it's -1. Nothing is there. Nothing is there. Okay, so let me take, this was example 1. Let me take another example as well. So we have 10, 7, 4, 2, 9, 10, 11, 3, 2. Okay, so what's the next right to the right of 10? It's 11, right? Just greater element on the right of 10. It's 11. Just greater element on the right of 7. It's 9. It's 9. Just greater element to the right of 4. 9 again. To the right of 2. 9. Just to the right of 9. It's 10. Just to the right of 10. 11. Just to the right of 11. Nothing. To the right of 3. Nothing. To the right of 2. Nothing. Okay? Okay, cool. See, if you are implementing any question, you can use STL in C++ or collections in Java. You don't have to implement push pop functions on your own. That's just for the sake of, if let's say your interviewer asks you. That's it. Okay, that's it. Cool. So if the question is clear, please tell me that how can we attempt it. At least give me the brute force approach. At least give me the brute force approach. So you will agree with me that brute force is nothing. So brute force is using 2 loops. So you can basically, let me actually write the code for it as well. So the brute force look like that. You can have an answer variable, answer array. Then you can iterate through all the elements from 0 to n-1. Then for those elements, you can again iterate from. So, okay, first you can initialize your result to -1 if let's say you don't find any element. So you can do for j that goes from I plus 1 to n-1. You can check if a of I is, so a of I is less than a of j, then simply put answer I is equal to aj. ठीक है, and break from here. Take a break from here because you just have to find just the larger element. You don't have to iterate any further. Okay. Now what do you have to do? Actually, this should be result, and out of this for loop you can set answer I is equal to result. Does that make sense? This is just the brute force approach. Okay, cool. Let's go ahead. So the time complexity of this approach is order of n square, since there are two nested for loops, and the space complexity would be order of n, which we can ignore because that will be just to store the, so basically this is just so we can actually make it order of 1 only, because we anyway have to take an answer array. Answer array we anyway have to take because that's how we are going to return the answer. So the space complexity for this we can assume to be order of 1, right? Cool. Now let's talk about the optimized approach and let's build some intuition for that. Let's see some observation. The first observation is that let's suppose the array elements are 12, 10, 9, 8, 7. Okay? 0, 1, 2, 3, 4. If let's suppose these were the elements, what is going to be the answer for them? What's going to be the answer for 12? Minus 1. Nothing is on right. For this, minus 1. For this, minus 1. Minus 1. Minus 1. Does that make sense? The answer for all of them will be minus 1. Now let's talk about another example. Let's say we have 5, 4, 3, 2 and 10. Now can someone tell me what is going to be the answer for 5 now? For 5 it's going to be 10. For 4 it's going to be 10. 3, 10, 2, 10, 10 minus 1. Does that make sense, guys? Cool. So the thing is that as you can see, when the sequence was in decreasing order, we got minus 1 for them. And here we also had a sequence in decreasing order, but once we got an element which was greater than them, so this element was greater than these elements, so the answer for them became 10. The answer for them became 10. Look at it like this. So let's suppose I have 5, 4, 3, 2, 10. So I start from here. This is 5, then this is 4, this is 3, this is 2. Now 10 came. So once the number came which was out of order and greater than them, so answer for them became 10. Okay, answer for them became 10. Let's look at one more example. We have 9, 6, 5, 4, 8. So this is 9, this is 6, this is 5, 4, then 8 came. So 8 is 8 to whichever element it is greater, it will become the answer to them. That is here. So this is 9, this is 6, this is 5, this is 4, this is 8. So 8 will become the answer for 6, 5 and 4. Okay? So basically now once we have got the answer for them, can I just ignore this and start by finding the answer for these now? Does that make sense? Does that make sense? Okay, giving you some intuition that here we are also ignoring whatever was redundant from the past. The idea here is that we have a monotonic sequence. We have a monotonic sequence over here. Monotonic sequence is when we have a decreasing or increasing sequence. So my point is that I had a decreasing sequence. Once I find an element out of order, so all the elements which are smaller to this will be the answer for them. This will be the answer for them. Okay? Now, so basically, let's say I have elements 11, 4, 3, 2, 10, 12. So I have 11, then I have 4, then I have 3, 2, 11, 4, 3, 2. Now 10 comes. Now 10 comes. So 10 is greater than these numbers. So answer for these will be 10. Answer for these will be 10. Now since we have got the answer for them, we can actually remove this. We can actually remove this, and now it will become such a sequence. It will become such a sequence. Now 12 comes. So this will come over here. Now whatever is smaller than answer to them, 12 will become the answer. So 12 will come over here and 12 will come over here. Now only, so we have got the answer for them, so we will remove it, and now we are just left with 12. We have completely iterated the array, and whatever we are left with, to them the answer will be -1. Okay, so since we are ignoring whatever is redundant to us previously, and since this is a monotonic sequence, therefore stack will help us over here. So let's see the dry run using stack. So intuition was that we had to look at the just past, removing this just past. So whatever answer we had got, we will just ignore them, and now we'll start again from some monotonic sequence like we did over here, over above, right? Okay, so now let us go through the dry run using stack. Then again, if you guys will have some doubt, we will come to those. Okay, so I have 11, put it onto the stack. So 11 has been put onto the stack. Then we have 4, put it onto the stack. Then we have 3, put it on top of stack. Then we have 2, put it on top of stack. Then we have 10. Now this, you can see that this is a decreasing order. This is a decreasing order. Now we found an element out of order. So to whatever elements 10 is greater, the answer for them will become 10. So is 10 greater than 2? Yes. So we found the answer for 2. Answer for 2 is 10. Remove it. Is 10 greater than 3? Yes. We found the answer for 3. The answer for 3 becomes 10. Remove it. Now is 10 greater than 4? Yes. So we found the answer for 4. The answer for 4 becomes 10 and simply remove it. Now is 10 greater than 11? No. So simply push 10 onto the top of stack and move ahead. Now we are at 12. So on top of stack there is 10. 10 is lesser than 12. So answer for 10 will become 12, right? Answer for 10 will become 12. Now, so we are at 12. Is 12 greater than 11? Yes. So answer for 11 becomes 12. Okay? So now nothing is there. Simply insert 12 on top of stack. Now move ahead. So we are done. We are left with no more elements. So whatever is present on top of stack, the answer for them will become -1. So in this case, answer for 12 is -1. Guys, does that make sense? So Anshul says that then in this solution, we need to also store index and stack. Anshul, that's what we are going to do. We actually need to store indexes on top of stack because we actually are trying to find the answer for the previous elements that we are done with. So let me quickly show you a dry run of how we can do this using indexes. Okay. So we are having the stack. We will place 0 over here. Then we will place 1, right? Then we will place 2. Then we will place 3. So basically still the array is in decreasing order. Now we found 10. So this 10 is greater than what is present on top of stack. So basically answer for this. So we will write it like this. S dot top. Okay? Because this is the index. So a of 3 is nothing but 2. So 10 is greater than 2. Answer for this has become 10. Then likewise, answer for this will become 10. Element at index 1 is 4, which is lesser than 10. Answer for this becomes 10. Now 11 is not smaller than 10. So we will simply push the index of 10, which is 4. Then we are here. Now this is 12. 12 is greater than a of s dot top. So we will simply mark the answer of a of 4 as 12. So this is 12. Again, so as we remove it, then a of 0 is lesser than 12. Answer for a of 0, that is 11, will be 12. And now whatever is present on stack, whatever is present in stack, you will simply mark their answer as -1. So you will put -1 here. And the time complexity of this approach is order of n. Since we are putting an element and removing an element just twice, so again order of 2 into n, which is nothing but n. And space complexity in the worst case can be, when let's say the complete array is in decreasing order, it will be order of n. So does that make sense to everyone? Okay guys, so we have actually placed the link to the questions for the next questions. Okay, so hope you guys try it, and guys, this was it. I hope you enjoyed it, and if you enjoyed it, please like and subscribe and share this with your friends as well. Okay, cool. Please try them. See ya. Bye bye.
Hello everyone, welcome to Scalar Academy's YouTube channel. Myself Vamsi. In this tutorial we will be talking about DBMS. DBMS is very important concept in perspective of interviews, whether you are attempting for any product based company or service based company. Having a knowledge of a DBMS and the concepts of DBMS is very important. Okay, it will definitely add an big advantage to you in an interview. So in this tutorial I will be starting right from the basic, so you can watch this without any fear. If you are an non-CS student, you can watch this. Okay, so like at the end of the video I'm pretty much sure that you will have a good understanding on how databases works, how what is a database and overview of databases, and some important concepts as well. Before starting, we have a few formalities to complete. First one, so if you are visiting channel for the first time, please don't forget to subscribe. If you like the content, please hit that like button up. And if you have any questions or if you have any video request that you would like to hear from Scalar Academy, please let us know in the comment section. Now let's start with introduction of a database management system. So before starting that, before discussing what is DBMS, let's try to divide this entire word database management system, and we'll see what it one each module can do. Let's say, okay. So let's take this data. So what is a data? What is a data? So I can say that any fact that you would like to store or preserve for future references is called a data, right? Now what is a database? How can we say that? So a database is a collection of a related data. So let's say you are storing the details of college students. Okay, in that particular, let's say I'm storing my details, let's say Vamsi, my roll number, my address. Okay, let's say Bangalore. So this particular thing would be my data. Okay, so if I store all my college student details in one particular place, that will be called as a database. Okay, make sense? Now let's go to a next one. So management system, a database management a system. So now let's understand. So I have an 5,000 data residing in my database. Okay, now I had a few things like one student left my college, he joined another college, so I need to delete that particular student data in my college database, right? So I delete. Now so I have to update one student mobile number or email ID, whatever it has. Okay, so already that student data has been in my database. Now I wanted to update that data. Okay, so simply I need to modify my existing data. Now one student joined in my college. Okay, joined in my college, so I need to insert his data, his or her data into my database. So insert. So all this thing kind of things, I can say that I'm managing my data, managing my databases. So how can we manage? There are some database management systems that helps us to manage your databases. Okay, so such kind of things will be called as a database management system. So how can you say that? So nowadays like all the databases has been computerized. So to perform the operations like a modify, delete, insert kind of things, we need some systems or software which helps us to perform such kind of operations. So those that kind of softwares will be called as a database management systems. Okay, makes sense. So we are done with the data, we are done with the DB, we are done with a DBMS as well. Now, on top of all these things, there is one thing. Okay, what is that? So the combination of database plus a database management systems is called database systems. Okay, so the combination of a database and a database management system is called database systems. Now you might have a doubt how we are storing our data in the databases. How many types? Like, okay, so yeah, there were different data type databases are exist, but nowadays people are using two things mostly. So one is DB types. Okay, so a relational a database. Okay, so what is a relational databases? So a relational database, if I want to say it in simpler manner, the data has been stored in the form of tables. Okay, so when I say tables, we are having a columns and rows. Okay, we are storing our data in the form of columns and rows. Okay, let's see. So suppose I am storing the student database, like student details in an art database. Now tell me what are all I can store. So let's say attributes of a student. So what I can have for a particular student, I can have a name, then a roll number, then address of a student, then a mobile number, email ID, parent names, go on. So I will have these kind of things for a particular student. So it is common for every student. So these things will be called as an attributes or properties of a student. Okay, so I'm going to I'm considering these attributes as my column names, as my column and names. Now so let's draw on one table. Okay, we'll see how we are storing that thing. So let's say now I have my attribute names as a name, a roll number, or let's say mobile number. Now I'm storing the student data now. Okay, so let's say first one, see, roll number 500, so mobile number something 1 2 3 4 5 6 7 8. Okay, now again, so this particular will be called as an one record. Okay, then I have another student thing, so let's say ready. Okay, his roll number is 501, and let's say mobile number is all zeros. Okay, so this is data. So again I can call this as a record. Okay, one record. So these can be called as a records, or I can call them as a tuples as well, and these are all the attributes. So the data, if we store our data in the form of this table, then we are calling it as a relational databases. Okay, relational database. Now there is another famous database exist. So what does it now? NoSQL database. So what is this NoSQL database? Okay, so we'll come to that what is a SQL in later part. Okay, now as of now let's discuss what is a NoSQL. So here let's say, so I have there will be something like schema. So what does it a schema means? So it represents how you are storing your data, and like let's say in simpler matter you can say that it's a format. Okay, so you will be defining. Okay, so when I say a student table, okay, so this is a student table, then I'm stating that you need to have a name, you need to have a roll number, you need to have a mobile number. So if any of the student won't have any of these column or attribute, just don't store his data in a table. So in that cases what happens, we are losing one particular record, right? We are losing our one particular record. Then is there any point of storing all the student names, like eliminating few student names? No, right? No, there is no point. So to overcome that bigger problem, we have a NoSQL database. So what is a bigger difference between this a relational database and a NoSQL database means? Now you don't have any particular schema, or format, how to store a data. Okay, so whatever the data comes from an user or database admin, it will store that. It won't ask any question like, so you are not giving mobile number of a particular student, you have given email of a student as well. It won't raise any kind of questions. It will just store whatever you give. Okay, here in these cases we are not eliminating any data, so but we does it in relational databases. So that's the major difference between the NoSQL and coming to application of these databases. So it's quite obvious, so everyone knows about it. So nowadays everywhere databases are being used. So hospitals, let's take hospitals. So in hospitals we are storing our all the patient records, and we are keep tracking of monitoring the particular student with his medical reports, right? So in colleges or like educational sector, in educational sector, we are storing the student details, right? In every college that happens. There is no separate introduction or how we are storing that data. So in every college, they call college management used to store our details, like amount of fee we have paid, amount of CGPA you have, or what are all the companies you have secured, kind of stuff, right? And coming to another, let's say online shopping. So we are storing the vendor details, like whoever all the products are products are selling, and whoever all the buying, like let's say I have ordered one a particular laptop today. Okay, I have ordered one particular laptop. So the data the details associated with this my order are seller details, buyer details, like amount I have paid, transaction ID, so amount, delivery date, who delivered my particular order, my address, my mobile number, all this data has been stored in the database. Okay, so yeah, like this you can consider any application. So nowadays our databases are became very vast. So without without using our databases, like all industries or any sector is not running. Okay, be it industries or like manufacturing units. In manufacturing units as well, they are keeping track of what are all the like products they have built or manufactured in this particular date, who are all involved in that particular manufacturing, right? So and entries and exist to keep track of employee working days, kind of stuff, right? So these are all the few database applications, but I request you to think of in an your own manner, try to write your own applications. Okay, so what is before DBs? Like now I am teaching, like now we are learning about DBs. Now before DBs, what there exist? There exist like simpler file systems. So they are storing data in our laptops only, right? File systems. So if I say, what are all the difference between a file systems and a database? Let's say file system versus a databases, right? So if there is some problem, that's why we have moved on to the new thing. Yes, so that's our responsibility to know why we have moved, why we are moving towards a new thing, why we are adapting new culture. It's a very similar for anything. If there is a something and we are learning something new, we have to know the problem that were occurred with the existing system. Okay, now I can say that first thing would be data redundancy. So what is a data redundancy? So redundancy means a storing or keeping a multiple records. Okay, let's say duplicates. Okay, a duplicates. So in file system, we used to store our duplicate values as well. But while coming to DBs, there is some concept like normalization. So with that principle, we are eliminating the redundancy. Means we are eliminating the no duplicates. Okay, we are eliminating the duplicates. So obviously, let's say there are 100 records in a particular college. Okay, college. Now suppose I am storing a duplicates values as well. It became 200. Now obviously my space has been became larger, right? So instead of consuming 100, let's say each record is consuming 1 MB. Okay, now instead of consuming 100 MB, it has now consuming 200 MB. There is a lot of space wastage. So again, apart from space wastage as well, there is something like confusion. We are often get confused, so what to consider, right? So in that cases, DBs are very good at it, managing that kind of stuff. So in DBs, no redundancy. Okay, and next thing, security. So obvious that in file systems we don't provide any security, so anyone can access if they are login into my system, right? So in that cases we are not providing, there is no security for our data. But when coming to a databases, we do have an concept like constraints. We provide a constraints for our DBs. Okay, so without like with that constraint, it allows, okay, it won't allow people who don't have that particular kind of permissions, or we are not able to send or receive data as well. Okay, now data consistency. So let's suppose we'll take an example. So there is a one particular student. Student is enrolled in 6 courses, right? For every semester, student should enroll in 6 courses. Now, so obvious that obviously, so student record will contain like that particular student record will contain in every course. Okay, let's say suppose I wanted to modify or update his one of its attribute, let's say email ID. Okay, I wanted to update his email ID. So I went and updated his email ID in one particular course. Now tell me, what about all remaining courses, like about 5 courses? What happens? It won't get updated. We need to go manual and we need to update that, so that I can say that data is inconsistent, right? So the data also, once I updated, it is not updating all the things, right? So in that cases, file systems get failed. But in DBs, it is a really successful thing. That is one thing that really fascinated people towards our databases. Okay, now yeah, so we discussed it so far. We discussed a few advantages of DBs, but now let's see disadvantages of DB. Disadvantages of a DB. Now first thing, obvious thing, that maintaining and the cost, like maintenance cost of an DB is a little higher than maintaining cost of file systems. Okay, that is a one thing. Okay, and second thing, one thing that so those whoever have any knowledge on how to interact with computer like databases using programming can only use databases, right? So those whoever have a knowledge on DBMS or any language which uses like which comes under DBMS like SQL or anything can interact with the DBs. Otherwise, they can't. So that is one of the biggest advantage. But in file systems, anyone can. Those who ever have knowledge on computers, yes, they can interact with the file systems and data. So, like I can say that a knowledge of computer or a DBMS must. And there is also like it's a little complex to understand those core like schemas and how we are getting the data, how to write queries and all. So obviously these are all stuff makes an person to get confused a little better. Okay, now let's talk about architecture of DBMS. So basically, the architecture of DBMS will depends upon the system which you are running your database systems or queries. Okay, so let's say we'll talk about a standalone missions. Okay, standalone systems. So what does it a standalone systems means? So basically, so you have in let's say you are using your file system as your database. Okay, so you are writing a user. Okay, you are a user, and you have a file system. Let's say you can that file system you are using it as a DB. Now where is this a query is being processed? That is being processed within your system, right? Within your system, so you are not using any connections, so you are just going, so like networked connections. Okay, so you are not using any of those kind of things, so because just because you are using the database which is inside your system. Now there are another kind of systems, let's say client server architectures, where like you are in a distributed environment or you are using some servers right from like where let's say your office is in Hyderabad. Okay, so but you are trying to access the DBs which are residing in like some places like US, Europe, Australia kind of stuff, right? So it might happens. So this is another structure. So here you will have some client server, let's say client here, and your server resides at another place. So you are making a request to server. Okay, so there are the two kind of systems you might have. And now are there like there are three types of architectures are there in DBMS. Okay, what are they? First one is a single tier architecture. So a single tier architecture means so this is the example of so yeah, single system standalone system is the best example for single tier architecture. So where you are both like client and server residing in same system, and which you are not using or you are not connected to any kind of network connections. Okay, you are not using any server, so you are just using the server which is residing in your own local system. Now second one is a two-tier architecture. What is this two-tier architecture means? Let's say we have a client, okay, let's say client or user, and you will have one, let's say you will have some a DBMS application. You are calling this as an client, and your database has been residing in server, like you are calling it as a DBS, so database system. So how this process happens? So basically as a user you will make an one query, simple query by using a database application or software, whatever it might be, and that like DBMS application or software, it will try to get connected to the server. So through the some networks like so it might be that network interface might be any let's assume JDBC or ODBC interfaces. Okay, so by using that you are trying to access the data from a DB systems. Okay, so this is the two-tier architecture. Now we'll talk about the three-tier architecture. So what is this three-tier architecture? So it's the same as a two-tier architecture only, but the only difference is, let's say this is your client, user is having a DBMS application. So let's say a client DBMS application. Okay, now this client client application will get connected to server DBMS application. Okay, so by using this server DBMS application, you can access the data from database systems. Make sense? So again, you are using any network interfaces here, as we discussed earlier in two-tier architecture, same as that. Okay, so here your client database application don't have a direct connection to your database systems, so you will send and process a request to the server database application, then your server's database application will process that thing from the database systems, then that will get then again, so server's database application will give you that results to your client architecture. Okay, so this is about the architecture of DBMS. And again, there is another architecture called a three-level database architecture. Let's see, DBMS, a three-level architecture. It's a very important question. Okay, you might get a lot of questions based on this question, like topic. Okay, so again, this topic is being called as an views, okay, views of databases as well. Okay, so basically there will the database architecture has been divided into three parts. Okay, three parts. So first part is being called as an external level. Again, this can be called as a view level as well. Okay, here you will have different users. So let's say user 1, user 2, user 3, and everyone has their own view, right? Like you can be like your GUI, okay, graphical user interface. Now this is the first level. Now you will have another level, so which is called as a conceptual level or logical level. So where your so it won't tell anything apart from like the data. You have to store the data in database, something like this. Like there will be something like schema, and okay, so it helps to design, like it stores that schema and it decides how to store that particular data. Okay, and also it will says some, it will hold some constraints, who, how to access that data, who can access that data, kind of stuff. Okay, so this conceptual level holds then like connects to with another level called internal level or a physical level. So in this particular level, the original data has been stored in a memory. Okay, so till now, till this level, you are not giving any memory or space to store your data. Okay, so but in this physical level, you are storing your data. Okay, by using some, let's say you are storing, allocating some KBs or MBs or GBs or TBs of data here. Okay, a DB. So this is where your actual DB stores, data stores, and this is where you are telling how to store a data, like okay, in which format or which type or data types you are telling, like what data, like say, so I'm storing the name of a student, so then you have to store it in a form of varchar, like string. When you are like, when I say it's an age, you have to store in a data, sorry, integers type. Okay, now also you guys also, let's say I'm storing a student table. Now what it contains: a name, a roll number, an address, and mobile number, kind of things, right? So it will, this particular level will tell you, so these are all the things that you need to store. Okay, but when coming to this particular level offer this, okay, so here let's assume here all the table has been created with the columns. Here all your rows will be appended to that thing. Okay, here what in this particular external level people can do now, here a user can, a user can access the, like tries to get the data from the internal level. Okay, so in this particular thing, data can be used in the form of either GUI, okay, or any like a query languages. Like if someone is really if someone is a good programmer, he might write an queries and he can visualize the things over there as well. And even if he is not an coder, there will be some GUIs he can interact with that GUIs using sorry, he can interact with DB with by using that GUIs as well. So this is the overview of and how the database three-level architecture works. And now if you could observe here, you can relate it to a few things, like, so please pause the video now, think. Okay, so basically this entire DBs, the to store this much of huge data, our databases uses data structures, like complex data structures. Okay, complex data structures. So but to make is this like to make is easy to use, okay, so all these complex things has been hidden. Okay, hidden. Okay, so this particular concept is called as a data abstraction. So what does this data abstraction means? Hiding the unwanted or unnecessary or complex things behind the screens and showing whatever required to the particular user is called as a data abstraction. The best example would be ATM. So we go to ATM. Okay, so we just insert our card, we'll enter our pin, and we'll so we'll enter whatever the amount we want, and we'll take that amount, we'll come back. That's it, right? So we never thought, or we never want to know how that system is being processed after entering my pin, right? What is the processing it is going to somewhere. Okay, so I don't really don't care about all such kind of things. And what I know is that enter pin, withdraw money. So that's what I want. So here the things that are hidden from us is making that call to the server and calculating the amount that you wanted to and the mission that is running. So all these were really unwanted, unnecessary for me. I just want only money. That's what I am getting. So this is called data abstraction. Okay. The next concept is a data schema, database schema. So we really talked about this terminology earlier as well, but let me define how these things works. Okay, in a clear picture. So let's say you have a student table. So you will have attributes like a name, a roll number, address, mobile number, email, and all. So what this schema tells now, you have to store this kind of data. You have to store the data. You have to store the data in this particular format in a table. Okay, so that is called a schema. Okay, now there is another thing called instance. What is this instance? So instance in the sense, let's say, so by the end of the today, or let's say there were 100 records in my table. Okay, now I can say that what is the instance in that. If I ask you what is the instance, I will say 100. So because there were 100 records exist in my database, so I can say that instance of a particular DB is 100. So what is that instance means now? So at particular time, whatever the time you want, so how many data has like data records are being exist in our database, that is called instance. So at tomorrow, a day 2, so there were 100 more users has been added, like 100 more records has been added to your database, then your instance will become 200, right? So this is how database schema and database data instance has been defined. So now let's talk about DBMS languages. So basically DBMS languages are used to perform a read, update, a store kind of operations in a database. So there were a lot of languages exist to perform such kind of operation. So one such language is SQL. So formerly known as SQL. So it might be called as a structured query language. Okay, structured query language. And if you are really interested to learn this SQL, so which is used by most of the companies, please do check out the playlist which was taught by other faculties or instructors in this particular YouTube channel. Now let's talk about the types of DBMS languages. Okay, so types of a DBMS language. So again, these are all the very important concepts in terms of place interviews. Okay. Now, first thing is DDL, okay, data definition language. So DDL is used to specify the database schema. Okay, so it is used for creating the tables, schemas, indexes, constants, etc. Okay, so let us see what kind of operations that we can perform using DDL. Okay, first one, create. So create can be might be used for either creating the databases or tables. Okay, and next one is alter. So alter means altering the existing tables, okay, or altering the structure of the databases as well. And another one, a drop. So a drop means deleting or dropping the existing instances of a database. So when I say instances, might be tables as well. And next one is truncate. And a truncate again, it is called to delete. Like truncate is used to delete the tables in a database. Okay, and next one is a rename. So again, so rename is used to either rename the tables, okay, or database instances. We can call it as a database instances. And a last one, comment. So comment is used to comment the databases. Okay, that's it. And now a DCL. Okay, DCL. So data control language. So which is used to control the access of a particular data which were there in like controlling the access of a databases as well. Okay, so in this we do have two commands. One is grant, another one is a revoke. So grant is used to grant the permissions, revoke is used to revoke the permissions which you have given already. And next one is a DML, data manipulation language. So this data manipulation language is used for accessing as well as manipulating the data already present in the database. Okay. Now what are all the options is a read. So a read is you can read that data from a database using the select command. And next one is insert. So insert command is used to insert the data into a database. Next one, update. So updating like it is used to do update the data which is already existing in a database or table. Okay. Now a delete. A delete is used to delete the data which is present in an table. Okay. Now all this, like these are all not the separate languages, all this work comes under SQL only. Now and the last one is TCL, so transaction control language. So in this we do have two commands, one is commit, next one is a rollback. So basically we perform lot of transactions, like a transaction might be, let's say there exists a table, you are manipulating that table. Okay, you are manipulating the data which is residing in that particular table using the DML commands. Okay, so since you are changing the database which is already stored in database, so we have to commit the changes. So commit means commit will help us to preserve the changes for a longer time. Okay, now what does that rollback do? So let's say you have changed something and you have committed that. Okay, sorry, we have changed something. Okay, we haven't committed that, and those so after changing your app or whatever, your application is not performing well, so now at that time you can do simply rollback, so it will take you to previous changes. Okay, so in that way these TCS commands will help us to do it in a better way. Data model is a logical structure of DB. It describes the design of DB to reflect the entities, attributes, a relationship among the data and constraints. When I say entities, so entities might be in our tables, right? So I can clearly say that entity is a real world existing thing. It's similar to the object in an object-oriented programming language that everyone is often familiar with. And in this particular data models, there were different types. Now we'll talk about them. So there was first model is object based logical model. Again, in this logical model we do have two types. First one is ER model, which is a very important in terms of both placements. And the next one uh, will be object oriented data model. Okay, now the second thing will be record based logical model. So again, this has been divided into three things. First one is a relational model, next one is hierarchical model, and third one is a network model. And there is another type which is an physical data model. So basically here this particular model describes the database of levels like conceptual level and a view level. Okay, so even the code based thing does the same, both conceptual and view level, but the here the difference is this particular record based logical model describes the data with records of fields and the attributes. Okay, so unlike object based logical model. And when coming to physical data model, it is it describes about the data which has been stored at the lower level of the data abstraction. Okay, let's say it's a physical level. Okay, so among all these data models, the one which is very famous and very used. Okay, so this one, ER model. Okay, so apart from the this particular ER model, most of the things were not being used nowadays. So now let's talk about that ER model only. So ER model stands for entity relationship model. So earlier I said that entity, when I say entity, it might be a table, and in OOPS terminology, it is being called as an object. How can we define an real world existing object or thing? Okay, so the examples would be like a person, employee, a car, book, a pen, etc. Okay, now this ER model is used to represent the like design the database architecture using the diagrammatic picture. Okay, let's say when I say diagrammatic picture, it contains everything like tables and attributes, links to the tables and the constraints. Okay, so like whenever we see that particular model of a database, we will get an overview. Okay, what's going to be in particular database and how these particular queries are being running. Okay, everything. Okay, now we'll talk about those ER diagram and what does it contains. Okay, so basically, let's say, so components of ER diagram. So a components has been divided into three things. First one is entity. So we all know that what is an entity. In this particular entity, would you have a weak entity? So what does this a weak entity means? Let's say you have a bank account. Okay, let's say bank table. So the attributes for this particular table will be bank name and a branch IFSC code. So here this bank is a table name. We often call as an entity, and uh, these things were attributes. Okay. Now there is another entity called bank account, right? Bank account. So it also has a few attributes like account holder name, account number, and amount that is residing in that particular account, and mobile number, email ID, right? So these are all the attributes of this particular bank account. Now, can you tell me, is that particular bank account exists without a bank? So it is not possible, right? How can a bank account exist without a bank? So can I say that bank account is a purely dependent on bank? This is a dependent. So without the bank entity, we can't have we don't have that particular bank account entity. So I in that situation I can say that this is a weak entity. Now we'll talk about another component called attributes. So the first attribute is a key. So a key is an unique attribute which is used to identify the record uniquely. Let's say what is an uniquely means. So um, in India there are a lot of people. Okay, so let's approximately there will be 120 crore. Okay, let's assume. So if I consider, okay, let's assume everyone has their own Aadhaar card. Okay, so the Aadhaar card number is very unique, right? So if I say this particular Aadhaar card number, if I give that particular Aadhaar card number, I am pretty much sure that there is no duplicate exist. Means one particular for one particular Aadhaar number, there will be no two persons were linked. So in that case, I can say that a person, let's say person entity, which has an attributes like name, uh, Aadhaar number, address, a mobile number, and email. Okay, now by giving this particular other id, okay, other id, I can get this particular uniquely, that person uniquely, right? So even this email as well, so I can say that email is also very unique. So by giving this email id, by searching with this email id, I will also get an person uniquely. So this is about a key. Now let's see next key, composite attribute. So what is a composite attribute? Let's say there is a record called entity called student. For this particular student, there are some attributes like name, id in the sense roll number, an address. So can I say that this particular this particular address might have another few other attributes like pin code, state, a city, a street name. In that cases, we will be calling this as an composite attribute. This particular address is being called as a composite attribute. Okay. The third one is a multi-valued attribute. What does this multi-valued attribute means? Let's say there is a student again. Okay, not a student. Let's take employee this time. To employee. So am I guaranteed that like entity? Okay, this is entity. So employee has that mobile number attribute. Is there any guarantee that every employee has their only one particular mobile number? No, right? Nowadays, Zio, Airtel, Ideas, everyone is holding two or more mobile numbers, right? So, in that particular situation, I can say that this particular mobile number is a multi-valued attribute. Okay, multi-valued attribute. Now, the last but not least, the fourth one is a derived attribute. A derived attribute. So what does this a derived attribute means? Let's say um, a student, a entity has an attributes like name, DOB means a date of birth. Again, it's an year, okay, and age, address. So I say that okay without can I say that age is purely depend upon DB? How? DOB how? So without knowing the year of like when he born like when he came onto the earth like year, can we find out the age of that particular person? Unknown, big no, right? So if I say he born on 1999, so in that case I can say that it's a 22 now currently. So when I say if he born on 1995, then his age might be and something similar to 27 or 26, right? So in that cases I can say that this particular age is purely dependent upon DOB. So I can say that it's an derived attribute. So since age is deriving from the DOB, like date of birth. Okay, so this is about attributes component. Now we'll talk about third component called relationships. So in these relationships again we do have four types. First one is a one-to-one relationship. So what does this one-to-one relationship means? Okay, so let's say uh, every person, can I say that every person uh, will have only one passport or one Aadhaar card or one PAN card? Yes, right. There will the possibility is only one. So every person has only one passport. One passport has been can be assigned to only one person. Okay. So in that cases, I can say that it's an one-to-one relationship. Now the second one is one to a many, one to a many relationship. So what can be the things? Let's say take an customer entity. So customer has placed an order, placed an order. Now tell me, a customer can place many orders. Yes, there might be possibility. Now, is there any possibility of many orders can be placed by many one single particular customer? No. So I can say that it's an one-to-one customer. So one-to-many relationship. Now, third one, many to one. So how? Let's say I have an entity called student. So can I say that many students can study in one college, one particular college, and also one college can accommodate many students, right? That is also a possible case. Now the last one is many to many relationship. What is this a many to many relationship? So can I say that? Can I say that many students, many students can be assigned to many projects? Yes, right. And also I can say that vice versa. So many students can be assigned to many projects can be assigned to many students. Okay, so this is about the components of an ER diagram. This is what most of the times it includes. Okay, so now let's discuss another topic in a DBMS. So the topic goes name is DBMS generalization. What does this mean? So it means that let's say we can define a generalization something like this. Generalization is a process of generalization is a process of in which common attributes in an two or more, like more than one, okay, in an more than one entity can lead to creating a new entity. Okay, let's see one example. Okay, so suppose we have an two entities. Okay, one as a teacher. Okay, so the attributes of this teacher, particular teacher, will be a name and address and salary. Let's take another entity called a student. So the attributes for this particular student will be name, address, let's say marks. Here, what are the common attributes in both of these entities? So this, 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 and this. So this one, this one, this one, this one. So can this be lead to a new entity? So think. Okay. So I can say that all teachers are people, and all students are also people, right? So can I say that? So will this our teacher and a student entities will lead to having an a people entity? Okay, people easy. Okay, so the relationship is easy, and here we will be having this, and we will be having this. So I can say that every people have the a name attribute and address attribute, but on top of that, a teacher might have a salary, a student might have a marks. So when you are talking about generalization, you need to consider these things from the like bottom to the top. Okay, so teacher is a people, student is a people. So people have the attributes like a name and a address, a student have the attributes like marks, and teacher might have attributes like a salary, right? So what we have done here, we have created a new relation and reduced the repetition redundancy of an table attributes, right? So and one thing here is we are considering it top bottom to top, and from the bottom entities we are creating the new top level entity, and there is something like that whatever the new entity that has been created as of now from the by using the bottom two entities, if required, okay, if required while creating another top level entity, that new level entity has to be mingled up with these two entities as well. Okay, so on that note, let's see another tip. So DBMS a specialization. In simpler words, I can say that opposite to a generalization. Yes. So what we have done in generalization, by considering the top bottom level entities, two entities, we have created the top level entity, right? But in specialization, by considering the top level entities, we will be creating or deriving new bottom or low level entities. Let's see how. Okay, so basically every employee will have a name, a salary, employee ID. Now, can I say that? So, can we? How can we divide this into a different particular entities? Okay. So, can I say that? So, employees might be, let's say, considered a software company. Okay. So, employee might be an software developer. Employer might be an software engineer in test. So, employer might be an HR, right? So let's try to divide this particular employee top level employee entity into an few low level entities. Okay, let's see how we are doing this. So we'll have a employee entity here, and what are the common things for all the employees? A name, a salary, and an employee ID. Okay, every employee will have that, but on top of that we will be having some is a relationship. Okay, so from here we will be having a developer. So well, coming to, let's make it very simple. Okay, so the attributes for will be boolean type. Let's consider boolean type. We will give you some programming language. We will be taking just whether he knows that particular language or not. That's it. Okay, C++, Java. Okay, so Python, C sharp. Okay, kind of. Now let's consider another case. So a tester. Okay, tester. So what will be the qualities of a tester? So you might be able to write a test case like manual testing and automated testing, which were like script based testing. Okay, and integration testings as well. Okay, now when I say a cloud engineer, a SRE or something, so cloud engineer, now he must be able to know all the terminals of oops, like they oops, and he might be good at cloud like either AWS and a CI/CD pipelines and all, right? So this is how we have divided our particular employee entity into an multiple sub entities, right? So again, so this has to be started from top to bottom. Okay, top to bottom. In case of generalization, it's a bottom to top. Now we'll see another thing called DBMS aggregation. What does this mean? So aggregation is a process of in which a single like process of in which a single entity is not able to make sense in a relationship. Okay, so the relationship of two entities is being combined to another new entity. Okay, let's see. Okay, let's take an example. So basically, let's take an again IT company. So every employee works on one project. So again, project is an one entity, employees and one entity because they are independent words. Okay, so project might have a project ID, project name, and a product owner. Okay, so employees will have again employee name, employee ID, address, kind of stuff. Okay, now this is an one entity, like one particular block. Let's consider block. Okay, now can I say that for every employee there will be one manager, for every product project as well there will be manager, right? So in that case, can I say that, so if I directly write an relationship between employee and manager, we might miss an relationship between a project and employee. So can I say that now, if I draw this here, manager, managers, right? So if I write something like this, then it works, right? So manager works on this entire block. Okay, he sometimes works with he is responsible for employees and he is responsible for one project as well. So this is called aggregation. Okay, so earlier I have discussed what is a key. So key is an unique attribute. Okay, so which uniquely identifies an entire tuple or record in a database. Okay, we do have a different types of keys exist in an a DBMS. Okay, now we'll talk about them with an one example. Okay, so let's say you have an like two tables with the attributes of like this. Okay, so student table, so you have a student name and roll number, Aadhaar ID, Aadhaar number, a mail ID, address, and you do have another table called a course. Okay, so this has a course name. So usually students enroll in that particular course, right? Like DBMS, OS, mathematics, operating system, something like that. So then a course ID, then faculty name, who is teaching that particular course currently. Okay, now done. Now tell me, now tell me. So in this particular student table, what are all the unique things? Let's say, so can I say roll number is my unique? Why so? So let's say, so there were 5,000 students enrolled in one particular college. So if I say roll number, if I pick up any roll number, is there any chance of getting that a same roll number for an another student? And no, there is no chance, right? So if I give any particular roll number, that must be unique. So if I give particular roll number, he can tell me the student details. So it is an unique. And what about this other? This is an entire nation unique thing, right? So that's there will be no two persons with the same other number. So it is also an unique. So what about email? It's an universal unique, right? So now, what about name? There might be possible, right? There exist an two name. Okay, there exists an two students with the same name, right? And address as well. Okay, so let's say there were brothers and sisters. Okay, so they are from same family. Okay, they are studying in same college. So then their address and parent address and mother names would be same, right? So in that case, I am not saying that address and student names are not going to be unique. So all these attributes, okay, what are all I have seen? I said like all these were uniquely identified. All these were candidate keys. Okay, now upon, so we don't need three things, right? Three keys to identify, and I am pretty much sure that any of these three things will work for me. Okay, so in that case, since that table is an role a student related, so I can pick up a roll number, which does my task very simple manner. So I will pick up a roll number as my unique column. Then I will call this as a primary key. Okay, so among all the candidate keys available right there, okay, I will pick up one key. Okay, so to identify an entire record or row uniquely, so that particular key has been called as a primary key. Now what about other two keys that exist in an candidate keys, like other and email will be called as an alternate keys. Okay, alternate keys. Make sense? Now we'll talk about a super key. Okay, so now tell me. So I am pretty much sure that only with a roll number I can get an entire record. But now tell me, so can I get an student name? So can I get an one particular student by giving an a student name as my search key? No, right? So there might be multiple students with the same name. So if I add a roll number to that particular name, that will make my job a little bit easier. Can I say that? Yes. So in that case, I can say that by combining the student name plus a student a roll number, it will be more powerful. Okay, so this combination is being called as a super key. Even along only a student a roll number will also get my job done. It is also it might be also a super key, but no, I can't say it's a super key, but it's an candidate key, right? So I can simply say that a super key is a, okay, super key is a superset of candidate key. Okay, makes sense. So the definition of an super key will be looks like this: a super key is a set of one or more columns which uniquely identifies the entire record or row. Okay, now the last key that exists is a foreign key, which is very very important. Foreign key. Now tell me in the beginning I have said student enrolls in a particular course. So I have to store that particular course details in a student for particular student, right? So I will have an another course ID thing here. So why so? So here, by having an course ID, I can uniquely identify the entire course details, right? So it means that it will act as a primary key in a course table. So by having a reference of course ID from the student table, I can I can get an entire course details in a course table, right? So it means that it will act as an foreign key in my student table. So what is this foreign key definition? Goes something like this: a foreign keys are the a column of a table that points to the primary key of an another table. Okay, points to the primary key of an another table. So they acts as a cross reference between the two tables. Okay, so cross reference. So this particular course table, the primary key is being pointed to same as an foreign key in this particular student table. So that's all about the keys. So now let's discuss about normalization. Normalization. So what is a normalization? So basically, a normalization is a process of organizing the data in database, okay, to avoid a data redundancy and some anomalies. So what is a data redundancy? So data redundancy means simply you can call it as a duplicates. Okay. So what is anomalies? Anomalies are problems. Okay, that were arised during the uh, data insertion in a table or well like in database. Okay, so let's see. So let me write the definition of that following. Okay, a normalization is a process of organizing the data in a database to avoid data redundancy, comma, anomalies. Okay, so this particular data redundancy means storing duplicates or means a duplicate values. Okay, anomalies means you can simply call them as a problems. So hope you still might be in a confusion. Let's see what does this. Okay, so let's take an example table. Okay, where you will be having employee ID, employee name, and employee address. Sorry, employee address. This is not address. This is let's consider this is a department, like where he belongs to. Okay, where he belongs to, and the department ID. Okay, department ID. Cool. So let's assume this is our database and we do have some records in it. Okay. Let's say when I say records, it might be, let's say, employee ID 101 and name is Vamsi. Okay. So employee department is, let's say, we do have department names like Godavari. Okay. So, and department ID, let's say department ID is D101. Okay. D101. And we do have another record, let's say Reddy Krishna, he belongs to Krishna department and department ID goes something like this. Okay, now we do have another thing. So Vamsi, sorry, Vamsi, and he belongs to mm, Spider-Man's team or Avengers, whatever you may call. Okay, and also a Vamsi is like 101. This person is again belongs to another team. Let's say Krishna. Okay, he belongs to Krishna team also. Now let's see. Now let's see what are all the anomalies we might get. Okay, so first one, tell me. So let's assume here Vamsi is like 101, 101. Okay. Now there is two records associated with 101 employee ID. Now I wanted to update the address of a Vamsi. Okay, I wanted to update the address of an update the address of 101 employee. Now how many times I need to update? At two times. Now let's suppose I forgot. Okay, I forgot to update for two times. I have updated only for one time. Okay, I have updated this guy. Okay, so I have made it as a Bangalore, and still he belongs to a Mumbai. Now tell me, is this a problem? This might be a problem, right? So this kind of problems is called as an update anomalies. Okay, update anomalies. Now let's discuss about a delete anomaly. A delete. Now let's say suppose I am trying to delete the department. Okay, so like we have an Spider-Man department with the department 103 ID. We are trying to remove that entire department, like means decompose that particular uh, department. Okay, now so if I delete this particular department, this entire record will get deleted. There might be a chances. So what is happening? We are losing one person. Do you think that? Yes. So that is called a delete anomaly. Okay, now what is an insert anomaly? So let's say so this particular department ID is a primary key. Okay, this is a primary key. Now I'm a new joinee. Okay, so I joined in a company 2 days back. So still I am in an training phase only. No department is being allocated for me. Okay, now some people is trying to update my database to get an ID card for me. Okay, so now tell me, do I have department ID currently? No, because I am not assigned to any department, right? So whatever the data I have is this particular employee ID, let's say 104, and a name, let's say Sai. Okay, so I don't have department employee department and the department ID as well. So it won't take the this record, right? You record this code. Sorry, you record the it won't take this particular record. So what happens? Okay, so it won't take that record. So we lost the one particular employee name. So that kind of problem is called as an insert anomaly. Okay, insert anomaly means during the insertions, like insertion into the a DB. So delete anomalies means while deleting the data from a DB. Update means while updating the data which is present in database. Okay, now this is about normalization and anomalies. So how we are going to solve this kind of problems is called as an normalization. Okay, so we do have different types of normalizations. So those were or classifications. Okay, you might call it as a classifications as well. So first one, 1NF, 2NF. So first normal form, a second normal form, a 3NF, and BCNF. And we do have a 4NF and 5NF, but this were not necessary. Okay, not necessary. What does it mean not necessary? So whenever we achieve this BCNF for a particular table in database, then we can say that there will be no data redundancy, there will be no anomalies. Okay, so we can say that that particular table is all set. Okay, so we don't require these things. Okay, so that is the reason why in interviews also, in most of the interviews, they don't track this 4NF and 5NF topics. Okay, they will end up at BCNF. Okay, not even BCNF. Yeah, so in some cases they will ask you BCNF, otherwise they will just ask you to define this what is 1NF, 2NF and 3NF. But when I say like when they ask you to define, it's your responsibility to take an one example and then you need to explain it, because in an interviews, mostly interviewers are not interested in hearing the standard textbook definitions. They want something like more than definition, like let's say concept. Okay, what you have understood from that particular point. Okay, that is what they want. Okay, that is what they are expecting from you as well. Okay, now let's see what is 1NF. Okay, let's start with 1NF. Okay, let's say we have a table like this. uh, Student ID, student name, and student mobile number. Okay, student mobile number. So what is the data? It has a student ID is 101, 102, 103. Names are Vamsi, Reddy, Sai. Okay, so now mobile numbers are, this guy has a two mobile number. Okay, so I am writing only 5 digits. Okay, so consider in real case. Okay, so another thing, another mobile number is this, and this guy has this, and this guy has this. Okay, these are all the mobile numbers they are holding. Now tell me, so the formula of like what is the principality of 1NF is, an attribute of a table cannot hold a multiple values. Okay, it should hold only atomic values. Atomic values in the sense it has to contain only one value under one particular attribute. Let's say, so in our case, under student mobile, we are holding two values, right? So this is not the 1NF principle. So we need to convert this table into the 1NF, right? So we need to convert this table to the 1NF. So here what we can do now, we can simply flat this like entire table. So when I say flat, let's say what we can do now. Okay, so what we can do, let's say 101, 1C, 1, this one is 1, and I can make this 13425 with another new record. Okay, so same ID is same, student name is Vamsi, but mobile number is 13425. So now there is no problems in this 102 and 103. If suppose again 102 has two or three mobile numbers, let's say three mobile numbers. Okay, three mobile numbers. Okay, so now again this, with this particular student ID, we do have a, we might have a three records. Okay, in our flattened, in our 1NF converted table. Okay, so something like this. So here we will have first number, here we do have a second number, here we do have a third mobile number. Okay, so this is what first NF, first normal form. Okay, now let's talk about a second normal form. So let's first discuss the principles of second normal form. So here the principles are, first thing, a table must be in 1NF. Okay, so whatever, so whenever we are trying to convert one particular table into an 2NF, that table must be in a 1NF. Okay, it must has to satisfy that principality of 1NF. Then second thing is no non-prime attributes. So non-prime attributes in the sense non-primary key attributes, okay, is dependent on the proper subset of candidate keys table, candidate keys. Okay, let's see with one example. Okay, I'm sure by seeing these definitions you are not going to learn anything apart from mugging up those definitions. Let's see. Okay, now let's see. So we do have a table something like this. Okay, so a student ID, a student name, and student age. Okay, so student id is 11, so let's say 11 111. It's not a student name, let's consider it's an course, okay, which a student has been enrolled. Okay, so 101 student id is enrolled in, let's say, DBMS subject, and his age is 21. Now again 101 student might be enrolled in other courses as well. So what is that course? It's a OS, like operating system. So again his age is 21. So we do have another with a student without ID 120. Okay, so he is also enrolled in computer networks. His age is 22. Okay, now another guy with 120 sim, and he enrolled in an machine learning subject with age is 22. Okay, so this is the data we have in our table. Okay, now it's our job is to convert it into the 2NF. Okay, now let's say, can I say that this particular table is in 1NF? Yes. So for every attribute it is containing only one value, so that I can say that it is in 1NF. Now we need to follow the second principle of this guy. Okay, so the here tell me, what are all the candidate keys here? Candidate keys only student id, right? So the keys which are helpful us to identify the record uniquely, that is only this student id. So what we can say, what we can do, so here our primary key is, prime key is student id. Okay, primary key is a student id. Now what they are saying, so they are trying us to, every non-prime key attribute has to be dependent on primary key. That is what they are trying to say. Okay, let's say, so what we are trying, so can I say that this course is depend upon this particular student id? So if I give you particular student id, can I say all the courses that that he enrolled in particular semester? Yes, I can say that. Now tell me, if I give you particular student ID, can I say that? So can I get the age of that particular student? Yes, that might be the case. So it's your table has been simplified something like this. Okay, so let me draw here only. Okay, so what I'm trying to do now. So first I will have two different tables. One is a student age, age table, so where I will be having details of all the ages of a particular student id. Okay, let's say here this guy, triple one, student id with triple one having an age of 21. Okay, now again to triple one 21. Yes, we do have that. Now again 120 22 age, so 120 and 22 age. Now again 120 22 age. Now whenever I want age of particular student, okay, now I can simply give you the student id, you will give me the you can give me the student age. That's okay, fine. Now what about this course table? So I will leave you that course as it is, because so if we wanted to make it as a, how can we make it? So you can make it like this, but we are violating the principality of 1NF. Hope you have remembered the definition of 2NF, right? So that table must be in a 1NF, and also that has to be in an like all the 9 non-prime key attributes must be associated with the prime key attribute. So I will leave that course table, I will leave that course table as it is. Okay, something. So let's say 111, 111, 120, 120. First guy is enrolled in DBMS, then OS, then CN, then ML. Okay, so whenever I want this particular student age, I will simply make a call to this guy. Okay, done. This is what 2NF. Okay, so it's very important to know the examples. Okay, at least if you are in an interview, you have to say these kind of things. Okay, so not even like simply drawing all the stuff. Even let's assume you can say something like this. Let's assume, sir, we have one table with the attributes like student id, student name, and the student age. So here the principles of second 2NF is the table has to must be in 1NF, and it all the prime non-prime key attributes must be dependent on the primary key. then you can divide those things into a multiple tables. That's it. Okay. Now we'll talk about 3NF. 3NF. So what is this a 3NF means? Let's say, so I can say that it has to be in table must be in 2NF. Okay, table must be in 2NF. That is for sure. Now apart from that, so there will like let's say transitive functional dependency of a non-prime attribute on any super key should be removed. Okay, so yep, it doesn't make sense to you. I will take one example and we'll see what it is actually. Okay, let's say we have a table of employee this time. Let's change the table this time. Okay, let's say employee. So employee ID, employee name, and employee address. Now let's consider address. Okay, so pin code. Okay, so pin code or zip code, whatever you might call. Okay, and then I am storing the state, then employee city, then employee district. Okay, so it has some data. Let's assume we have all the data. Now what I'm trying to say now, so this, if I give employee ID, I can get this entire row uniquely. Is there any key, something like that? No. So here candidate key and primary key is employee ID. Employee ID. Now, is there any possibility of decomposing this table again? So think. Yes, I can say one thing. So now let's forget this entire table. Now let's assume we have this only table. You have this table. Now can I say that? This, if I give this entire pin code or zip code, whatever it might be, so can I get the entire row in this particular table? Yes, right. And that pin code and zip code, pin code or zip code is very unique. Okay, it must not be given to another state, like another districts or another places or another legislatives, right? So what I'm trying to say, so I will decompose that entire table into two tables. So I will have employee ID, employee name, and employee pin code. Okay, I will have something like this. Now I will make this pin code connected to another table called address table, where I will be storing all the pin codes. Okay, let's say I will have a pin code, then a state, then a city, then district. Okay, now whenever, so I will give all the pin codes here, particular employee. Now whenever I search with this pin code, I will get a entire state and city and district details. That works. Right. So this is about the 3NF. Now we'll talk about the BCNF. Okay, now we'll talk about the BCNF. So the full form for BCNF was voice a code a normal form. Okay, voice code normal form. So again, the conditions like our principles of this particular will be, so it has to be in a 3NF for sure. The table must be in 3NF. And a second thing, so like I can say that BCNF is a little stricter than a 3NF. Okay, so a table complies with BCNF if it is in 3NF, and for every functional dependency. Okay, let's say X to Y. X should be super key of a table. What does it mean? Let's say, suppose, let's take one example. There is a company where employees works in multiple departments. Okay, employees works in multiple departments. Let's see. So uh, employee ID, employee nationality, employee department, and department ID, department ID, and a number of people in department, particular department. Okay, now we'll see. So employee ID is 101, and employee nationality is Indian here. Department he works for Godavari. Department ID, let's say 101, and in particular Godavari there were 250 people were working, let's suppose. Okay, and you do have so again this 101 guy, so 1001 guy also works in another department. Let's say again he is an Indian, so he's another department is Krishna, department ID is 102, and in that particular department let's say 100 people are there, and there is a guy with 100. Again he works for two different departments, and his nationality is American. Again, he works in both Godavari, Krishna, 101, 102, 250, 100. So this is the table that we have. Okay. Now let's try to identify. Okay. So let's try to identify. So can I say that? Can I say this entire employee functionality is dependent on this employee nationality is dependent on this employee ID? One thing, yes. Now I can say that employee ID gives you employee nationality. Now, what is the other case? So, can I say that? Can I say that employee like these things? Department ID and number of members in a particular department is dependent upon the this particular department. Yes, employee department. Yes, so I can say that employee department is equal to employee department ID and a number of employees. Okay, now how we are going to take this into the BCNF? Okay, so we can break this entire table into three tables. Okay, let's say how. So first table, let's say nationality table, nationality a table. So in that I do store employee ID and employee nationality. Okay, so 001 is an Indian, and this guy 1002 is an American. That's it for this particular table. Now I will have another table. Okay, so where department table. Okay, department table. Let's say we'll have department ID, department people, like number of employees. Okay, so first department we do have Godavari, and ID is 1001, and number of people this. And then we do have a Krishna, and it is a 102, and we do have 100 employees in that. Okay, that's it. Now we'll have another a table which is currently mapping to that particular both tables, right? Let's say so now I will, in this particular table, I will have only the primary things. Okay, primary case, primary attributes. Let's say what is the primary attribute in a table one? It's an employee ID. Now what is the primary attribute in a second table? It's an employee department. So now I can say that 101 belongs to Godavari. Again 101 also belongs to Krishna, and 102 belongs to Godavari, and oh, this guy belongs to Krishna. Done. So whenever I need entire department details, I will go to Krishna. I will get that. Whenever I need an nationality of a particular employee, I will go to nationality table and I will get the nationality. Okay. So that's all about normalization. Okay, so I highly recommend you to think on your own. Okay, like try to frame. Okay, take a couple of examples and try to divide those things, what kind of problems that you are going to get. Okay, now let's talk about transaction management in an DBMS. So what is what is that transaction management in DBMS? What is a transaction? What is a transaction? It can I say that a transaction is a set of logical operations. A transaction is a set of logical operations. I know you might be in a little bit confused, but let's see one example. Okay, so let's say you are sending some amount. Okay, you are transferring some amount from your bank account to your friend bank account. Okay, so now tell me what are all the operations that are been coming in this process, like right from the sending to uh, like receiving in your friend account. Let's say, can I say that first, whatever. So you need to read what is the amount that currently is being in your account. Let's say R is for read, W is for write. First, you need to extract the amount which is present in your account. Then, I'm assuming that your amount is being in this year. Okay, your current account, current amount. Okay. Now, let's say in okay. So in your current bank account, you have 1,000 rupees. Okay. Now you are sending 500 to your a friend. Okay. Let's say. So what you need to do? You need to minus a 500 from this 1,000, right? So 500. Now what you need to do? You need to write this whatever the amount. Let's say 1,000 minus 500. It's a 500. You need to write that amount to your bank, right? So write A. So now successfully. So till now your job is done. Okay, your job is done. Your job is done. Now what has to happen? So basically, after the amount has been detected from your account, it has to process that amount to your a friend account. Let's say. So again, so I will be getting this money from these two, your friend, and being it is being stored in B. Now, whatever the amount I am sending, it has to update that data in your friend data, like friend account, right? So B plus 500. Done. Now I need to write this data to my account. That's it. So can I say that what these are all the transaction that has been involved in this particular entire transaction, right? All the operations that are being involved in this entire transaction, right? So let's simplify this. Like let's give some overview what we have done. So first we have read your current account, right? And detected amount from your account, and we have updated the amount in your current in your current account, right? Then we have initiated amount to your friend, and we rate the amount of your friend, and we have updated the amount present in his bank. Then we have committed that changes, like whatever the amount that has been updated, we will be updating that in database as well. Okay, so these are all the transaction operations. Now let's say what happens, you might have a question like a transaction failures in between operation. Okay, you might have this question, right? So let's see what happens. So let's suppose you are using some Android application, or you are using some online application to send money to your bank. Okay, so like to your friend. Now let's say you are at sender and you are at friend at the receiver state. Now you have initiated your transaction. Okay. So from your bank, it has to go to receiver. Now amount is got detected from my account, but it is failed to update it to my friend, like failed to send that amount, whatever that is being detected from my account, to my friend. So what happens? So like in general, everyone must have used applications, right? So it will say your money will get back to you, get back to your account within 1 hour, like 1 hour or 2 hours, right? So it has to be. Now let's say this is the failure case, right? This is the failure case. If it is has been a success case, like this, so detected and success success. So can I say that whatever the amount of money that has been detected from my bank will get reflected in my friend's bank? Yes, can I say that? Now what is being happening? What is being happening? So can I say that if transaction is got failed, okay, transaction failed, I am roll back my changes to the, okay, previous changes, like before initiating that particular transaction. Now if like success case, right? So I'm committing changes at both ends. Okay, so whenever that particular transaction, like all operations in a particular transaction are good, then I will commit my changes at the both ends, at receiver end and server, like sender end. So if something went wrong, okay, and a transaction got failed, then what I will do, immediately I will roll back my changes to the previous changes, okay, whatever the state has been there before that, before initiating that transaction. Okay, I hope you had some good knowledge on these transactions. Now we'll talk about another important question on like transactions in an interview. So asset properties. Asset properties. So what is asset properties? So A stands for atomicity. C stands for consistency. I stands for isolation. D stands for durability. We'll talk about them each. Okay, we'll talk about them each. So what is it? Let's discuss, start from this atomicity. So what is atomicity? So let's say you have an account A and account B. Okay. In account A, you have 500 rupees, and in account B, you have 1000 rupees. Now, what you are doing, you are transferring 100 rupees to account B. Okay, this here. So means, so we will detect your money, okay, and it has to update here. So it's in success case, right? So now let's suppose it got failed here. Okay, suppose it got failed here, means amount got detected here and changes were not updated here, like money didn't receive that particular whatever whom you have sent. Okay, now in that case what you need to do, so you need to become to previous state, right? So roll back. So what does this atomicity says now? Either 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 your transaction should be successful. If it is successful, you need to commit, okay, what we have discussed earlier. If it is failure, you have to roll back to previous changes. Okay, so you should not be in a middle case, okay, where let's say where money got detected from you, okay, and money didn't updated in your friend's account. Okay, you should not be in that particular state, right? So who wants to be like that, right? No one. So either it has to update currently or it has to not to update everything. Okay, so that is what the principle of atomicity. Now we'll talk about consistency. Now let's say again you have an account, okay, account A, okay, there were two accounts, account B and account C. Okay, you have 1,000 rupees in your bank. Okay, you are trying to send 1,000 rupees to here, 1,000 rupees to here, no sorry, 100 rupees, sorry, 100 rupees to here and here. Now you have initiated a transaction like concurrently, both are running concurrently. Okay, concurrently means both are running at the same time. Now tell me, so it has initiated transaction, so B is assuming that, so after withdrawing that particular money, like money got detected from the A's account, then it should update, then it will update as 9. Again C will also do that same, right? So because while whatever the like before, while initiating this particular transaction, account A has 1,000 rupees, so it feels that I am the only one who is doing this particular transaction, then it will update this 1,000 to 900. Hope you got it. Now tell me, is this the right way to do so? No. Okay, so in this particular case we can say that this is an inconsistent. Okay, so actually our database has to update 800 but we have 900. So in real time we enjoy the most, but that should not be the case while designing the software. Like at least as a software developer, if I do like that, entire like a bank will come to my company and will they screw you us, right? So that should not be the case. Now, what is isolation? So what is the solution? This is the solution for this consistency. Okay, let's say, so it says that at every time, okay, whatever the time, so only one transaction has to be executed at a time. Okay, so we have seen some problem with while here, right? So here we have initiated two transactions, so we have seen some inconsistency problems. So for that we are saying that solution might be isolation. So it means that, so at whatever the time you have to initiate only one single transaction at a time. Okay, like you can say that single transaction at a time. Now what is the last one? A durability. So we do perform lot of transactions, right? We do perform lot of transactions on our banks. So at the end of the day, whatever transactions I've made, all those things will get reflected on my bank account, right? Bank balance, right? So whatever. So let's say I have sent 1,000, then I have received 1,000, then I have again sent 2,000, I have received 5,000. So whatever happens, like my bank account balance has to be reflected and it has to be preserved for longer. Okay, so whatever changes or transactions I do, those reflected changes, reflected things has to be preserved for forever. Okay, preserved forever. Great. Hope you got guys had an good understanding of AdSeed property. It's very important to understand. Okay, so if you have not understood, please try to have a look over again. Okay, now we'll see the states of an transactions. States of transactions. So transactions. Okay, so what is a transaction states? Okay, so first, so whenever you start an transaction, it has to be in activate. Okay, now let's say, So we have started a transaction. Okay, due to some reasons it got failed. Okay, then what you will say? What must be go to failure case, failure state. Okay, failure state. Now there is no problems. You have performed enough read and write operations. Okay, then it has to be committed. That then it has to be committed. Now, okay, let's say, so after committing your changes, okay, so like amount has been detected from your bank, okay, but your friend didn't receive that amount, then it might be failure case. So here again it might be a failure. Now, so what is the other case? So after committing, let's suppose, okay, let's so sorry, it's partially committed. So let's suppose your transaction is successful. Okay, your friend also got his money, like got your money in his bank account. Then we can commit. We can say commit. You can say commit. Now, so if it is fails, we need to roll back to our previous changes, right? So after roll back, we do abort. Okay, if we do abort, it will get rolled back. Okay, so whatever happens at the end of the day, we'll terminate our, like will finish or terminate, right, our transaction. That's it. So these are all the states of an one particular transaction. Now let's talk about a deadlock in DBMS. Deadlock. So again, deadlock is been a very important topic, and which is asked in like every product based companies, if I say. And also the same context sorry, that the same topic is being reflected in OS as well, operating system. Okay, now let's see what is this a deadlock means. So a deadlock is a condition. Okay, a deadlock is a condition where in uh, two or more processors are waiting for each other to execute. Okay, but none of the tasks are willing to share their resources. Let's say you have a process one, okay, which is doing some task. Okay, and it is using a resource called R1. Okay, resource 1. Okay, now, so again there is a process called 2, process 2, and it is using our resource 2. Okay, resource 2. Now here the problem is, so to complete process 1, okay, to finish the process 1 task, it need R2. Okay, it need R2, but the problem here is R2 is currently used by R1, sorry, P1, P2, sorry, P2. Okay, but to come the problem for to complete the P2 task, P2 requires R1, which is being currently held by P1. So P1 is not interested to lose his R2. Okay, it needs that, and also it is waiting for R1 as well, and P1 is not interested in giving R1, and it is waiting for R2. So can I say that it is being full pack like traffic jam? Okay, so this kind of situation is being called as a deadlock. Okay, so hope like you got an enough idea. Okay, let's say I will put these points here. Okay, so the point one is P1 holds R1 and waiting for R2. Okay, P2 holds R2 waiting for R1. Okay, so this is not going to happen, right? Because either of the processors are not giving up. Okay, so to say like when these kind of situations may occur, so we have an conditions which were being called as a Kaufman conditions. There were 4 conditions. Okay, if like 4 conditions are get satisfied, then we can say that a deadlock may occur. Okay, so the first one is mutual exclusion. mutual exclusion. What does this mean? Let's say, so there are no one or more than one resource are not being shareable. Okay, so let's say if there is a resource which has to be allocated to only one person, okay, so which is not shareable, okay, then we can say that it might get into an uh, deadlock condition, just because it can serve only one process at a time, right? Okay, one or more resources are not shareable. This is the first one. Now what is the second one? The second one is hold and wait. Obviously we know that, right? So it is holding something and it is waiting for something, right? And other one is also holding something and waiting for something. Okay, so in that cases we can say that it might enter into deadlock condition. Now what is the third one? So the third one is a no preemption or non-preemption kind of stuff. Okay, so what is this a no preemption? Let's say there is one process which is being executing his task, like doing his task. Now you wanted to do your tasks. Okay, so currently P1 is doing his task, and you even at the same time you have some urgent and you wanted to do your task as well. So in that cases you have to wait. You can't drag that P1. You can't say like, hey, I have to go, I have to do have some urgent work. You can't say like that. You have to wait till P1 completes its task. Okay, there is no midway. It has to complete, and then only you can go and do your task. Okay, so in that situations I can say that it might enter in deadlock situation. Now last but not least, a circular wait. So as you can see in our particular diagram, so yeah, here this is in circular way, right? So it is P1 is waiting for R holding R1, and RP2, like process 1, process 2 is waiting for P R1 and it is holding R2, and R2 is like P1 is waiting for R2. So this is a circular condition. So no one is gonna execute it. Okay, it will be going in infinite loop. That, so in that situation as well, I can say that it might enter into a deadlock situation. Now think, what are all the handling, like deadlock handling conditions, deadlock handling methods? What are they? So first one, so the one which I love the most and nowadays which is being very used. Okay, so just avoid, like whatever, like ignore the problem. You can simply say ignore the problem. So problem in the sense deadlock. Arey yaar. So what are you saying? So you got some deadlock issue and you are saying just ignore that. Like how this is going to be and one handling condition? No, I can say that this is not a condition, but why I am saying this? Okay, let's see. Let's understand. So basically, let's consider. Let's consider. Okay, so you got a deadlock situation and your system got hanged. Okay, your system got hanged. So I can say that to resolve that particular deadlock issue, like deadlock situation, it will take 10 minutes of time. Okay, I can say that 10 minutes of time, and even it will be a little more costlier as well. Okay, now so how much of time do you require to reboot your system? Can I say not more than 2 minutes or 3 minutes? So which one do you prefer now as a developer? So I will prefer this one, right? Which is time. So it finishes my task within some little time. Okay, so like 2 or 3 minutes, so that I can continue with my work. So that is why ignore the problem. So this is not a bad solution. This is being used in Windows and Unix systems. Okay, this is not a bad solution. Now the second one is deadlock avoidance. So what does it mean? What does it mean? So let's get all the requests, okay, from like whatever you want to process. Okay. Now, if there any chance, by any chance, if you get an deadlock occurrence, okay, so if you have observed that there is one deadlock situation has been occurred, now stop there and check all the processes. Okay, so whatever the condition, like whatever the process that caused that our deadlock situation, then go take that out. Okay, take that out, just leave it, that's it. Okay, just leave it. So what I'm trying to say now, so let's assume this is your like system or CPU. Okay, so collect all the requesters. Okay, now if any deadlock situation has been arrived, okay, then stop stop and take each request at a time and check for deadlock condition. Okay, so if and by chance if you found any request that is causing deadlock, okay, just avoid that particular request, avoid that particular list request, then do continue with your uh, processes, other processes. Okay, so there is one famous algorithm which does all these tasks, that is called a banker's algorithm. Now let's move on to next handling condition. Next handling condition, so that is deadlock prevention. No, before going to deadlock prevention, let's discuss deadlock detection and recovery. Okay, so it is again same, collect all the requests. Okay, process everything, and if you found any if you found any particular request caused a deadlock, okay, then take out that particular request. Okay, then try to recover that, like whatever the request that caused deadlock, try to resolve that. Okay, then that works. Okay, so now last one, a deadlock prevention. Deadlock prevention, what does it mean? Let's say, so now again we'll come back to our Kaufman conditions. Okay, okay, we'll try to have one solution per at least like for every Kaufman condition. Okay, first one is mutual exclusion. So like what is the problem that we have got? So we got that we don't have any shareable things. Every resource can share only one particular process. So now what we can suggest, so we can suggest to make processors as sorry, make resources as shareable. That's it, which can serve one or more processes at a time. Okay, then that will help resolve our issue. Now the next one is hold and await. Now, so it is like, what is this problem is causing? Like, let's say if we saw that in root cause, so it is holding something and it is waiting for something, which means before it started, it don't know what exactly it required. If it is that if that particular request knows what all the resources it required, it should have asked earlier, right? So before starting that particular process, it should have asked everything, and after getting everything, if it started, then it won't enter into that particular deadlock situation, right? So what I'm suggesting now, before starting process request, collect all required resources and then enter into execution. That's it. Then there is no waiting, right? Then there is no waiting. Okay, so this might be one kind of solution. Now what is that next one? So next one is preemption. What is this preemption? So let's say we have went and P1. Okay, first P1. Now it identified that it requires some kind of resource. Okay, so whenever it says yes, I need request to complete this task, then take out that process outside and continue with next processes. That's as simple as that, right? So then collect all the required resources, then again process it after the next one. It makes our job easier, right? Now, last one, circular wait. So this is little interesting. Let's say we have a P1 and it is holding R1. Okay, and it is waiting for R2, which is being allocated to P2. Okay, now P2 is waiting for R3, which is being again you assigned to P3. Now P3 is waiting for R1. Okay, so now can I say if I able to cancel this particular call, if I make, okay, now can I say that I'm not going to enter in a circular wait? Yes. Now what is that condition? Okay, what is that condition? So if you observe that thing slightly, that is done because, let's say, if I have a condition, okay, so if a resource is, if your resource is less than your process request, let's say here process request is P3 and the request, like resource that you are requesting for is R1, which is a smaller than, right? So it means that R1 is currently holding by someone. Okay, so whenever such kind of request has been made by any process, just say I don't give. Okay, just say I don't give. So in that cases, we won't end up in a circular wait, right? So that is the case. So hopefully you have learned a lot from this entire tutorial. If you are visiting channel for the first time, don't forget to subscribe. If you like the content, please hit that like button up. If you have any questions or video requests that you would like to hear from Scalar, please let us know in the comment section. We'll catch up in the next video.
Hey folks, I welcome you all to Scalar Academy's YouTube channel. And this is the first video in the SQL tutorial series. Now, before I start off with today's session, I'd request you folks to subscribe to our channel and also hit the bell icon so that you do not miss out on the notifications. So, on that note, in this session, we'll start by understanding what exactly is SQL, and then we will go ahead and create our first database and table. So before we do all of that, let's understand what is SQL. So simply put, SQL stands for Structured Query Language. Well, that is just the extension of this term SQL. But what can you actually do with SQL? Well, with the help of SQL, you can communicate with databases. Okay, that's fine, but what is a database? Well, whenever you'd have to store data, and if you'd have to store that data in an organized form, you will need a database. So simply put, with the help of a database, you can store your data in an organized form. So let's understand the example of database and tables with a simple example. So I have got this T set with me. I hope you guys can see this properly. So in this T set, what you can consider is this entire thing to be your database. And in this entire thing, what you're doing is you are organizing your data in a proper structured way. So this entire set you can consider to be a database, and these cups which are present inside it, you can consider to be your tables. And if I'd have to simplify it, what I can say is, let's say if you are studying in a college, then your entire college or all of the information about your college would be stored in your database. And in your college database, you can have multiple tables. So you can have one table for student information, another table for the faculty information, another table for the department information. And this is how you store data in tables, and those tables are properly organized in your database. But there's a catch over here. if you'd have to work with the data which is present in these tables or which is present in this database, then you'd need this language called as SQL. Because without the help of SQL, you cannot extract data from these tables. And this is where, my friends, the knowledge of SQL comes in. So with the help of SQL, you can properly either maybe insert data into this table, extract data from this table, or even manipulate the tables which are present inside this. So now that we understand what exactly is SQL, let's go ahead and create our first database and our first table using MySQL Server. So I've opened up MySQL Workbench over here. Now, before I go ahead and create the database, let's again understand what is MySQL and also what is MySQL Workbench. So MySQL is a database management system. So we know what exactly is a database. And again, to work with these databases, what I need is a database management system. And that is exactly what a DBMS means. And we have different types of DBMS. So we've got MySQL, we've got Microsoft SQL Server, we've got the Oracle SQL. And out of these, right now, the DBMS which we are using is MySQL. And if I do want to use the GUI tool of this, that is what is known as MySQL Workbench. So as you can read over here, MySQL Workbench is the official graphical user interface tool for MySQL. And now let me go ahead and open my local instance. So this is what you see over here, local instance, and I'd have to type in my password. So user by default would be root, and then whatever password you had given, just go ahead and type in that. And I have opened up my window. So over here, let me go ahead and create my first database. So to create a database, this would be the syntax. Let me increase the size of it so that you can properly see it. So here I'll write down create a database. And after this, I would have to give in the name of this database. So this create database, what you see are the keywords. So create a database, this is the syntax which you would have to use. After this, just give in the name of the database. Let's say I give in the name of this database as college. After this, let me just put in a semicolon and let me select all of this, and this thunder symbol which you see, just click on that. Now, when you click on that, here you would see that create database college, and here you would see in response, one row has been affected. This would basically mean that I have successfully created my database called as college. Now, after I've created this database, if I have to go ahead and create some tables in this database, I would have to use this database. So for this, I will write down use and then give in the name of the database. So the name of the database is college. So I'll just write down use college. Again, I will hit on this symbol. Again, you will see that use college response 0 rows has been affected. Again, this would basically mean that I have successfully selected this particular database. Now that I have selected the database, this is my opportunity to create a table inside this database. So inside this college database, I would want to create a table called as student. And to create the student table, this would be the syntax. So I shall write down create table. So by default, this is what you would have to write, create table. And this is the syntax to create a table in your SQL Server table or SQL Server database. So I'll write down create table, and then I'll go ahead and give in a name to this. So I'll just write down student. So this would be the name of my table. After this, I will give in these round braces, and inside these round braces, what I want to do is I will give in the column names and also the type of the column name. So first, well, if you're a student at a college, you will have a student ID. So for that student ID, I'll just represent that as SID, and then I will give this a data type. So let's say the data type for this is int. Then going ahead, I would need the first name and the last name of this student. So here I'll just have S first name, And the type of this would be variable, character, or var char. And over here, let me just give in. So let's say the first name, the maximum length of the first name could be 25 characters. Then after this, the student would also have a last name. And if this student has a last name, I would create a new column for this. And I shall call that column as, let me just write down last name over here. Again, I will give this a data type. So for this, again, the data type would be varchar. Again, the length of this, I will set it to be equal to 25. So here 25 basically means that the length of the first name and the last name could be anywhere between 0 to 25 but cannot exceed 25 characters. And now, so I've created columns for the student ID, student name, the student last name. I would also need another column for the student marks. So here I'll write down S marks. Again, let me put it to be integer. So this is also set over here. Now I have given over here 4 columns, and also since everything is set, I will end this command with a semicolon. So what I've basically done over here is I've created a table called as student, and the student column or the student table has 4 columns. So the 4 column as student ID, and the data type of student ID is integer. Then we have first name, and this is a variable length character, which would basically mean you can give strings over here. And over here again I have last name, where again you'll give a string, and then you have the marks where it is of integer type, and you end this entire thing with a semicolon. Now let me select this entire thing and let me hit on this. And here, if you look at this, you will see create table student 0 rows affected. This again would mean that I was successfully able to create this table called as student. Now let me delete this entire thing, and if I would want to see the table, what is present in this table or what records are present in this table, I have a command called as select, or I have the statement called as select. So here I shall write down select star from, and I would have to give in the table name. So the table name is student. So select star from student would mean that I am selecting everything or all of the records and all of the columns which are present in the student table. So let me select this, let me hit over here, and as you see, I was successfully able to create this student table which had all of these columns. So here I've got the SID, which is the student ID, then I've got the first name, the last name, and S marks. So folks, this is how we can create a database and a table using SQL. So folks, this would be the end of this video. In the next video, we'll see how to insert data items or records into a table. Now, before I end the session, again, I'd request you folks, if you find this session to be informative, do not forget to hit the like button and also to subscribe to our YouTube channel. So thank you, and let's meet in the next one. Hey folks, I welcome you all to Scalar Academy's YouTube channel. And this is the video number 2 in the SQL tutorial series. In the first video, we understood what exactly is SQL. And after that, we went ahead and created our first database and our first table. And in the second video, we'll see how to insert data into our SQL table. So we'll not at all waste time and open MySQL and go ahead and insert records into the table. So I've opened up MySQL Workbench over here. Let me go ahead and connect to my local instance. And over here, again, I would have to give in my password. And I have opened up MySQL Workbench. And over here in the first tutorial or in the first video, if you remember, we had created a table called as student. And that student table was part of the college database. So my first task would be to use the database. So for that purpose, I'd have to write down use database. Let me also just go ahead and increase the size of the text so that you can see this properly. So here I shall write down use college and let me execute this. So we have successfully executed this. Now we have opened our desired database. So the name of the database is college, and in this college database we had created a table called as student. Now let me also go ahead and open that table, or maybe just select all of the records which are currently there in that. So for that we had used something called as select star from student. So what this basically means is I have a table called as student, and from the student table I am selecting all of the columns and all of the records, and that is what the star means over here. Let me again hit on this thunder symbol, and as you see over here, these are the columns present. So I have this column called as SID, then I have another column called as S first name. After that, I have a column called as S last name, and then going ahead, I have a column called as S marks. But you see that this entire table is empty because we have not yet inserted any data items into this table. So this is what this entire video is about, and in this video we will see how to insert records. So let me just go ahead and do that. Let me decrease the size of this. So here, let me just remove this out, and let me see if I can track this down properly. Seems like I cannot do that. So instead what I'll do is I'll just write down the command to insert data items. So what I'll do is I will write down insert into. So here you'd have to properly remember the syntax. Insert into are the keywords. This is what you'll give. After this, you will give in the name of the table. And what is the name of the table? The name of the table is student. So you shall basically write insert into student. Then you will have to give in another keyword, which is values. After that, you have to give in 2 round braces, and inside these you can give in the values. So the first value is student ID. So let's say the first student ID is 101. Then I would have to give in the first name of the student. So let's say the first name of the student, and also if you remember the first video properly, you would know that the first name, last name are basically var-char type columns. And over here I can give in string data type, and whenever I'd have to give in a string, I will enclose that in double quotes over here. So first name, so let's say the name of the first student is, I will write down Annie, and I would have to give in the last name as well. So let's say the last name of this person is Cleopatra. So student ID is 101, first name is Annie, last name is Cleopatra, and I'd have to give in marks as well. So let's just say Annie Cleopatra has scored around 87 marks. Now I will put in a semicolon over here, and I'll select this entire thing, and I will hit this thunder symbol. And we have successfully inserted this into our table. Now just to verify this, what I'll do is I'll delete this entire thing, and I shall again write down select star from student. And now if I hit this thunder symbol, you will see that I have inserted these values. So we've inserted the first student, or the details of the first student. So SID is 101, first name is Annie, last name is Cleopatra, and this person has scored 87 marks. Now similarly, if I would want to insert the details of the second student, I'll do the same thing. So let me just write down insert into, then I need to give in the name of the table, which would basically be student, and I will give in the keyword values. Again, given this round braces over here, now let's say the next student ID is 102. Now the name of this person is, let me just write down John, and the last name would be Smith. So let me just write this down properly. So this person's entire name is John Smith, and John Smith has scored, let's say, 56 marks. And let me end this syntax with a semicolon. Now I'll select this entire thing, I'll click on this, and we have again inserted this. Now just to verify, I'll delete this. Again, I will use the select statement. So I'll write down select star from, And I would have to give in the name of the table again. So the name of the table is student. Let me write down student over here. Let me end this with a semicolon and I'll execute this. So right now you would see that I have also inserted the second record where the student ID is 102, student first name is John, student last name is Smith, and this person has got 56 marks. So folks, this is pretty much it for this video where we have learned how to insert records into a table. So on that note, I will sign off, and before we actually end this video, I request you folks that if you found this session insightful, do like the video and also subscribe to our channel. So thank you very much, and let's meet in the next one. Hey folks, I welcome you all to Scalar Academy's YouTube channel. And this is the third video in the SQL tutorial series. And in the previous two videos, we learned how to create a table and also how to insert records into our table. And in this particular session, we will see how to work with the where clause and filter out records on the basis of this where clause. So before I actually head to the coding, I'd request you guys to like this video and also subscribe to our channel. So on that note, let me open up MySQL Workbench. So I've opened up MySQL Workbench over here. Let me go ahead and select my local instance and also put in the password. So the password, I'm typing it over here. Let me hit enter, and we have successfully opened up our local instance. And I would again open up the student table which we had created in the previous video. Now, if you would want to know how to actually create a table and insert records into a table, you can follow the first two videos and you will find the link for these two videos in the description below. So if you don't really know how to create a table and also how to insert records, I request you guys to watch those videos first and come back over here. Now, let me go ahead and open up my student table. And before that, I'd actually have to select my database. So the student table I had created in a database called as college. So here, now before I write this, let me also increase the size of this so that you can see this properly. So here I shall write down use, and then I shall give in the database name. So the name of the database is college. After this, I'll just give in a semicolon. Let me select this and select this thunder symbol, and we have executed this. Now that we have selected our database, so in this college database, I have a table called as student. Let me go ahead and open up all of the records which are present over there. So here I shall write select star from, then I need to give in the name of the table. So the name of the table is student. Now let me select this again, and as you see, I have opened up the student table. And in the student table, I've got all of these columns: student ID, first name, last name, marks, and gender. Now, in this video, we are supposed to work with the where clause, and with the help of where clause, we can filter out records on the basis of a condition. So let's say from this entire table, I would want to extract only those records where the gender is equal to male. Let me go ahead and write down the command for that. So I'll start off by writing select star from, and after this I need to give in the table name, which would be equal to student. So till here, what we're doing is we're just using the select query. After this, we will give in the where clause. So here I shall write down where, and as you see, even the color of this where clause has turned to blue because this is a keyword. So I'm writing select star from student where. After this, I need to give in the condition, and the condition is s underscore gender. This needs to be equal to male. So from this entire table, what I'm doing is I'm extracting only those records where the gender of the student is equal to male. Let me select this entire thing. Let me press this. And now if you see, I have extracted only those records where the gender is male. Similarly, let's say from this entire table, I'd want to extract only those records where student ID is equal to or greater than 103. So this where you see, so this is actually a numerical entity and the ID start from 101 go up till 105. What I'd want is I'd want to extract all of those students whose student ID is equal to or greater than 103. So here I shall write select, let me write this properly. So select star from student, and after this I again given the where clause, and after the where clause I given the condition. So the condition needs to be SID is equal to or greater than 103. Let me actually change this and make this greater than or equal to 103. Let me select this entire thing and let me run this. Now, as you see, the SID over here, it starts from 103 and goes up till 106. Now, let's say if I want the student IDs from 104 or basically upwards of 103, then I shall remove this equal to symbol from over here. Now, if I run this, you shall see that I've extracted only those records where the student ID is greater than 103, and that is why I have 104, 105 and 106. Now, after this, let's say if I'd want to extract records on the basis of multiple conditions. So here I can use the AND operator as well as the OR operator. With the help of AND operator, I'll be basically extracting those records where both of the conditions are satisfied. So for that, let me show you the entire table for you guys again. So I shall again write down select star from student. Now from this, what I'd want to do is I'd want to extract those students where the gender is male and marks scored by the student is less than 50. So if we see from this entire table, we see that there is only one particular record where the gender is male and mark scored is less than 50, which is basically this student, and the name of the student is Matt Cooper. So for this, what I want to do is I'll again start off with the same thing. So we shall have select star from student. After this, I shall give in the where clause and I will follow it up by giving both the conditions. So let me give in the first condition. Select star from student where the first condition needs to be gender. So I shall write S gender is equal to, let me write down male over here. After this, I shall integrate it or combine it with the second condition using the AND operator. So this what you see is known as the AND operator, and with the help of this I can combine two conditions together. Select star from student where S gender is equal to male and the second condition needs to be S marks. Let me write this properly. So S marks needs to be less than 50. Now I shall select this entire thing and I shall execute this. So as you see over here, there is only one student and the student is Matt Cooper, and as you see, Matt Cooper, his gender is male and his marks are less than 32. Now after this, I would go ahead and show you the entire table again. So let me write down select star from student, and these are all of the records over here. Now again, let me show you another command with the help of the AND operator. So here, now let's say I'd want all of those records where the gender is female and marks are greater than 50. So let me also write a command for that. So here I shall write select star from student where after this I need to write down and to give the first condition, and this time the condition would be S gender is equal to female. I'll follow it up with the AND operator and then given the second condition. So the second condition is S marks greater than 50. Now let me execute this. I'd have to write from over here select star from student. Now let me execute this, and as you see again, there is only one student and the name of the student is Annie Cleopatra, whose gender is female and who has scored 87 marks. Now we'll go ahead and work with the OR operator. Now before I do that, let me again show you the entire table. So I shall again write down select star from student. I'll execute this, and from this, let's say I want all of those records where Either the student ID has to be less than 104 or the marks of the students are greater than 50. So what I'm doing is I'm basically giving in two conditions over here. The first condition is the SID needs to be less than 104 and the marks needs to be greater than 50. So by that condition, seems like we'll be extracting all of that. So what I'll do is, since I want both the cases, so I shall maybe put in the gender condition. So either what I'll do is the SID has to be less than 104 and maybe I'll put the gender as equal to female. Let me just write that down. So select star from, I shall write select star from student, where the first condition needs to be S underscore ID is less than 104. After this, I shall write down, I'm giving an OR operator over here and I'm combining this OR operator with the next condition. So the next condition would be S underscore gender is equal to female. And let me go ahead and execute this. So here what is happening is, if either of these conditions is satisfied, we'll get the result. So what we'll get is, so we've got 6 records over here, and with the help of this condition, so this says if student ID is less than 104, which would mean that we'll get the top 3 records over here. And along with that, since we're also giving in the second condition, which is as gender is female. Now here, even though the student ID is 106, which is greater than 104, but as you see, the gender is female, and that is why we'll also get this particular record. So let me select this entire thing. Let me run this. And as I've told you guys, from the entire table, I have extracted those records where the student ID is either less than 104 or the student gender is equal to female. So folks, this is how we can work with the where clause and filter out records on the basis of this. So thank you very much for attending this session. And again, if you found this session insightful, please do like this video and also subscribe to our channel. And we'll meet in the next one. Thank you.
Hey folks, I welcome you guys back to Scalar Academy's YouTube channel. And in this particular session in the SQL tutorial series, we shall work with the update query. So till now we've seen how to create a table, how to insert records into the table. Now with the help of the update query, we shall see how to modify the records which are already stored in our table. So what we'll do is we'll directly open up MySQL Workbench and start working with the update query.
So I've opened up MySQL Workbench over here. Again, I will click on local instance and let me go ahead and give in the password. And we have our MySQL Workbench right over here. Now my task would be to select the database and open up the table. So the database which we were using was college. So here I shall write down use college. Let me select this and I will click on this button. So I've selected the database. Now what I'll do is I'll go ahead and use the table which is present inside this. So the name of the table is student. So to look at all of the records which are present in the table, I shall just write down select star from student. Now again, I will click on this and as you see, these are the different columns which are present and these are all of the records. So as of now, it seems that we've got 6 students. And we've got their names, we've got their marks, and we've got their gender respectively in this table. Now, what I'd want to do is, let's say if the marks which Anne Cleopatra has scored, it's actually 97 and not 87. There has been a mistake while storing the data. What I'd want to do is actually change that. And for that purpose, I can use the update query. So here, this is how I would change the marks which are stored as 87. I would want to change that to 97. So let me just write down update. So this is how I'll start. I will start off by writing the keyword update. Then I shall give in the name of the table. So the name of the table is student. So update student. After this, I shall again use the keyword set. And I would have to set S marks to be equal to 97 where the first name is equal to Anne. So here I shall select where S underscore first underscore name is equal to Anne. So what I'm doing is I am changing the value of marks from 87 to 97 where the first name is equal to Anne. Let me select this entire thing. I'll run this properly. So seems like we have an error over here. You are using safe update mode. So normally what happens is if we are trying to update something and by default in your MySQL server, if it is in safe mode, you cannot update it. So we'd have to turn off the safe mode. So to turn off the safe mode, this is the command which I'd have to use. So I'd have to use set SQL safe updates is equal to 0. Now I'll select this. Let me run this now. So as you see, this has been properly executed. Now again, I'll select this update query and I will select this. Now this has been successfully executed. So now that I've made the changes, let me go back and open up my table. So here I shall write down select star from students and let me run this and let me see what would be the result that I get. So I'll select this again. So this has to be student if I'm not wrong and not students, and I'll click on run. So as you see, initially the marks which Anne Cleopatra has scored were 87. With the help of the update query, I was able to update it or change it from 87 to 97. Similarly, we've got another student over here. So we've got David Leon and he scored 92. So, but it seems that this again is incorrect and David Leon had in fact scored 62 and not 92. So let me also change that. So what I'll do is I'll write down update, then I shall give in the name of the table which is student. So update student, then I'll write set. And after this, I'd have to give in the name of the column. So the name of the column would be S marks. Update student set S marks is equal to 62 where now in the where clause, I'll actually use the SID instead of S first name. So here this person's name is David Leon and his SID is 103. So here I shall write where SID is equal to 103. Now I'll select this entire thing and let me run this. So again, I've executed this. Now let me go ahead and select my table. So select star from student and let me run this. And as you see over here, initially marks scored by David Leon were 92. With the help of the update query, I was able to change it to 62. So folks, this is where we learned how to work with the update query. And if you do want to learn about the other basic things in SQL, such as how to create a table, how to create a database, or maybe how to insert records into the table, you can watch our previous videos and you'll find the links for the same in the description below. So now before I end this class, I'd request you folks to like the video and also subscribe to our channel. Thank you very much and let's meet in the next one.
Hi everyone, my name is Devi. And in today's video, I will be discussing joins in SQL. I'll be discussing the different types of joins that we have in SQL, and I'll also show you how you can run those join queries in MySQL. But before moving on with the video, I would request you to kindly like this video and subscribe to our channel. Alright, so starting off, first we have a brief introduction of join statements. As you can see, join statements in SQL are used to combine data or join columns from two or more given tables on the basis of a common field between them. Suppose you have two or more different tables and you want a single table consisting of different columns, say one column from one table, another column from another table, and so on. In that case, you could take help of join statements in SQL and obtain a single table with different columns from the different tables. Then we have different types of joins in SQL, but in this video we'll be covering inner join, left join, right join, full join, and self join as well. So to begin with, first let's take an example. As you can see on the screen, we have two different types of table. The first table is the student table, which contains 4 different columns: roll number, name, address, and age. Then we have the second table, which is the course table. The course table contains 3 different columns, as you can see: serial number, course ID, and roll number. So the first join that we have is the inner join. Now the inner join or join keyword is mainly used to select all rows from the given tables for as long as the condition remains satisfied. Now the resultant table that you get is formed by combining all rows from both the tables where value of the common field will be the same. So as you can see, the syntax for inner join is given right here. It goes like: select table 1 column 1, table 2 column 1, from table 1 inner join table 2, on table 1 matching column equals table 2 matching column. Now here table 1 refers to the first table, table 2 refers to the second table, whereas matching column refers to the common field between the two given tables. Now for the given tables, the inner join query would be: select course ID, student name, student age, from student inner join course on student roll number equals course roll number. Now what this inner join query does is that it gives you a single table which contains the 3 columns: course ID, name, and age. And these columns are taken from the 2 tables, student table and the course table. And also this is done on the basis of the given condition that the roll numbers must be matching. Here you can see the output or the resultant table on the screen. There's the course ID, name, and age. Moving on, the second type of join that we have is the left join. The left join, which is also known as the left outer join, returns all the rows of the table on the left side of the join and matching rows for the table on the right side of the join. The resultant table that you get displays null value for those rows which have no matching rows on the right side. You can see the syntax for left join here. Select table 1 column 1, table 2 column 1, from table 1 left join table 2, on table 1 matching column equals table 2 matching column. Now for the given set of tables, the left join query would be: select course ID, student name, from student left join course on student roll number equals course roll number. What you get from this left join query is a set of these 2 columns, which is course ID and name, and this is given in the form of a single table by joining the student and the course table on the basis of the given condition. You can see the output or the resultant table on your screen. We have the course IDs and the names, and these data is associated with the same set of roll numbers. Okay, so the next type of join that we have is the right join. The right join, which is also known as the right outer join, is quite similar to the left join, but the only difference between the two is that the right join returns all the rows of the table on the right side of the join and matching rows for the table on the left side of the join. The resultant table that you get displays null values for those rows which have no matching data on the right side. As you can see, we have the syntax for right join right here. Select table 1, column 1, table 2, column 1, from table 1, right join table 2, on table 1 matching column equals table 2 matching column. For the given set of tables, the right join query would be: select course ID, student name, from student right join course on student roll number equals course roll number. What you get from this right join query is a single table which contains the columns course ID and name, and this is done by joining the 2 tables, student and course table, on basis of the given condition in the query. You can see the output or the resultant table here. Here we have the course IDs and the names, and also we have null values in the course ID column wherever there is no matching set of data. So the fourth type of join that we have is the full join. Now the full join is nothing but a combination of both left join and right join. The output table that you get from full join contains all rows from both the tables, and also the resultant table contains null values for the rows which have no matching set of data in any of the tables. Here you can see the syntax for full join. It goes like select table 1 column 1, table 2 column 1, from table 1 full join table 2, on table 1 matching column equals table 2 matching column. Now for the given set of tables, the full join query would be select course ID, student name, from student full join course on student roll number equals course roll number. Now what you get from this full join query is the output or the resultant table, which you can see on your screen. Here we have all the course IDs listed on the left side and all the names listed on the right side of the table. And also you can see the null values wherever there is no matching set of data available. Now the last type of join that we have is the self join. The self join statement, as the name suggests, is used to join a table to itself. Each row of the table is joined with itself as well as all the other rows available based on some given conditions. The syntax for self join is select A column 1, B column 2, from table name A, table name B, where given condition. Here, the table name refers to the name of the table that you're joining, and the given condition is the conditions based on which the rows are selected. Alright, so for the given set of tables, the self-join query would be select A roll number, B name, from student A, student B, where A roll number is less than B roll number. Now the output that you get from this self-join query looks something like this. Here you have the set of roll numbers, and on the right hand side of the table you have the set of names. This table is obtained on the basis of the given condition that you have here in the query. So now I'll show you how you can run these join queries in MySQL. Here on the screen you can see the MySQL workbench. So let us see how we can run those queries. So on the left side of the screen you can see the list of schemas. Now I have already created a schema or a database that we are going to work with today. Here you can see the database that I have created, user underscore db1. And I'll also show you the tables that I have created. Here's the student table. I'll show you the student table right here. You can see roll number, name, address, and age. It has all these 4 columns. I've also created another table, which is the course table. You can see the course table right here. Serial number, course IDs, roll numbers. All of the data is present right here. So now let us begin. First, you can see here's the workspace. Here's the area wherein you can write your queries. First, let us see all the default databases that we have. This is the query you use for seeing all the default or existing databases. As you can see, we have these default databases and the database that I've created, user underscore db1. So today we'll be working with this database. And okay, so the first query that we are going to run would be the query for inner join. So let me just quickly type in the query, select course ID, then we have student name, from student inner join, course, we have on student roll number equals course roll number. All right, so now I'm quickly going to run this query and see what we get. As you can see, we have the resultant or the output table here. We have the course ID and the names. Okay, so moving on, the next query would be the query for left join. I'll just quickly type in the left join query. We have select course ID. Then we have student name, from student left join course on student roll number equals course roll number. Okay, so here's the query for left join. Now I'll run this query. Okay, so now you can see we have the output right here. We have the table which has course ID and the name. Also, we have null values wherever there's no matching set of data. So moving on, the third query that we are going to run is for right join. So I'll just quickly type in the query, select course ID. We have student name from student, right join course on student roll number equals course roll number. Okay, so here's the query for right join. I'll just quickly run this query. As you can see, we have the output of the resultant table right here. We have the course IDs and the names and null values for wherever there's no matching set of data. So now, coming to the full join query, let me just tell you that the full join keyword is not supported by MySQL. So what you can do in this case is you can use a combination of left join, union, and right join keywords all at once. I'll just show you how you can do it. First, you need to type in the query for left join. This is just the same query that we have run previously. Student name from student, left join course on student roll number equals course roll number. So here we are done with the left join query. Then you need to type in the keyword union followed by the query for right join. Course ID, we have student name from student, right join course on student roll number equals course roll number. Now we are done writing the query. Now I'll just run this query and see what we get. Here you can see we have the resultant or the output table with the course IDs and the names and null values for wherever there's no matching set of data. Okay. So the last query that we have for today is the self-join query. Select a roll number. We have B name from student A, student B, where A roll number is less than B roll number. Okay, so here we have the resultant table or the output table with all the roll numbers and the names based on the given condition in the query. So I hope you're clear with the concept of joins in SQL. In this video, I have discussed with you the brief definition of join statements. I have shown you how you can run all the join queries in MySQL. I hope now you're clear with the concept. If you like this video, please don't forget to hit the like button and also subscribe to our channel. Thank you.
Hi everyone, I'm Naman Bhalla, and today in this video we are going to discuss about SQL queries and some of the common type of questions that appear regarding to SQL and basics DBMS knowledge that is required if you want to be good in DBMS. So the topic for today is SQL interview questions and concepts. Okay. So today we are going to first start with a basic coverage of different concepts that you need to know before you even start diving into doing SQL queries. You must know that, okay, how data is arranged, how to arrange data, how to structure your database in a good way, such that it is very fast on the queries that you have to do and all other things. Okay, great. So let us first begin with what even data is and why is data important. Okay, the efficiency of any company, any business depends upon the data it has. Okay, I'm like the user data that you have, or you have the data about how people are behaving, and that information is very relevant for you to make business decisions. Okay, so data is of a prime importance and at the core of a company's functionality. Okay, now how will you arrange data? To arrange data, you need some kind of system, right? What can be those systems? One very basic way to arrange the data can be, hey, that let me just actually create a file, and suppose I have a data, and my data is something about, let us say that we are developing database for a system, okay, for a university. So what will be my data like? Let us say that I am a university, so my data can be like something about students, right? I can have some data about students. I also can have some data about my faculty, right, or my employees. Let us say for now, let us keep it short, and let us say that we have only data about these two things. Now, how might I save it? One way to save it is very rudimentary way that, hey, let me actually create a lot of files on my machine, and then in those machines, let me store the data. So let us say that there is a file, something like students.txt, and let us say that there is another file that is employees.txt. And then suppose you have multiple students. Let us say that there is a student who has a roll number 1 and his name is Abhay. And suppose he has a batch. Let us say that we are storing these three information. We store it something like 1 Abhay, and let us say it is 2016. So that is a very fine way to store data. There's nothing wrong with it, right? But is it a good way to store data? That depends. And that depends upon what kind of data that you have, right? So that is where the concept of a database management system comes. That, hey, how will you even store the data? What optimizations will you do so that the storing data is relevant to you? Because you don't just store data, you also use it, right? So you have to do some queries upon it. You have to also fetch the data back again to make some business decisions or resolve some queries, right? So there are two important decisions that you need to do. The very first decision is storing the data, and the second thing is querying that data, right? Without these two operations, our database management system is irrelevant to you. Okay. So our DBMS is nothing but a system software that allows you to store the data and query the data, along with providing a lot of security constraints and other things, which we will tell as we go into this video. Okay. So those are the primary two things that we need to maintain with us. Okay. So that is what a DBMS comes from. How can we structure a DBMS? One way to structure, I mean, like, how will a DBMS inside itself structure itself, right? So the one way can be like even a DBMS maintains a file. That is a fine way to structure. That might be something like it is maintaining documents. Okay. Can there be any better way to structure your data inside a database management system? What do you store the data about? In your computer, you store the data about some things, right? You store the data about something. Like here, you were storing the data about students. You were storing the data about employees. Suppose there is also users. You have some, let us say that probable students or people who have applied to you. So there might be something like applicants, which you are storing the data about. Okay. So you are storing the data about something, and for each student, for each thing that you are storing data about, you are storing some things about that thing, right? So these things that are called as entities. So entities are nothing but about what or about whom are you storing data. Okay. And about whom you are storing data, and what data are you storing, right? You are also storing some kind of data about things. Like, for example, for students, you are storing the roll number, you are storing the name, and you are storing the batch ID. That depends upon the business decision as to what you want to store. So there are two things. The very first thing is the things that we are storing the data about, which, as I told, is called as entities. And then there is attributes or fields. What data about entities are you storing? Now, let us consider our real world use case. Is data in silos? No. There is always a connection between one data and other data, right? So for example, for a student, let us say in a university, you might also need to maintain that which courses have been enrolled by a student. So somehow you also need to maintain a course enrollment data set, right? So let us say that another kind of entity can be course enrollment. For course enrollment, what do you need to store? You might need to know that what is the course number, and also you might need to store that who is the student who has enrolled for that course. So let us say the two things that you need for a course enrollment is nothing but a course represented by an ID, and also a student, which is probably represented by a roll number. Okay. Now suppose these are the three data sets that your university has. If we see here that, hey, we were maintaining the student roll number here, as well as we were maintaining the student roll number in the data set for this student, we were maintaining that roll number here. So data set is not in silos. Our data at what particular location has some kind of reference to data at other particular entity, right? Okay. This is known as relations between data. So now we observe one pattern in it that, hey, we are maintaining data about something, and we are also, because we have maintained data about different things, then we somehow need to maintain relations between them. So a database management system which stores data in the form of entities and the relations between them can be known as RDBMS, or relational database management system. Okay. What kind of RDBMSs exist? There are different varieties of RDBMS that exist in the open source industry and are used very widely by different companies. Some of the popular examples can be MySQL, and another popular one can be PostgreSQL. Okay. Now, in these two terms, you would have noticed one thing repeating, right? You would have noticed one thing that was repeating was SQL. What is this SQL? This SQL stands for Structured Query Language. This can be considered as a default language, or I mean, like, it's not actually default, but it's one of the most popular languages to query upon the data that you had stored. Because as we recalled earlier, whatever data that you have stored has also needs to be fetched, right? I mean, like, if data is just stored, it's of no importance to us. It's just increasing your storage. I mean, like, it might be relevant to us in the future, but anyways, at one time we do need to assess it, and that is why we are storing it. Okay, cool. So now SQL, as we told, is the most important language that is used to fetch data from the relation RDBMS systems. Now let us see how SQL works. Okay, so the very first important thing that we see from SQL word itself is a query. What is a query? A query is nothing but a statement that you execute to fetch the data from an RDBMS. What is one important thing about computers? One important thing about computers is they do what you tell them to do, right? But they also require that you should be very well defined. You can't just say random things to it and expect that it will fetch you the exact results that you wanted, right? So you need to be very well defined. So you need to know that how do I write queries in SQL, right? Otherwise, you won't get the data that you actually intended to get from the SQL query. So the prime focus for the today's session will be how do we write SQL queries? What are the important constructs that we need to know while we write a SQL query? Most of the SQL functions in different DBMSs are almost same. So that is why we are going to abstract away from one particular technology of a DBMS. We are going to structure about common abstractions that we have in a DBMS management system, and then you can run those over any kind of system that exists. Okay. So the very first type of query, the very first important function or important feature to do a query is the select statement. This select statement is the most important thing that you need to know to run any query. What does select do? I mean, if we just go by the definition of the word, select means selecting something or choosing something from the data that you have, right? So that is the whole function of a select statement. So a very simple select statement can be that, hey, suppose you have a student table and you are maintaining three things about a student. Let us say that he has an ID, he has a first name, he has a last name. Okay. And you need to know that, hey, who is the student who has an ID of 1? Suppose that is the thing that you need to know. And there are multiple students. Let us say the student with ID 1 has a first name of A and a last name of P. Then there is a student with ID 2 who has a first name X and last name Y. And you need to know that what is the first name and last name of the student who has ID of 1. So you basically need to know A and P. How will you use the select statement to write this? It's very simple. You will say select. What is this? This is first name. So I need to select the first name. What do I also need to select? I also need to select the last name. So select first name, comma last name. Where do I need to fetch from, right? So suppose someone asks you that, hey, you need to get this thing. I just tell you that, hey, you need to get a, suppose a biscuit. Where will you get that from? You will ask me that, where should I get that from, right? So that information is relevant. So the next thing is from. Where should the query language get the data from? So suppose it gets from a particular table. The name of the table is student. So select first name, comma last name from student table. Okay. If you write just this query, what will you get? I mean, suppose you're a computer and someone tells you that, hey, you have to just get first name and last name from the student table. You don't know. I mean, like you go to the student table and you try to see that which first name and last name I need to get. You see there are a lot of first names and last names. So best way is that you bring all of them, right? If you just write this query, what will it return? It will return the whole table as it is. It will get the first name and last name of all the students. So basically what you will get will be A, B, and XY. Why did it return this? Because you didn't specify which first name and last name should the SQL get, right? Okay, so let us be a more precise. Let us say that, hey, you have to select first name and last name from student of the person who had the ID 1. So you need to know that, hey, the ID should be 1 at that place. So you can write where ID is equal to 1. And finally, you can terminate the statement with a semicolon. Okay. So what will this return? This SQL query will return you A and B. And why will it return? This is because of three statements that we just saw here of SQL, that is select, that is from, and that is where. These are the keywords in the SQL query language. Great. So I think the basic idea about a select statement is clear now. Now let us discuss about a subquery. I mean, like we will be discussing multiple of these where clauses from in depth, but let us first discuss the basic high level concepts before we delve into details. Let us discuss what a subquery is. Now, let us say that you need to give degree to some students. You are a university, you need to give degree to students, right? The students who are just going to pass in this particular year. Okay, now how will you give degree to those students? Suppose you have two tables. The one table that you have is a students table. Okay, in this students table, you have an ID, you have the name of the student, let us say, and let us say that you have batch. Okay, suppose this is a simple student table that you have, and you need to give degrees to the students who are going to pass in batch 2020, let us say. So then someone comes to you that, hey, some of those people who had the batch of 2020 are actually not going to get the degrees because they failed in some courses. Then you ask that, okay, where should I know that which students failed? So that person tells you that, hey, there is also a table that is failed students. In those failed students table, you have IDs of the students who have failed. Okay, so now you need to give degree to those students who have the batch of 2020 but have not failed. So somehow you now need to use what is here to give the result of your final query. How will you do that? To know which are the students who had failed, you need to select all the IDs of students from here, right? So somehow you need to select IDs from failed students. Okay, but the task that is given to you is not to fetch the IDs of failed students. The task that is given to you is to tell who are the students who are going to get the degree. Who are the students who are going to get the degree? Those are the students who actually have the batch, who actually have the batch of 2020 in the students table. So also you know that you need to do this, that, hey, select ID from students where batch is equal to 2020. Okay, so now you need to select those IDs from this students table where the batch was 2020, but you don't need to select those IDs that were present here, right? So what will you do? One very simple way, I mean, like one thing we will come to that in later of section of this video. There is also one statement which can do it in one line. But let us say you can say that where batch is equal to 2020 and ID should not be an ID not in. And where should the ID not be? The ID should not be in the result of query of this particular thing, right? So ID not in, select ID from field students, right? So here we saw that, hey, we used one select statement inside another select statements, right? This is also known as a subquery or a nested statement. By the way, this not in is a keyword in SQL where you can select those things that are not present in the result of a particular table as well. Okay, but now let us say that you ask me a question that, hey, how does SQL know that these and these are the same thing, right? I mean, like, how will it know that? I mean, there should be a basic thing that whatever data is here should be whatever the data was present in what was I mean, like, retrieved from the earlier query, right? So that is a constraint that SQL asks you. I mean, like, that's your responsibility to maintain that the data type of the data that is taken from here is equivalent to the data that is here. Okay, so that is what a nested statement is. Okay, now what kind of nested statements can be? There can be two kinds of nested statement. First can be correlated. What does a correlated nested statement means? What does a relation with two things means? Relation between two things means that, hey, one of those things cannot exist without the other thing, right? So a correlated subquery is a query in which none of the, I mean, like, in which this subquery, this is the subquery, right? Subquery is not independent, but needs the main query to execute itself. So it can't exist independent of each other. So if there is a correlated subquery, then what can be a different kind of subquery? The second kind of subquery can be non-correlated subquery. In which the main query, for example, in this particular query, this was the main query and this was the subquery, where main and subqueries are both independent. Okay. What do you guys think was the above subquery? Was it a correlated or was it non-correlated? As we can clearly see that in the above example, the select ID from field students can exist without even the main query existing, right? So it is definitely an independent or a non-correlated subquery. Okay. Okay, so now we have discussed select, but now you also see that we were doing where, right? We wanted to check about, we wanted to do some kind of assertions that, hey, I need to know data about those things. I need to know the data where a particular thing is maintained, right? So let us discuss the common clauses. This where is known as a clause. Okay. So I mean, like, what is a clause? I'm like, in normal term, in normal real day life, you might have thought about clauses in your agreements or contracts, right? Those are the things that you need to check. Those are the things that you need to ensure. So where is also a clause. So let us discuss SQL clauses. Okay, one of the clauses that we have already discussed is where. There are three other main important clauses. Those clauses are group by, having, and order by. One of the best parts about the SQL query language is that, hey, each of the words in the language are actually very, I mean, like, self-descriptive, right? Because, I mean, like, you just see the word and you kind of get an intuition that, okay, what might this thing be doing? What can the where thing be doing? Where clause just allows you to filter the records based upon some conditions. Okay, for example, what were the conditions? What were the conditions in the original query that we had written? In the original query that we had written, the condition was that ID should be equal to 1. Let us say that our data had multiple students, and those students, let us redraw a student table. In the students table, we again are having ID, we are having a name, and let us say we are having batch. Okay, and let us say that there is an ID 1, 2, 3, 8, 9, 11, 12. Okay, the name is A, B, C, D, E, F, G, and batch is 2020, 2021, 2020, and 2022. Okay, so now I ask you that, hey, you only need to give me the students who have the first condition is who are going to pass in 2020, that is who have their batch as 2020. And the second thing, I also ask you that their IDs should be less than 10. Okay, so then what will your where clause have? Your where clause will have two things. What are those things going to be? Your where clause will have first will be batch is equal to 2020. And what is the second thing? The second thing that your where clause will have, ID is less than or equal to 10. So this is a simple where clause, and a where clause can have multiple things, multiple assertions that need to be maintained. And those assertions can be grouped with and. And if there is and, what do we think that other statement might be? I'm like just similar to and. Suppose if I'm like if we have done programming, there is and then there is a or as well, right? So suppose I had, instead of writing and, I had written or. What would the result of this query be? This query will result into all those students who either had a batch of 2020 or had an ID less than or equal to 10. So the query will return this. The query will the query return this or not? The query will return this. Why? Because the ID is less than equal to 10. So this will be returned. This will be returned because this is also satisfied. This is also satisfied. This will be returned because ID is less than equal to 10. This will be returned. This will be returned because batch is 2020, but this won't be returned because neither is batch 2020 or I did this. Okay, great. So that is where clause. Now let us discuss the order by clause. Before we discuss group by and having, because they are interrelated, first let us discuss the order by thing. What do we mean by an order? What do we mean by an order? Order is nothing but an arrangement of things in the way you want them to be arranged, right? Consider order by something similar to sorting. Okay, now I ask you that, hey, please return me the list of all the students. Okay, I just tell you this thing that, hey, please return me list of all the students. You go, you fetch all the students and you return it to me. But in which order will you return? Did I ever tell you that? No, right? So there might be a thing that you ask that, hey, hi, in which order should I return it? So for example, let us take a normal use case. Suppose there are a lot of things in a restaurant, a lot of things in a restaurant menu, and those things are grouped by being a starter or being the main course or being a dessert. Okay, suppose a starter is represented by a 1, a main course is represented by a 2, and a dessert is represented by a 3. Okay, now one person asks you that, hey, he has maintained in a DB table, he has maintained one starter, one main course, and one dessert. Okay, suppose he has maintained a DB table which is something like what will I eat, what to eat. Okay, so which is food ID. It also has food name. Okay, and also it also has food type. Okay, so food ID can be something, I mean, like suppose you are representing breads by something, you are representing some kind of pastries by something like that. Let us say there's a food ID which is 201, which can have a name of pastry, which let us say is a dessert, right? So let us name it 3. Then there can be something he has selected 1. There are multiple things he has selected as main course, so there can be 2 things. Let us say that he has rice and he has some kind of meal or something. Okay, so then there are 100 or 120, and then there is one starter that he selected. Okay, let us say it is XYZ and it has 300. Okay, and this is a starter, so this is 1. In which order will the person like to eat? The person will like to eat in the order that he will have like to have, I mean, like he will have the main meal in between and then the dessert, right? Okay, so you need to, so you just go to the DB table and you say that, okay, return all the meals that the person had selected in what to eat. If you return the meals in the order that exists in the table, then you will actually disappoint the person like anything, right? So you need to return those meals in the order of what type of food they are. So you should return pre-meal here, then you should return main course, and then you should return the dessert, right? So you need to order the meals that you bring by food type. So how will you do this thing? So you will say select food. Let us say you select the food ID. Where should you select those food IDs from? You will select those food IDs from what to eat. From what to eat. Okay. But in what order will you select those? You will select those in order of food type. So you will say order by food type. Okay. So then your SQL query will return this thing first, then one of those two things. I'm like, it can return any of those two because they have the same food type, and then it will return finally the decimal. Okay, so this is the order by clause. Now let us discuss the other two things, having and group by. Okay, what is having and group by? I mean, like, what is the intuition that you guys get that, okay, what might having represent? Okay, so let us first think of group by. But let us first think of group by. Group by is a thing that is used by aggregate functions. Okay, let us actually talk about group by here. Group by is a statement, is a clause that is mostly associated with aggregate functions. Okay, so what does this mean? Aggregate function means that, okay, those functions who actually compute upon a large amount of data and then return a result. So there can be two kind of functions, right? One kind of function computes upon a single argument and then returns a value. So those are known as scalar functions, which we will come to in depth again. And then there is an aggregate function. Okay, suppose aggregate function, the examples of aggregate functions can be sum, can be average, and those. Okay, so let us discuss about a simple thing. So let us say that you are using a having clause. So you want to know that you have to return those students, I mean, like, who lived in India and the student ID was greater than 5. Okay, so you need to return count of those. So what you will write? So you can say that select count of student ID, comma, country. So I mean, like, let us say that we had a DB table. In a DB table, with every student, I was also maintaining his country. Let us say in this student table, I had a country of first person was India, then this was USA, this might also be USA, this can be UK, this can be India, and this can be India, and this can be India. Okay, so you need to know that which are the people who have a country of India. So that is the very first thing to know. That, okay, so let us say that we need to know who are the students who don't have country India. Let us say we do the reverse. We need to know who are the students that don't have country as India. Okay, then you get the students. Which will be the students that you will get who don't have country as India? You will get this, you will get this, you will get this. That's it. Okay, but now you need to order them in some way. Someone tells you that, hey, once you have filtered those students who don't have country India, please group all the students that had a country together, right? So group all the students who had country USA together, then group all the students who had country UK together, and so on. Okay, so how will you do that? You will say that select count of student ID, comma, country from students. Okay, where what should be the thing? The thing should be that country is not equal to IN, because IN is representing India. Okay, okay. Now you get all those students. Now you need to group them by countries, right? You need to group the countries that had USA together. Okay, so group by country. Okay, so all the students that have the same country are now together. That's it. Suppose you return this. What will this return? Now, what a group represents, a group basically creates a single group of people who had the same value here. Okay, so let us decipher this particular query one by one. Okay, in this statement, the very first thing is select from students where country is not equal to India. This thing will give you 2, 3, and 8. So you get these three things. Okay, then the next thing that you do, you are grouping them by country. So then you get two groups, right? There are two students that had USA and one student that had UK. So now you will get two groups, which are 2B and USA, and 3C and USA, and the final one was 8D and UK. Okay, so these two students were in the very first group and this student was in the third group. Okay, now you have grouped them by country. Now what do you need to return? You also need to return the count of student ID. Basically, how many different student IDs were there where in each groups. So because count is a aggregate function. It works upon a different thing. It works upon a set of inputs and returns the number of inputs that are there. So what will be here? It will be 2. What will be here? It will be 1. So what will it return? It will return 2 USA and 1 student from UK. So writing this query helps you to find the number of students from each country where the country is not India. Okay, I hope that is clear. Now let us discuss having. Suppose I have written this query. Okay, and then I tell you that please return only those countries, where the number of students were greater than 1. Okay, so you need to return only USA and not UK. Okay, so having allows you to do filter on aggregate queries, filter on aggregate functions. So you can say that where having the count of student ID, so you can here write having count of student ID, or let us say ID, which is greater than 1. So if you write this thing, you are only going to get USA. So the difference between where is just a filter upon a normal attribute value, whereas having is a filter upon an aggregate function, the value returned by an aggregate function. So the question is why we use having instead of where clause in group by clause. So having actually used to, because see, once you have done group by in functions, then you need to do some kind of query upon these groups, right? So consider this as different, that you have done a grouping. Here you have done a grouping, and then out of those groups you are selecting particular groups that had something as this. Okay, so that is why you need to do a having kind of thing. Okay, great. Now we had actually, when I was discussing this particular thing, that hey, let us say that we had to select the students who we were giving degree to. Okay, then I tell you that hey, we also don't need to select the students who actually failed. I told you that hey, we will run one query and then we will run a subquery, and the basically whatever the value was not in the second subquery, we will put in a not in clause and then give, right? This thing can be done in one query in SQL. So let us discuss three functions, which are union, minus, and intersect. Okay. By the way, I'm like, if you have studied set theory, these clauses seem very similar to what we discussed in set theory, right? Is there any kind of relation between set theory and why these terms are like that? Yes, there is. The reason for that is because the relation that RDBMS system, when they were actually originally the paper of RDBMS, actually is representing all these things with notations of set theory. So an RDBMS is nothing but a implementation of set theory, that okay, how you will be doing operations upon data in terms of how you do operations upon set. Okay, so each table is actually a set and not order table. So that is why there is no guarantee as to how the data will be arranged in the table. It might happen that this data is somewhere here or this data is somewhere here, because these are sets and not tables. Okay, Acha. Now let us discuss union, minus, and intersect. What is union in a set? What is union in a set? In a set, let us say that we have two sets, A and B. In one set, we have three things, 1, 2, 3. We have four things here, 4, 2, 1, and 5. What is union of A and B? By the way, union in set function is represented by U sign. So what is AUB? This is nothing but 1, 2, 3, 4, and 5. Basically, union is the combination of all the values that is present in any of those two sets, right? If you also notice here that, hey, 1 was present here as well, but 1 was present here as well, right? But in A union B, we got 1 only once. So a union removes duplicates, returns duplicate only once. But what if you want to return, if 1 is present here and here as well, you need to return it twice. What if you want to return 1, 1, 2, 2, 3, 4, and 5? For this thing, there is a union all in SQL. Okay, union all keeps all the duplicates. Okay, so what the union statement basically does is, union statements returns all the values that are present in any of the sets. present in any of the sets. Okay. Now, what is minus? So I tell you that, hey, I have some things here. I have some things in this particular system, which is, let us say, A, B, C, D, and E. These are some things here. I tell you that you need to return everything that is here, but should not be here. Okay. So what will you return? I mean, like, suppose, let us say that you have 5 things and 2 things. You need to return every of those 5, but those 2, but not those 2. So you do 5 minus 2, right? In maths, you do a 5 minus 2. Similarly, in sets, you can do a set A minus set B. Suppose this is represented by set A. This is represented by set B. If you do set A minus set B, you will get all those queries that are here. I mean, like, they should be here, but they should not be here. Suppose there was an F here as well. So what are the queries that are here? These are A, B, C, D, and E. Okay. And what is the second thing? The second thing is they should not be here. So out of these things, what are the things that are here? So they are B. So B will be removed. Well, that is A. So A will be removed. This is F, but F is not here, so we are fine. And the final return from here will be C, D, E. Now, do you guys think that we could have actually directly used this minus statement in the previous question? What would we have done? Instead of writing where not in, we could have just done minus here, right? So if we were doing here, we could have just done minus here and we would be fine. Correct? Great. So that is the minus query. And then what is intersect? Intersect is also a set function, and intersect between a set A and a set B is represented by an inverted U sign, and it says it returns values present in both set A and set B. So let us say that set A had the values 1, 2, 3, 4, 5, and 6, and set B had the values 2, 4, 6, 8. Now, if you do A intersection B, it will return those values that are present in both of those sets, right? So it will return something that are present here as well as here. So those are things like 2, 4, and 6, right? Great. Now let us actually, I mean, like, now we understand that, okay, what are these commands doing, but how will we actually write them in SQL? How will we use them in a SQL query? In these SQL queries, these statements are between two select statements. So how will it be represented? So one way can be that he select name from students minus select name from failed students. What will this query do? This query will return all those students, the names of all those students that are students but are not failed students. Now I tell you that you need to return everyone who is a member of my university. So suppose my university can have students and he can have employees. Okay. And it can also have, I mean, other things, but let us say that for now these are the only 2 things, and you need to return everyone who is member of the university community. So now you need to represent a union of those 2 things, right? Either that person can be a student or that person can be an employee. So what will you do? You will do select name from students union select name from employees. Okay. Now there can be one thing that, hey, I need to select those students. Who are actually, let us say, living in a particular city, who are living in Delhi. Okay. Let us say, how will we do that? So we will say select name from students. Okay. Those are all the students, right? And then I have a different table. Let us say my database was arranged like this, that I had a students table and I also had a Delhi students table. Okay. So I need to select all those students that are, first of all, students. And the second thing, that they are also Delhi students, right? So I will do an intersect. I will intersect with select name from Delhi students. So this will return me all the list of people who are present in this set as well as this set. Okay, as I discussed earlier, these terms are actually related to set theory, and an RDBMS is more of like sets and not of more like arrays. Okay, or what we say, a table. Okay, so these are sets. This is set 1, this is set 2, and this is a set operation of intersect. Okay, so there is a query that is it minus or except. This is a minus. Okay, this depends upon different database management systems as well. Okay, I mean, like, depending upon different DBMS system which are implementing, these concepts might be known by different names, but mostly these are known by the common terminology of union, union all, intersect, and minus. Okay, great. Now let us discuss one of the most important topics that are there in database management systems, that is joins. What is a join basically? Now, as we discussed earlier, that hey, data doesn't appear in silos, right? Some of the data might be here. Also, some information about that student might be in some other table, similarly, and so on, right? Let us say that we are maintaining data about an organization. Okay, let us say that we are maintaining data about an organization. So in the organization table, in the organization data set, we have first thing, we have employee table. And the second thing that we have is, let us say, employee salaries table. Okay. Okay. So now the thing is that I need to know the salary of a particular employee. Okay. I need to know the salaries of particular employee, or I need to return to you. Someone comes to you that, hey, please return me. Let us say that this employee table is storing ID. He's storing the first name. He's storing the last name. And let us say that he's he's storing the role. So these are the four informations that are maintained in an employee table. And let us say the employee salaries is nothing but an ID, and there is a salary. Okay. Now someone comes to you that, hey, please give me the list of all the employees along with their salaries. So now what you need to do is you need to return some data from here along with some data from here, right? So you need to return a group of things. So suppose there was an ID 1, the first name was A, the second name was B, his role was, let us say, he is a CEO, and then the salary of ID 1 is, let us say, 10,000 some units. Okay. Then there is an ID 2, first name is A. Two people can have the same first name, right? The last name can be C, and let us say his role is a VP. The salary of VP is something like, let us say, 8,000, and so on. And what you need to return? You need to return 1 A, B, CEO, and 10,000, 2 A, C, VP, and 8,000. So now you see that, hey, to return my answer, I need to actually fetch two tables. I need to fetch data from two tables. Okay, but how will you ensure that this data corresponds to this data, and this particular row, this particular record corresponds to this particular record? How did you come to know that? You came to know that based upon the ID here and ID here. You joined, or basically you selected those, you combined by the ID, where this ID matched, you combine those, right? This is the use of joins. It allows you to fetch data from two different sources, from two different tables, based upon something that matches. Okay. So now how is this happening? Let us discuss different type of joins when this will become clear. So the very first join and the most important join is the inner join. Inner join allows you to basically join based upon a particular column, and the data should be present in both of those things. So suppose there was a ID 3 and he had a salary of 6,000, but you don't see any employee with ID 3 here. So what is even the use of returning this data, right? So if still the same person asks you to return all the employees along with their salaries, you only need to return this, correct? Because you don't know if this 3 person is here. And let us say that there was an ID 5, and his first name was D, his last name was E, and he was also a VP. But you don't have his salary information. So you don't have his salary information. There is no salary information available here. So you only need to return those data whose information is available here as well as here, right? So this is the concept of an inner join. Okay. So let us discuss that how this inner join is going to work. So this is going to, the normal function, how do you write is that select star from first table. By the way, what is this select star doing? This select star does nothing but returns all columns of the table. All columns, okay? Not the rows. Okay, so we select star from table A, and then when we have selected everything, so basically I have selected everything from this table, then I also need to select everything from the employee salaries table, right? So then I will also select star from table B. Okay, but I need to join them. I need to join this with the second thing, right? How will I join this? I will see that, hey, ID here matches the ID here, right? So what I can do is, rather than doing this, so I say select star from table A. I select everything from the first table, and I join. And I join with what? I join with table B. That's it. This is equivalent to select star from table A, inner join table B. So writing inner join is normally in most of the DBMS is not mandatory. Okay. So when you have done this, you get the result of this based upon these two tables. Why? How it automatically selects that what should I group by? It sees that, hey, there was an ID column here, there was an ID column here, as well as there was an ID column here. Because both of those columns had the same name, so it makes sense to, it makes sense to choose that as the common name and then group by that, okay, and then join by that. So that is the inner join. That is the most common join that is used. The second type of join is left join. This is a left outer join, but let us call it left join. What it says is select everything from left side, select everything from left side, and if corresponding values are not there on the right side, fill those values with null. Let us take the above case. So suppose instead of doing an inner join, where the value was present in left side as well as in the right side, I was doing a left join upon this table. So what would I be returning? So I will definitely be returning everything which was from the left side. So I will be returning 1, I will be returning 2, I will be returning 5. But there is no corresponding data for row 5 on the right side. So for those particular things, for all those values of this thing, I will put null and null in the salary. So what will I be returning? I will be returning 1, who has a first name of A, B, CEO, and his salary is of, let us say, 10,000. I will be returning 2, A, C, VP, who has a salary of 8,000. I will also be returning this because this is a left join. So I will be returning 5, D, E, VP. But I don't have any information about this. So I will replace this by null. So this is the left join. As there is a left join, so obviously the opposite also has to be true. So the opposite is right join. What this right join means? This right join means select everything from the right side. Now you have to do the first selection on everything that is on the right side. Now, if the corresponding data of the similar column is not available on the left side, fill the left side with null. Okay, fill the left side with null. If corresponding data is not available on the left side, fill the left side with null. So what will it return? It will return 1, it will return 2, it will return 3. For 1 and 2, there is the data on the left side, but not for 3. So what I will be returning will be 1, 2, and 3 are the IDs. For 1, I know the first name, I know the last name, I know the role. So this is CEO, and I also know his salary. Okay. For 2, I also know everything. So I know that his name is A, his surname is C, it is a VP, and it is 8,000. But there is a person 3 whose first name and last name I don't know. So what will I return? I will return 0. Sorry, I will return null, 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 and 6,000. So this is a right join. Okay, so we have done left join, we have done right join. What can be other thing? The other thing can be, if there is, select everything from the left side, select everything from the right side. If left side has corresponding data in right side, obviously do the join. But if there is no data on the right side, fill with null. Similarly, if there is something on the right side which doesn't have a corresponding data on the left side, fill that with null. So it's a combination of left join plus right join. And what will it return? It will return, and I'm like, it's known as a full join as well. Full join. Select everything, join if a match, else fill left side or right side by null, depending upon the situation. So let us see what will be the full join output for this particular table. I will be returning everything from the left side, right? So I will be returning 1, I will be returning 2, I will be returning 5. So it will definitely be returning at least these 3 things. Okay. But I will also be returning 3. So I will also be returning 3 because it is present on the right side, but it is not present on the left side. So I will also be representing this thing. So if you see, this is the output of left, this is the output of right. What is the output of a full join? Output of a full join is nothing but union of left and right, right? So basically, what will be the output of a full join? It will be 1 A, B, CEO, who has a salary of 10,000. Then there is 2 A, C, VP, who has a salary of 8,000. Then there will also be 5, whose name is D, E. Then he's a VP, but I don't know his salary. But I am also doing a right join, so I will also be returning this. So it will be 3, null, 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 and I know his salary is 6,000. So this will be the output of a full join. Now there is one more thing that that is also there. That is a cross join. So let us say that we have 2 sets. Basically, each select query is nothing but a set, right? So we have a set A and we have a set B. And there are multiple values here. Let us say they are A. These are different rows, right? So these are A, B, C, D. These are, let us say, F, G, and H. Okay. If we have 2 things, if we have 2 different sets, and you have to make a Cartesian product or a cross product, Cartesian or cross product. Okay. What this means is that, hey, combine all the values from the left side with all the values of right side. So basically, what will be the final output? There will be this one row, these. So there are 3 rows. Similarly, there are 3 rows from here. There are 3 rows from here. And similarly, 3 rows from the final D. If there are 4 values in the left side and 3 values in the right side, how many values will be there in the final set of the cross join? If it is a cross join and one side has 4 values and the right side has 3 values, the final values will be nothing but 4 multiplied by 3. Why? Because each row on the left side is going to produce 3 rows, because it is going to be combined with every value on the right side and thus produce 3 rows each of those. So we will be getting 4 into 3, which is 12 as the final table. Okay. So there's a question that what if there are more than 2 tables? If there are more than 2 tables, you can use just parentheses to say in which order do you need to find the outcome. Okay. And all these functions are actually commutative. I mean, like union and intersection functions are commutative. So any of those order works. Suppose you have to do intersection of 3 sets. Okay. So then you can do select star from A. Then you can do union, select star from, let us say, B. Now, whatever all these values we got from here, then we need to do intersect, select star from C. So we can put this in parentheses so that this is executed first, then an intersection with this thing will be executed, and there will be an outer parenthesis as well. So I mean, like, we can group those statements together as we want them to. Okay, great. Now we have been discussing a lot different kind of joins, but what are we actually working upon? We are actually working upon the data. We are actually working upon getting the data. Suppose you have the data, what is your main idea? I mean, like, you want to get that data as fast as you want to, right? I mean, like, you want that, hey, please get me the data as soon as you can. Okay, so you need to ensure that my queries should run fast. How will you make the queries run fast? I think everyone must have heard about arrays, right? Everyone must have heard about arrays, and you guys would have also heard about hash maps. What is the difference between searching a value in an array and searching a value in a hash map? Searching in an array is a linear time operation, whereas searching, I mean, like, if the array is not sorted, and searching in a hash map is probabilistic order of 1, right? Okay, so what we observed from here was that, hey, in a hash map, we use some kind of different space or some other optimization or some other conversions to improve our search time complexity, right? Yeah. So if we want to optimize, if we want to speed up our queries, we can probably use some other memory. We can use some memory to speed up our queries. Okay. Using some memory to speed up queries is known as indexing. Okay. Now let us say that you know that, hey, a lot of times, I need to find all those students who had total score greater than 80, who had total score greater than 80. So suppose you have a table, suppose you have a student table in which there is an ID, there is a name, and there is a total score. Again, recall that hey, SQL is not a array. SQL is a set. Okay, and there is no order in a set. A set can be returned in any random order. So suppose there is an ID student here who has a name A and whose score is 60. Then there can be 2 whose name is B, whose score is 10. Then there is a 3 whose score is 90, and let us say his name is C. Then there is 4 whose also name is A. It can happen that 2 people have the same name. Then it's also 80. Then there is 5 whose name is L, let us say, and his score is 5. Okay. Now, always there are a lot of queries that come that, okay, each query you have is that, hey, find all the users, or find total number of users who had sum or who had score greater than equal to X. If it was an array, I mean, like, if suppose this was the final data set that you had, and you knew that you are getting a lot of function calls just finding score greater than equal to X, would you like this data to be arranged in some kind of order? Would you like this data to be arranged in some kind of order? You would like that, hey, if this data is sorted by the total score, right? If this data is sorted by total score, then you can answer each of these queries using binary search in order of log n, right? So you need to do some kind of post processing. Okay. And also you need to know what are the common operations that your database has, or what are the common queries that your database has. So this is known as a database indexing. What is an index, first of all? An index is nothing but a data structure. To study which is a data structure that actually does that is not the scope of today's lecture, but if you want to study that, you should definitely see about that B tree and B plus trees. What are these? So this is how indexes are actually, I mean, like, most of the times implemented. So an index is nothing but a data structure that provides quick lookup. Okay, because you need to arrange the data. I mean, like, hash table is also nothing but a data set, right? So quick lookup based upon a query, based upon queries in a column or a set of columns. What do I mean by set of columns? Why set of columns? Okay, sometimes it can happen that, hey, suppose a lot of times that you have queries that are actually not just based upon a particular column, but are based upon a conjunction of multiple columns, right? That all the students who have a name beginning with, let us say, B, and who had a score of less than equal to 80. Okay, so then you probably need an index upon 2 columns, which can be name, and the second thing can be total score. So how to choose which will be the columns that you will index upon, that depends upon what your application is showing. What data is your application assessing a lot of times? If you see that a particular data is being assessed a lot of times, it makes total sense to add an index over those particular columns. How will you create an index, by the way? To create an index in SQL, you run this. So you run a statement like this, create. So by the way, I mean, like, if you ever have to create something in SQL, you use the create statement. If you have to create a table, you use this. You have to create a database, you use this. And this time you have to create an index. So you do create index. You can also name the index. Okay, I mean, like, you can call the name of index something that you want to do. So let us say that I call this index name score. So I create an index whose name is name score. Then I also need to specify what are the columns that I'm creating that index upon. So I'm creating that index upon columns that are name and total score. But these columns can be present on a large number of tables, right? These columns can be present in a lot of tables. How to decide that which is the table I'm talking about? So I also need to mention the table. So I will say on students, name, and total score. So if I run this particular query, it will create an index upon these two things. What is the disadvantage of an index though? The disadvantage of an index is that it needs extra space, but that is fine. An extra space is not a big issue, but it can slow down writes. So let us say that, okay, let us say we don't know about B trees or B plus trees, but you had to actually implement an index yourself. Okay, if you had to implement an index yourself on this particular thing, you can say that, okay, I will always maintain this table in sorted order of table score. And then if insertions happen on this particular table, what will be the time taken to insert? It will be linear, right? So because you always need to ensure that the table is sorted, so then you can't do it in in order of one or in constant time. So indexes can slow down writes because they need to process the new data that it achieved. Okay, that is an issue with indexes, but otherwise they are actually always beneficial. Okay, great. Now, what kind of indexes can be there? The indexes can be of two types. There are two ways in which you can classify indexes. The very first way in which you can classify indexes is unique and non-unique index. What does unique index says? Unique index basically allows you to maintain that if a particular data is if there is a duplicate in a particular column or in a particular set of columns of the data. Suppose you have a data in which you want to always ensure that no two no two students have the same name. No two students have the same name. How can you do that? To do this thing, you can create a unique index on name column of students, right? So what will happen is that at any write, whenever a write happens, it will check the index if a constraint that was set in any of the index is being broken or not. Okay, if we had not indexed this thing, checking this would have been a more complex operation or a more computationally expensive operation. But as we have maintained an index over that particular column, it immediately allows me to check that if that constraint of uniqueness is being broken or not. Okay, so unique indexes are there to ensure some constraints in there. Then what is the definition? Why is there a need of non-unique indexes? Non-unique indexes exist to speed up the query. So while unique indexes, the main purpose of unique indexes is to maintain the constraints or data integrity, right? They need to ensure that the data integrity is maintained, but the function of non-unique indexes is only to speed up the queries. Okay, and that is the biggest advantage that non-unique indexes have. Okay, now there is also another way in which we can classify the indexes. This way is known as clustered and non-clustered indexes. Okay, the very first thing that I told you was that, hey, a relational database is not a table, but it's a set. Okay, so that means there is no definite order in which the data would actually be stored in memory, right? It could be stored in any way. Okay, now if I tell you that my query is always to select people in order of their roll numbers. If I say that I have a student table again, okay, I have their roll number, and let us say that I have their name. And I tell you that my queries are always going to be selecting students in the order of their roll numbers. But as the databases are set, so the roll numbers can be arranged in any order. So 3 can be here, 2 can be here, 4 can be here, and like this, name is A, name is B, name is D, let us say name is C. Okay, so data can be arranged in this order, but I tell you my queries fetch students always in order of roll numbers. Now, what would you like to have? Will there be something that makes immediate sense that, hey, if my queries are always fetching data in the order of roll numbers, should I arrange my data in the order of roll numbers? If I have arranged my data in the memory in the order of roll numbers, it will speed up my queries, right? Because then I need to just iterate over the data and I'm done. Okay. So what clustered indexes allow you? Clustered indexes, they change the way data is stored in the database as per the index. So if I create a clustered index based upon roll number, what will it basically do inside the memory, inside the storage where the data is actually stored? This will change to 1, 2, 3, 4, and 1 has C, 2 has B, 3 has A, and 4 has D. So now, if my queries are always in the order of roll numbers, they will become very fast. Okay, so that is what clustered indexes are. But what are non-clustered indexes? Non-clustered indexes maintain a separate data structure to optimize queries. Let us just see only this definition of clustered indexes. If clustered indexes change the way in which data is stored in the memory, can I have more than one clustered index? No, right? Because if I have more than one clustered index, then I need to store the data inside the memory as per the conditions of two indexes, which is not possible, right? Because there can be only one way in which I can dictate the order the data has to be stored in the storage, right? Okay. So one issue with the, or basically one thing with the clustered indexes is, the very first thing is that there can be only one clustered index, while there can be multiple non-clustered indexes. Okay. The second difference between clustered and non-clustered index can be that the clustered index changes the order. Clustered index affects how data is stored in memory, while non-clustered indexes don't. Okay. 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 Let us say that we have these two things. If we have a clustered index upon a particular column, and also if we have a non-clustered index upon a particular column, which of those do you think will be faster? If we have a clustered index, basically because clustered index is actually directly affecting the data set, right? And it is storing the data in the way you are assessing. Also, you have a non-clustered data set. Which of those do you think will be speeding up the queries more? Obviously, the clustered index will have even faster queries, right? Clustered indexes have faster performance with respect to non-clustered, okay? Because in a non-clustered index, you actually first talk with a different data structure, and then that data structure depicts that, okay, now fetch this data, now fetch this data. Whereas in a clustered index, the data itself is stored in that manner, and thus it helps you to speed up those queries. Okay, great. Now let us actually talk about something called as views. What are views? What a view is, let us say that I need to have one source of truth. Okay, so I say that there is always one source of truth, and a lot of times I'm storing data about students again, let us say, and I am also storing their gender. I have students, suppose I have their ID, I have their name, I have their batch, and I have their gender. Okay. Okay, so let us just write few things. A 2020, gender can be male. 2, which can be P, which is 2020, gender can be female, and P can be A, let us say C, whose batch is 2018, who can be, let us say, again female, and 4 can be T, 2019, can be male. Okay. Okay, so this is the data that we have. Okay, now what I tell you, that there is one person in my university who ensures that whose job is to ensure to do data analysis upon the data of females. Okay, suppose her job is that, okay, let me actually analyze the data of females, do some operations with it, try to find out some information from it. Okay, how can I ensure that the repeated task of that particular employee in my company, whose task is only to just do multiple queries upon the data of females? Okay, so this is students. Then one way can be that I create another female students table. So one can be that I create another female students table, and that female students table will be like this: name, batch, gender, and then there will be 2 P 2020 female, then there can be 3 C 2018 and female. That is one way in which you can do that. Do you guys realize that there is some issue with this? There is some issue in which the data is being arranged here. The issue with that is, now if a new student gets added, suppose there is a new student that gets added whose ID is, let us say, 5, name is E, batch is, let us say, 2019, and she is also a female. Now we don't just need to put the data here, but we also need to put this data here. Okay, and if by mistake you forget to put this particular data at this side, then the employee whose job was to ensure the data, to do some operations or analysis over the female data, will go wrong. Okay, so what would you ideally like to have? You would ideally like to give the employee who is working upon the female data a view, a subset view over the students data, right? That hey, he can see what is the data of students, but only that subset of the data of students where the gender was female, right? That makes sense. How can we do that? We can do that by creating a view. So a view is nothing but a select statement, is nothing but a select statement that that gives an intuition of a different table, an intuition of a different table, while in reality data is present only at one location. Let us see how this works. Like, suppose we have this data only, then what will a view do? A view will actually, let us say that this is, it kind of like is a camera over that thing, that okay, it allows you to see this thing but with a filter. It allows you to see this thing but with a filter. So here, this view is, let us say that the female students is no longer a table, but female students is a view. This view behind the scene is just running a select query, which is just selecting those students from the students table that have gender as female. But the employee whose task was to work upon female students can now use it as she would have instead used a female students table. That is what a view does. So view basic. And now what would happen? Now if you ever do a write here, now if you add a new thing, you just need to add it here. As soon as you add it here, this view will automatically get updated because there is only one single source of truth. Okay, awesome. Now let us discuss some of the, like how can we do the where clause? Okay, like we have a where clause, right, that we have discussed. One way in which we have used the where clause till now is using equal to, right? Using directly checking for equality or checking for less than equal to and all those things. Let us discuss something called as wildcard patterns and other things that you can use in the where clause. Okay. So where clause, let us say pattern matching. Okay. So in where clause pattern matching, let us discuss different kind of things that can happen. The very first thing is wildcard patterns. Suppose a complaint comes to you about a person, and the person who actually did the complaint didn't know the exact name of the person who did the crime. Okay, and then what he tells you that I just know one thing, that hey, his name starts with KH. That's the only thing that you know. Now you can't just do a DB query. You can't just do a SQL query where name is equal to KH, something like that, right? So you would like the name. So you want to do a SQL query where name starts with KH. Okay, how can you write such query in SQL? In SQL, you can have pattern like K percentage. What KH percentage means? This means KH and followed by any sequence of vectors. This can represent KH. This can also represent KHA. This can also represent KHAY and similarly, right? Great. So this is what a percentage or a wildcard pattern is. So how will you use this wildcard pattern? Suppose the task that is given to you is find all students whose name begins with KH. Okay, suppose this is what the data that is, like the question that is given to you, and the data set is something like this. This is the student table, and in this student table, you have an ID, you have the name, and you have, let us say, batch. That should suffice. So there is a student with ID 1 whose name is Khyati, and the batch is 2016. Then there is student name number 2 whose name is, let us say, Aman, and whose batch is also 27, let us say 2017. Then there is student 2 who is Khayal, let us say, that might also happen. Then his batch is 2016. You need to find all the students, and let us say that there is also one more who his name is Kamal. Now, what will this query do? So we need to find all those students whose name starts with KH, right? Whose name starts with KH. So that means we need to return this, we need to return this, and that's it. Okay, we don't need to return this because this starts with KA. So what SQL provides you? The SQL provides you first the wildcard pattern, and the second thing is a like statement, is a like keyword. So you can write thing like that, hey, select star from students where name. See, when we actually know the exact name, we use the equal to sign, right? But now we don't know the exact name. So instead of equal to sign, we have to use like, where name like, and then I will say KH percentage. I hope that is clear. Okay. Now, rather than finding all the students whose name is KH, I tell you that, hey, the question is changed, but I need to find all those students in between their names. Suppose AMA is coming. Suppose I need to find all the students that have AMA in their name, anywhere in the name. I mean, like, it might not be the starting characters, it might not be the ending characters. What can be a real world use case? Suppose what do we say that, okay, I mean, like, an examination is going on, and the invigilator finds a chit, and the invigilator finds a chit. On that chit, the name of a person was written. It was AMA. Now the invigilator wants to know who might be the students, who would have done, whose chit that might be. Okay, so now you need to find all those students that had AMA in their name. How can we do that? To find all those students that had AMA anywhere in the name, we can write percentage AMA percentage. So what this percentage symbol is representing, basically, if we see from this particular thing and from this particular thing, is any sequence of 0 or more characters. Okay, so this percentage AMA will match Aman. This will also match Naman, but this won't match Amit. Okay, so what can we do? We can just write a statement, select star from students, where here we wrote where name like this. So here we can write where name like percentage AMA. Now we had also discussed a thing, like I mean, like, in the very beginning of this video, that if we want to remove a subset of the queries from my statement, right? So I had used a not keyword, right? I had used a not keyword. What this not keyword allows you to do, this not keyword allows you to omit those results present in something else. So let us say that my just query just changed. I somehow know that, okay, the person who had did this, I mean, the person who did this thing, his name just doesn't have AMA. That's the only thing that I know. Okay, then what can I mean, like, how can I find all those students that had, how can I find all those students that didn't have AMA in their name? I have to find all those students that didn't have AMA in their name. I can just use this not keyword. I can say select star from students where name. First we were doing where name like. Now we don't want the name to be like something, right? So we can say where name not like percentage AMA percentage. So if we run this query, this will return Amit, but this won't return Aman. Okay, now we have discussed three things. We have discussed percentage at multiple places. We have also discussed not. There is also a specific sign, okay, a wildcard for a specific position. That is nothing but the underscore sign. Okay, what it says, suppose I want you to find all those people, all those students, the third character in whose name was, let us say, M. Okay, so if I only want you to find all those students, the third character whose name was M, but anything else can be anything else. Okay, so I want to return Naman, and I want to say, let us say that there is something called Lambot. I need to return this as well. I need to return this as well, but I don't need to return Amit. Okay, suppose this is what I want to return. Okay, so how can I do that? I know that the first two characters can be anything. Then there should be an M. Then there can be any number of remaining characters. Okay, if I write percentage M percentage, will this work? No, this won't work. Why will this not work? Because this will also return Amit. Because Amit also satisfies percentage M and all this as percentage. So what can I do? I can say that the first two characters should be underscore. So underscore matches any character, any single character. Okay, so first two characters should be underscore. then there should be an M, then there should be percentage. What this means is that the first two characters, so that numeric value, that there should be a percentage, then there should be an M, that should be a percentage, that is fixed. So I can find all those students who had the third character as M by something like select star from students where name like slash underscore underscore M percentage. Okay. Now let us take talk of another question. Let us talk of a question where I had to return all those students whose name had more than 4 characters. I had to return all those students whose name had more than 4 characters. How can you do that? If the name has to have more than 4 characters, we know that the first 3 characters can be anything. The first 4 characters can be anything. So we can just write that by underscore 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 underscore. That means the first 4 characters can be anything. Then it can be percentage. I mean, there can be any number of characters after this. So a query to select all those students who had name greater than 4 characters can be something like select star from students where name like underscore 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 and percentage. Okay. So that was in wildcard pattern searching of strings in a database. Let us also talk about what kind of database, I mean, like what kind of operations can actually have can happen on a database. Because if you are using a database management system, you need to know what are your requirements, right? What kind of data that you want to have, okay, or what kind of operations happen, or what kind of requirements are there from the data set, so that you can choose a database system that actually conforms to those requirements. So there can be two kinds of database management systems that are commonly known. The first type of database management systems are OLTP, and the second thing is OLAP. So how to distinguish between these two? You can distinguish between these two types of data sets using the word T and A. Okay. What does T means? T means transactional. What does A means? A means analytics. Let us try to understand the difference between OLTP and OLAP. So as we see from the name that OLTP database is more for transactional things. Okay, what do we mean by transactional things? Transactional thing is a large number of queries, but each query is very small. Okay, I mean, like let us say that very simple thing. Let us say that I just need to select all those. I mean, like I just need to increment the value of something by 1, or let us say that I still have the students table and I have their marks as well. Let us say, so I have students tables, I have their marks. And let us say the student table has something like this: ID, comma name, comma marks. Okay, so there is ID 1, A, initially his marks are 20, then 2, B, 30, something like this. Okay, so now my queries are things like, hey, my queries something are like that, hey, insert a value or update a value, things like that. These are very small operations, but these operations are happening a lot of times. In those scenarios, you need a transactional database management system. So what that transactional database management system will need to do, it should have actually a very fast response time. You will be very sad if just to create a like, if just to submit a like, it takes a lot of time for the Facebook's database system to actually store that like in the DB and return you that, okay, you have liked that post. Okay, let me actually just tell the full form of these things. OL stands for online and P stands for processing. So online transactional processing and online analytical processing. Okay, so this is the difference between OLTP and OLAP. Okay, so in an OLTP database, I need fast response time. Okay, so my CPU requirements are not that much, but I need to be able to serve a lot of requests in very fast. Okay, so normally OLTP databases are actually distributed. Okay, because you need to serve a lot of requests or so lot of parallel requests which are normally short, so you actually distribute your load. Whenever you actually have to have a lot of small queries, the best way is that you distribute those things and have multiple different computers handle it rather than having a vertical scaling approach. Okay, whereas consider you are a company, consider you have a database of a lot of users being stored since long. Okay, and then every 2 months or every 1 month, At the end meeting, you do a very big processing over those database. You try to find all those users who had posted more than X messages, or you find all those students who had actually attended more than 5 classes, and then who had actually also solved more than X contests and solved those things. Okay, so in online analytical processing, these databases are useful for business analytics and intelligence. Smaller number of queries happen, but each query is quite complex, can be quite complex, we will say. Okay, because I mean, like, one query might be fetching from a lot of tables and doing a join between them and trying to find a lot of other things. Also, in OLAP database management systems, other things that are actually, I mean, like, if you're doing a business intelligence, visualization becomes very important, right? So visualization, etc., are common features. Okay, so in this thing, being distributed is one important aspect, but in this thing, having a large support for visualizations and other things is a more important task. Okay, now let us actually talk about a very important thing in database design. I mean, like, how will you even create I mean, like, how did we decide that what tables do we need to create, or what do we need to store in what table? How did we decide that? Let us discuss this. Actually, this is a very I mean, like, important topic as in terms of database management systems, in terms of understanding database management systems. This is normalization. Normalization allows you to have good database design. Good database design in terms of what? In terms of how we are arranging entities and relationships between them. Okay, so normalization also allows you to reduce data redundancy. Okay, let us say I had the student table again. In the student table, now I'm also storing the address of everyone. I'm also storing the address of everyone. Okay, so let us say that student has ID, he has a name, he has a city where he lives, he has a pin code, and these are the things that I need to store. Okay, so let us say that this is the database. So let us say that we have ID1, his name is A, he lives in Delhi, and his pin code does not live in Delhi because Delhi has multiple pin codes. Let us say he lives in a city XYZ that has only one pin code, and let us say that the pin code is 110001. Then let us say that there's a student 2 whose name is B, who lives in city ABC, and the pin code is 133001. Then there's a student 3 who also lives in city, like, whose name is C, who also lives in city XYZ, and the name is 110001. Okay. Suppose after a few days, government decides that, okay, we will be changing the pin code of the city XYZ. What can happen? What can be an issue in this database design, this database schema design? The issue can happen is that, hey, suppose government says that the city with XYZ will now have a pin code of 127201. Suppose this is the pin code that the new pin code of XYZ has to be. Now, if this happens, what you will have to do is you will have to go on this student table everywhere where 110001 is there. You have to change 127201, you have to change 127201, and all those things, which is a very bad design, right? What can also happen is that suppose there was also another student C, let us say T, he lived in city XYZ and had a pin code of 11001, but you somehow forgot to change this. And that's a bad thing for you. Now your data at some places is storing the pin code 127201 for the city XYZ, but at some places it is storing 110001. That means the data is not consistent. What do we mean by that? We mean irregularities in the information. So what would you ideally like to have? You would ideally like to have is that, hey, all these cities, I mean, like, the city and pin code, because a city can be recognized just by the pin code, right? So I would ideally like to have is that somewhere I'm maintaining the pin code and the city name. If I am somewhere maintaining the pin code and the city name, I can ensure that these consistency issues are reduced to minimum, right? So what will be very good for me is that, let me have a ID, name, and pin code here, or let us say, instead of having one table storing this, I can have a student table that only stores ID, that stores name, and that stores city ID, right? And I have another table, which is city table, that is storing city ID, city name, and pin code. Now we have 1A and let us say 1 here. Also we have 3C and 1. We have 4D and 1. Now we have 2B and 2, let us say. So we can say that the city ID 1 has name XYZ and has a pin code of 111001. City ID 2 has name ABC and 133001. So now if government decides to make the change, you only need to make one change, that is here. And this thing will automatically conform to new changes that happened here, right? So this is the advantage that you get by making your designs of databases very good. Okay, so these are known as normalized databases. Okay, but how will you decide that there is a need to improve the database design? Let us discuss normal forms for that. There are 6 normal forms actually, but greater than 3 normal forms are not actually used much. So we will be discussing here 1NF, 2NF, because those are more prominent. Let us discuss what 1NF says. A 1NF data, a table or a database schema design is known to be satisfying 1NF if there are no multi-valued attributes. What do we mean by no multi-valued attributes? Suppose you have a library management system, and in a library management system, you store which books have been allocated to a particular student. So you need to you have a table, let us say allocation table, in which you have a student ID and you have a list of books. Okay, so suppose there is a student whose ID is 1 and he had bought and he had rented, let us say, 5 books. So those books had ID 101, 120, 113, 120, and let us say 121, and let us say 180. Okay, so there can be a student 2 who has rented 3 books, let us say 11, 113, and 21. So on. This database schema design in which any of the table can have more than one rows is, like in which any of the column can have multi-valued attributes, because this attribute has multiple values. This is not just a single value. This is not just an atomic value. So this does not satisfy 1NF. So how will we convert this data into 1NF form? How will we convert this data into 1NF form? We can change this data into 1NF form by splitting this data. Like this. Student ID and books, and say 1, he has 101, 1, 120, 1, 113, 1, 121, and 1, 180. Similarly, 2 has 11, 2 has 113, and 2 has 21. Okay, this data, this satisfies 1NF, this does not satisfy 1NF. Okay, so that is how you convert a data set that is not satisfying 1NF into a data set into a schema design that satisfies one normal form. Let us discuss about second normal form as well. 2NF data, like the exact theoretical definition of this is that there should not be any column, or a set of columns that can be uniquely identified, by anything other than the primary key or the candidate keys. Like what are the primary keys and what are the candidate keys? We will discuss in a moment. But let us take care of this thing. Let us see the example that we had here. Let us see the example we had here. What was the primary key of this table? Let us firstly define primary key as a row, as a column value that has to be unique. For any record in the table. So for example, if we see, the ID has to be unique. Like no two students can have the same ID. That is the main source of distinguishing between any two records. Okay. So what it says is that, let us see this pin code and this city thing. Do we think here that pin code actually doesn't need this ID to be uniquely identified? Pin code can be uniquely identified if we just know the city. But city is not the primary key, right? Like pin code can be identified by the city, but city is not the primary key. That means there is a subset of columns in my schema design that can be uniquely identified without even the primary key, which is ID. So how can I convert this data set into second normal form is what we just did here. But the conversion that we had done here was nothing but the conversion of a data set that does not comply with second normal form into a data set that complies with the second normal form. Let us actually take one more example. In which we can do that. Okay. Suppose, let us say that this example is actually present also on the interview practice forum of this. So what it says is that, hey, let us say we have a student's table. We know the student ID, we know their name, and we also know if he's a Mr. or if he's a Mrs. Okay. Then we say that, okay, let us say that we have students, we have ID, we have name, we have gender, and we say that what is the salutation that we use for them. Okay. So let us say that salutation can only be Mr., Miss, or let us say it can be Doctor. Okay, these are the three salutations that are allowed. Okay, can we somehow know these three things by some other thing? I mean, like, let us say that currently I'm maintaining students like this. One whose name is A, whose gender is, let us say for now we have only Mr. and Miss. Okay, we name it A and gender is male. We have student B whose gender is female. We have student 3 whose gender is A, whose name is B. This salutation will always be Mr., this will be Mr., and this will be Miss, right? But actually what we realize here is that, hey, if we just know the gender, we actually know the salutation. So what happens if I suddenly decide that or I will call all the males not Mr. but suppose Master? I might decide that. Then I will have to iterate over the students table. and update this which is, and that can lead to consistency issues. So this is where, I mean, like, if these are the two columns that can be uniquely identified by something other than the primary key, we split these set of columns into a different table. So we split this by only maintaining gender here. So let us say that we are maintaining ID, name, and we are maintaining gender ID. Okay, so we are saying 1, 2, 3, she is A, he is B, he is A, then gender is 1, 2, 1. Then based upon gender ID, I can store the name. I can also know the salutation. So I can say that gender ID 1 is male and the salutation is Mr. And the gender ID 2 is female and the salutation is Miss. So this is how I convert a table or convert a schema design that's not into the second normal form into something that is a second normal form compliant. Okay, great. Now let us discuss one last thing before we actually end the today's lecture is something called as procedures. Okay, something called as procedures. In normal functions, when you would have, I mean, like in normal programming that we do, we don't just write code sequentially, right? We don't write code sequentially, but we actually make our schema design procedural, right? We say we have a function called print this, we have a function called do specific task to ensure that a SQL I mean, like code, that means our normal program is modular. Okay, that should look modular. Okay, how can we do the same thing in SQL? In SQL, we have something called procedures. Procedures are nothing but select statements. They are also select statements that can be identified by a function call. We can create procedures, and each procedure is doing nothing but a select statement. Okay, so each procedure is doing nothing but a select statement. They are select statements that are identified by the name. Now, these procedures can be something that also manipulate the data, right? They can actually change the data as well, that whatever is in the data set at that particular location. So suppose there can be a procedure, or this can be update statements, modification statements. Okay. So one example for that can be, suppose this was the thing that happened, that hey, you decided to call all males master. Okay, suppose you decided to call all the males master. Now what you will do, you can write a procedure. You can write a procedure which is called change salutation. It can take in gender and it can take in new salutation, right? and then this recursively runs the SQL query and then changes it. Okay, now when we are actually discussing this, let us actually discuss what kind of SQL statements we had, what kind of SQL statements that we had. And let us actually parallelize its intuition with how you build a house. When you are building a house, what are the things that you need to do? Okay, I mean, like when you are building a house, first you need to decide that, okay, how will my house look like, right? How will my house look like? So that is basically definition. Okay. Then the second thing can be who will live in the house, right? Who will live in the house? Okay. What can be the other things? The other thing can be you put something in there, right? You actually put some value there or put some data here and all those things, right? So the other type of queries can be that, hey, you manipulate or you change the design, that you say that, okay, I will put one more thing in the kitchen or I will do these things. Okay. So those can be what we say controlling it, or we can say it as modifying it or manipulating it. Okay. And what can be the fourth kind of thing? The fourth kind of thing can be that, hey, you have manipulated, you have queried, you have I mean, like you have defined the thing, you have queried, you have manipulated. You also say that who is the control, who is going to control the thing. I mean, like who has what assets. So these are the four things that are actually I mean, like in SQL, these are the four kind of statements that exist. The very first kind of can be data definition language. These statements allow you to define how my data is going to look like. That, okay, this is going to have something like this is going to have something like these statements are create and all the statements. Okay, these can be create, these can be drop, these can be truncate. I should not truncate is not actually a data definition language. Then the second thing can be query. For querying in a database, what are the statements that we had actually used? One most prominent statement that we used for query in a SQL database was select. So that is a SQL statement that is used for selection, for query, right? And the third thing can be manipulation. These manipulations can be insert, update, and all those things, right? Insert this, do this, and all those things. Okay. What is one more important thing? One more important thing is who actually has access. Who actually has access to my table? Because data is very private, so you can't give the access to everyone, right? So you need to have some kind of control of who has access to the data. So I mean, like in a SQL, the database administrator actually gives you a control that, okay, there is a user this who can actually create I mean, like who can actually write to this data, or this user cannot write to the data but he can only read. So these control statements can be grant and revoke. So in a SQL, all the statements can actually be segregated into these four things. There can be a definition statement, which can be creating, dropping. This can be querying, which can be like select. This can be manipulation, inserting something or updating something. And these can be controls. These controls are allowed, I mean, like these control statements are there to, I mean, like give some read rights, read rights, or only write rights and all those things to the database management system. Okay, so these are the four things that are there in this. Now let us actually discuss some, I mean, like some tricky kind of thing. Let us discuss one tricky question that is normally asked in a database interview, and then we will. The question is that, hey, you have to create a new table with structure, with exact data structure of another table. Okay, suppose there is a table called students, and you don't know that there is a table called students. You don't know this. Okay, so there is a table called students, but you don't know what is inside this table. So there is, suppose, ID, there is name, there is 2 3 more things, but only you know that there is a table called students, and you need to create a table called students copy, which should be having the exact same structure as the students table. Without knowing that, what is the structure of students table, how can you do that? So this is actually a very tricky question that is normally that can be asked. So what this, I mean, like how can you do this thing? Anyone has any ideas here? Let us try to see what a select statement was doing. Select statement actually returned me whatever the data was present in my table, right? So if I don't know students table, at least I can run this select query to get the data in that form, right? So I can still get select star from students. Okay, but then what will I do? Now I at least know that what is in the data. I mean, like what is the structure of students table, but what should I do now? I mean, like, what can I do? I need to store whatever was the structure that came from here into some other table, right? So SQL allows you another keyword which is into. I say I select star into student copy from. Now where am I selecting from? I'm selecting from students, right? Okay. What will this thing do? What will this statement do? If my statement is only this particular thing, what is it this going to do? Into does nothing but copy everything that was in the first table as it is to the next table. Okay. So for example, if students table had 1, 2, I mean, like 1A, XYZ, 2B, ABC, and 3C, DEF. Okay. So this statement, I mean, like, this is the students table. This statement will actually just copy everything as it is into the students copy table. Okay. But I don't want the data. I only want this structure. I only want this structure. How will I do that? I can say, I mean, like, because I have written a select statement, then I can have a where clause, right? Then I can have a where clause. Okay, I will have a where clause, but what to put in the where clause? I need to put something in the where clause such that none of these rows actually get carried forward here. So what? So I mean, like, the statement should be something that is always false, right? That is always false, so that nothing from here gets carried forward here. So what can that statement be? I mean, like, one very hacky thing is where 3 is equal to 4. This statement can never be false, right? This statement will never be true. This is always false. So select star, when the select star thing gets the table structure, it creates a new table, student copy, because you are putting into here. So it creates a student copy, but because the where clause was never satisfied, we actually never put anything there. Okay. Or actually we could have done where 0 or where false. That would have also worked perfectly. Okay. Great. Now let us actually discuss some of the aggregate functions of the in SQL that are present in the SQL, because that is something that people tend to miss out, because I'm like, otherwise you have to see the documentation. Let us quickly discuss that, and then we will be ending the today's session. So let us discuss aggregate functions in SQL. Okay. So let us just list them down, and let us see what those are. The very first function can be average, AVG. So this function takes in a list of values. And returns the numeric mean of them. Okay. One more function that we had actually discussed in the beginning of the lecture, in between the lecture, was a count, right? Count statement returns just the number of rows or the number of records that are satisfying that particular statement. So if I just do select count of star from students, what will this do? I'm saying the count statement just returns the number of records that satisfy my select statement, right? So if I have select and I'm saying select everything from students, so what is the count of everything? This is nothing but number of students. So one hacky way to get the number of records that you have is just select count star of students. That was perfectly fine. Okay, let us discuss other functions. That is min. Min also works upon a type of data. Then there is max. Because there is average, then obviously there also has to be a sum. There is first and last. What are the first and last doing, by the way? I mean, like, people tend to get confused by first and last. What is the, I mean, like, how are they going to be decided? They are going to be decided by the order in which the rows are returned. So the first will return the first element in the order in which select statement would have returned the values. Are null values counted? Yes. I mean, if the whole row is null, but it is still present, so yes, that will be counted, because that record is still there, unless you have maintained primary key constraint, in which that case it will anyway fail, right? Yeah. So similarly, the last fetches the very last particular record for that particular element. Okay. When we were in the middle of the lecture, what we found about that? What did we observe about these aggregate functions? These aggregate functions allow you to these aggregate functions allow you to group by. I mean, like they are used with group by and having, right? So these are the aggregate functions when you aggregate upon something, when you are doing an aggregate. So let us say I am going to take average of all males. Suppose the question that comes to you is that, hey, given a student table where student table is something like ID, name, gender, and score. Okay, you have to return average of males and females respectively. Okay, so the very easy question, very easy version of this is that, hey, I just need to return the average of all the students. In which case you can just do select average of score from students. But now you have to select average of males and female in different groups. How will you do that? In that case, you will have to group those students by their gender, right? You will have to group the students by their gender. So you will still have to select average of score from students. But now all the students are not one group. All the students are not one single group. There are multiple groups. And how are those groups being made? Those groups are being made by their gender. Okay. Select average of score from students, group by gender. Okay. So this is how the group by statement comes into effect. I hope that is clear. Okay. Now let us actually discuss these are the functions that are aggregate functions. These are working upon a set of data. There are also other functions. Like many people feel that, okay, it's very difficult to, like it's normally a better choice to use a programming language along with, like SQL. Otherwise, it's difficult to write a lot of things. But actually, SQL has inbuilt scalar functions. So what are those scalar functions? These take in one value and return one value. So basically, like in multiple programming languages, suppose you have a capitalized function, right? Suppose like in, let us say in Python, you have a capitalized function. Actually, let us write those functions in SQL only so as to not confuse people. So let us, in SQL, there is a function called uCase. If this function is nothing but this takes in a string and returns uppercase version of the string. Similarly, there can be lowercase as well. Okay. Then there are multiple other functions. There are concatenation of different strings. Then there are some mathematical functions which are actually useful. These are rand for random. Then there are round. One of the most important functions that I've actually personally used in my, in real life environment is the timestamp functions. So if you are working with, let us say, data warehousing solutions like Redshift and all those things, timestamp SQL functions are very actually useful. So these can be like to timestamp. Then there can also be now function that returns the current date and time. So one thing, most people think that SQL is just about the query language, it's just about querying, but it actually has a very strong set of inbuilt functions that are available directly that you can use and do a lot of tasks that you can actually probably do with only programming. Obviously you can't do a lot, many of them, but it's more than what normal people think to be. Okay, one thing actually we missed out in the medium of the lecture was keys, right? We actually missed discussing them in detail. So let's just throw a brief light on them and then we'll be ending it. Let us discuss primary keys and foreign keys and how to create those and foreign keys. Even before we discuss primary keys, let us actually discuss a term called as candidate keys. Candidate keys are a set of column values which can uniquely identify every other value. Select a set of columns, actually, set of columns which can uniquely identify every other value in a record. What do we mean by this? So basically, let us take care of a student's key. Let us take care of a student's table again for the last time. So let us say the student has an ID, he has a name, and let us say he has marks. Okay, and that's it. Or let us say even as a gender. Okay. So let us say the student with ID A has name A, score 20, and gender M. Then ID student 2, he has name B, he has score 30, and gender female, he has student 3, he has name C, 31, and male. Okay, so suppose I just tell you the ID of the student. if I just tell you the ID of the student, you can directly go and say that, okay, the student with that ID had this name, had that score, and that name. Okay. So I mean, like, if you just know the ID, you can know all these three things, right? Let us only consider this table, the current values in this table. Do you think in this current value, name will also be uniquely able to identify all the other attributes? If I tell you that please get me data where name is A, please get me data where name is A, will it be able to uniquely identify all the values? Yes. In the current set, it will be able to, because there is only one person with one name. So A has only one person, B has only one, C has only one. So if I only know name, I can directly get the score, I can directly get the gender, directly get the gender, and directly get the ID. Is gender enough? Is gender enough to get the data? No. Gender is not enough to get all the other values of the data set, because there are multiple people who have the gender male but have different name, different ID, and different scores. So the columns, that is for this example, name and ID, that can uniquely identify every other values are candidate keys. So candidate keys can be a single column or a set of columns. What is primary key then? Primary key is the key that the DBMS uses to uniquely identify a record. Okay. It can also be a single column, or it can be group of columns. Okay. So let us see the student and books table that we had actually written above, right? Above we had actually written a student table where what we had was that, hey, which student has rented which books. So there we had a student ID and book ID, right? So if student 1 had taken book 201, he had taken book 202, he had also taken book 203. Then student 2 has taken book 101, he had also taken 202, he had also taken, let us say that there is a student 3 who has taken 203. Suppose these are the students and this is the table. What do you think can be a primary key of this table? Can it be only student ID? Can it be only student ID? No, because there is no, I mean, like, if I just tell you student ID, you can't uniquely identify the value. This student ID is associated with this book ID. I mean, like, there is this thing, this is also associated with this is also associated with this. So basically primary key can be I mean, it can be the set of columns whose value, if you know, you can uniquely identify a row. You are guaranteed to return a single row. Okay. So for this particular table, the primary key will be student ID, comma, book ID. Both the columns together constitute the primary key. And let us actually discuss how will we create a primary key. I'm like, in a sequence statement, how will we create a primary key? To create a primary key, you can either do, the very first way in which you can do that is while creating table. So while creating table, you can do create table. You tell the name of the table. Let us say that the name of the table is students. You create table students. In this table, we are actually maintaining student ID and book ID. Let us talk about this thing. Let us say here we maintain the ID as this. Okay. So when we create a table, we have to tell what is the name of the column. And then we also have to tell what is the data type of that column. So let us say that ID is an integer. Okay. And I mean, like, let us for now keep it as it is. Then we say that, okay, we are also storing a name. Name is nothing but a string, right? In SQL, a string is a varchar. It's a variable character of how many characters max? Let us say it's 255. So at max, that can be 255 characters. And then here we have, let us say, score, which can also be an integer. And let us say we finally have a grade. I mean, like, let us say we don't have a gender for now. Okay. Then we have to decide the primary key. So we can write primary key, and in the parenthesis, we set what that primary key is. Okay, that is one way. While we create the table, we actually write what is the primary key going to be. But suppose you had actually created the table and you forgot to add the primary key. What will you do? If you forget to do something that you had actually written while creating a data or while defining the data, you can use the alter keyword. Alter keyword is used to alter the initial data definition that you had done. So you can do alter table students where and you first you say that I am now going to alter my table. So that means I'm going to add something to it. what I'm going to do, I'm going to add primary key, and that primary key is going to constitute only ID. That is how I use the alter keyword and get this particular thing done. Okay, so that is about the primary keys. Let us actually briefly discuss, I'm like, before we come to foreign keys, let us actually briefly discuss the constraints. Okay, so I also want that, hey, I tell you that there should not be any student whose name is empty. Okay, I don't want any student whose name should be empty. Okay, that means I want that student's name should definitely be present. So SQL provides us a list of constraints that we can use upon our data definition. Okay, so one of those constraints can be unique. Then the other constraints can be not null. Then there are other constraints like that can check a particular value. That, okay, unique constraint says that value in a column or a group of columns should never be duplicated. Okay, not null says value should never be empty. Then one of the constraints that we have discussed is primary key. That primary key by default says that it should be unique and it should be not null. Okay, then there is also one more constraint that we can say default. So I tell that, hey, if I somehow miss to give the value of a particular column, please set it to this value. Please set it to the default value. Okay. Then one thing can be check. This check statement can actually verify that a value is satisfying a particular condition. For example, I can say that suppose I also had a gender here. So I can say that it's a gender and it's in character. Okay. Then I can maintain a check that, hey, gender should be only M or F. Okay. So this is what this is what we maintain by gender, that, okay, I put a constraint that, okay, I can't, there's no predefined constraint. So let me actually create my own constraint that, hey, the value of gender should only be M or F. Okay. And the next, there is also one more constraint, which is the foreign key. And let us discuss this foreign key constraint now. Okay. So what is a foreign key? When we actually were creating the original thing, when we actually created the employee table in above, what we had actually done, we had two tables, right? So the very first table that we had was employee data, in which there was an employee ID, his department, and let us say his title and all those things. Okay. Let us say we had this table. And the second table was, let us say, employee salary. And this had employee ID, and this also had salary. Okay. So if we have these two things, does it make sense? Does it make sense that, hey, there is an employee, but an entry corresponding to him is not present in the employee salary table? Does that make even any sense? No, right? Because if there is an employee here whose department is, let us say, tech, and his title is, let us say, CTO, then there can be another ID 2 whose department is, let us say, program management, and whose title is, let us say, let's say it's a general one, it's program management 1. Then there can be another person 3 who is also a program manager, let us say his title is PM2 and all those things. And let us say there's 4 who is in tech and he's software engineer 1. Let us say these are the rows that we have, and corresponding to ID 1, I have a salary, let us say 200. 2000, let us say, and I have a salary 2, they have 3000. I have a salary 5, I have 6000, and I have a salary 3 who is, let us say, 4000, and I have a salary 4 who has, let us say, 2000. Does this make any sense? There is a salary of an employee, but that employee does not exist. This does not make any sense, right? There should not be, there should not happen that, hey, in employee salary there is an ID, but that ID is not present in employee, right? So we need to ensure that if an employee salary is present here, that employee ID should also be present here as well, right? So we can add a foreign key to the employee salary table, but what should that foreign key reference to? That foreign key should refer to the ID column of the employee table. Okay, so what can it do? It can say, how can we add this? I can say that, hey, when I create the employee salary table, I say create table employee salary. Okay, when I'm creating the table, I need to have an ID. Then I also, this is an integer. Okay, and I also need to have, let us say, the salary, which is also an integer. Okay, now I need to add a foreign key. What is the foreign key upon? Foreign key is upon this ID, right? Foreign key I add upon this ID. But what should this foreign key refer to? What should this foreign key refer to? This foreign key should refer to ID in employee table, right? So I say foreign key ID references, this references employee ID. Okay. So this is how I create a foreign key. If I forget to create foreign key, I can just, like we add primary key later, we can do alter table foreign key, alter table employee salary, alter table employee salary. And then what I do, I have to now add a foreign key, right? So I add a foreign key. I add a foreign key upon which column? I add a foreign key upon the ID column, and this references employee ID. Okay. So this is how I can add a foreign key later as well. Okay. By the way, like anytime when we have to do a modification to the data, whenever we have to do any modification to the data, we actually have to use this alter command. This alter, as we know, is a data definition thing, and this can actually, like alter the table, alter the definition of the data. This allows you to do that. Okay. Okay. Finally, I think there is one more confusing thing that I actually saw someone in the comments. What is the difference between drop, delete, and truncate? What is the difference between these three things? Like these three things in English wise mean the same thing, right? These three things mean the same, that okay, you are deleting something probably. Okay, but is there any difference between these things? Why does SQL has these three things? Like why? Okay, so the difference between these three things is that, hey, delete is used to delete a row from a table. Delete is just opposite of select. Okay, in select statement you select some set of tables to view, but in delete command you select a particular set of records to remove them from your SQL table. Okay, so like what you can do is, suppose you have to delete all those students. Like suppose your university decides to remove all the students who had less than 40 marks, so what less than 40 scores. So your university can do delete from students. Okay, then you can use everything here where what you use in select statement. So you can use everything here. So you can select where, let us say, score is less than equal to 40. This will do what? This will just remove every, like every data from the student table, from the students table that had a score in which a student existed who had a score less than equal to 40. That is a delete command. Then there is also a truncate command. What this truncate command is used to do, this deletes all the rows. This deletes all the rows. But table is still there. But table and its definition, constraints, everything is there. Definitions, constraints are still there. And then the final thing is drop. Remove every existence of the table. Okay, remove complete existence of the table. So let us actually give you an intuition of this with a diagram. Okay, suppose we had a table like this, in which we have an ID, in which we have a score. Okay, let us say we have an ID 1 whose score is 50, ID 2 whose score is 60, ID 3 whose score is 20, ID 4 whose score is 10, ID 5 whose score is 70. Okay, let us run three commands here. Let us run, and this is ID and this is size. Okay, this is suppose the table, and let us say the first command that we run is the delete from students where score is less than equal to 40. What will this return to? This will change it to ID and score, and this has 150 because this is there, 260 and 570. Okay, other things will get deleted. You do truncate. If you do truncate, you are only remaining with ID, score. No data is remaining. Okay, nothing else is remaining. And if you do drop, nothing is remaining. Like there is complete empty thing. Nothing is remaining. Yes, Rahul, where clause can be applied in delete. That is what we have written here, right? Yeah. So let me actually give an example of how to write the truncate command. To completely remove the students table, you can do truncate table. Like to truncate all the data that is there in this. So you can do truncate table students, and to remove the students, like to go into this thing that there is no existence of students table at all, you can do drop table students. Okay, so they completely remove the data, or the second thing, the drop table actually completely removes the whole existence that is there of that data. Okay, yeah, so that's all that I had from my side today. I hope you liked the session. It went for around 2.5 hours. So yeah, thank you for being a very patient listener. And okay, and by the way, guys, I mean, like we have actually a very, I mean, like all these things we have actually written into a well-defined article as well on the Interview Bit platform. So that is present on this particular link that I just pasted on the chat. So please, I mean, like if you want to practice all these SQL statements, you can actually write those SQL statements there and see if the code, if the SQL code that you wrote was also good. Okay. Yeah, awesome. Have a good night. Please stay safe and stay healthy.